Good morning, guys. All of you, welcome to Ashok IT. So, my name is Ashok. Today, we are here to understand one very important topic for Java developers, that is Java Microservices Development. So, as part of this session, we are going to learn first what is monolithic architecture, what is monolithic architecture, and what are the challenges available with the monolithic architecture. Then we are going to understand what is microservices architecture and why microservices architecture came into market, and what are the advantages available with the microservices architecture. What is monolithic architecture and what are the challenges available with the monolithic architecture. Then we are going to understand what is microservices architecture and what are the challenges available with the microservices and what are the advantages with the microservices. Then we are going to learn about service registry. What is the meaning of service registry? Some people also call it as a discovery server. So in the real time, some people also call this as discovery server or discovery service. Service registry or discovery service, both are same. Then we are going to understand admin server. What is Spring Boot admin server and why we need to work with that admin server. Then we are going to understand what is Zipkin server in the microservices. What is the meaning of Zipkin server and why we need to use that Zipkin server and how to work with the Zipkin server. Then we are going to understand APIs development, REST APIs development, how we are going to develop our backend REST APIs by using Spring Boot. And when we are developing backend REST APIs, how to establish inter-service communication among those APIs. What is inter-service communication? What is inter-service communication? How to establish that inter-service communication by using Feign client. Okay, then next one, we are going to understand what is API gateway, which is used to perform pre-processing of a request. Inside this API gateway, we are going to understand routings and filters, how to route the request from the API gateway to the backend services. API gateway is going to act as a mediator between the incoming request and the backend APIs. So how to implement routings in the API gateway, how to implement filters in the API gateway, we are going to understand. After this, we are going to discuss one more important concept here, that is cloud config server. We are going to understand one more concept called cloud config server, and based on all these topics, we are going to develop one mini project also. By using all these concepts, we are going to develop one mini project also. This is the agenda for today and tomorrow session. Java Microservices Development. So in the real time, application can be developed in two ways, guys. In the real time, application can be developed in two ways. What are the two ways to develop our application? One is by using monolithic architecture. Another one is by using microservices architecture. A project can be developed in two ways. One is by using monolithic architecture. Another one is by using microservices architecture. What is the meaning of monolithic architecture? Develop all the functionalities. Develop all the functionalities in single application. If you develop all the functionalities in one single application, then that application is called as monolithic architecture application, single unit. For example, in my application, net banking is available, net banking functionality is available, mobile banking functionality is available, credit card functionality is available, debit card functionality is available, okay, educational loans available, property loans available, and mortgage loans available, gold loans available. So there are n number of functionalities available in our application. If you develop all these functionalities as one single project, then that project is called as monolithic architecture based project. So can you read this point? what is the meaning of monolithic architecture? A monolithic architecture is a software design pattern where all components of a system are integrated into single unified application. So a project nothing but collection of requirements will be available, several functionalities will be available. If you develop all those functionalities in one single application, then that application is called as monolithic architecture. So if you develop your project by using monolithic architecture, there are some challenges available. There are some challenges available. What are the challenges available with the monolithic architecture? Problems with the monolithic architecture. What are the problems available? The first problem, tightly coupling, because everything is available at one place. Everything is available at the one place. So the project will have tightly coupling problem. So the project is going to have tight coupling is available, tightly coupling. So if you want to change any small functionality, then it may impact on the other functionalities because everything is available at one place. Everything is available at one place. If you make a minor change in a project, that may affect on the some other functionality because several functionalities we developed in one single application. If you make a minor change in the application, if you make a small change in the credit card functionality, okay, so credit card functionality available, debit card functionality, loans functionality, net banking available, mobile banking is available. All the functionalities are developed as one project. So many classes are available. If you make a modification in the existing functionality, in one functionality, if you make a modification, it may impact on the other functionality. So that is the reason when you go for monolithic architecture development, the project functionalities are tightly coupled. The project functionalities are tightly coupled. Because of this tightly coupling, maintenance problem. Maintenance is difficult. The project maintenance is going to be very difficult when you implement that project by using monolithic architecture. If you want to make a minor change in the application, it may impact on the some other functionality. If you make a minor change in the application, it may impact on the some other functionality also. If you make a minor change in the application, it may impact on the some other functionality also. Maintenance of the project is going to be difficult. And what is the another problem? The another problem is redeploy entire application. The another problem, redeploy entire application. If you make a small change in the application, then you need to redeploy the entire project. I made a minor change to the credit card functionality. If you make a minor change to the credit card functionality, you need to redeploy the entire application here. You need to redeploy entire application. So the deployment risks will be available. Okay, first problem with the monolithic, the project is tightly coupled. Everything we developed at one place. Then as everything available at one place, the maintenance of the project is going to be difficult and we need to redeploy the entire application. And the next one, this project is technology dependent. The project is technology dependent. So that means if you develop your application by using Java, then all the functionalities you need to develop by using only Java. So you can't use different technologies to develop one project. So it is a single project. Everything we are developing in the single project. So we need to choose only one technology. The project is technology dependent. The project is technology dependent. And here, as we are developing everything in the single application, burden on the server. Burden on server. Because credit card functionality, debit card functionality, net banking, loans, gold loans, personal loan, educational loan, mortgage loan, property loan, everything is available in one project which is deployed in the server. So when everything is available in the server, so many people, some people are accessing credit card, some people are accessing debit card, some people are accessing net banking, some people mobile banking, some people loans. So many customers are using our application at a time. If so many customers are using our application at a time, all the requests will go to single application. That application is available in the single server, then burden will be increased on the server. Burden on the server, it can cause server crash also. It can cause server crash also. Our server can be crashed and users may not be able to get the response as expected. The response of the application will become very slow because the burden is increasing on the server. So earlier, long back, people used to develop the application by using monolithic architecture. What is the meaning of monolithic architecture? Developing all the functionalities in one single application, functionalities in single application, single unit. Everything is available at one place only. We are developing as one single project. So many requirements are available. All the requirements, if you develop in one application, then it is called as monolithic architecture based application. If you develop all the application, all the functionalities as a single application, then it is called as monolithic architecture. So if you go for monolithic architecture, then what are the problems available? So there are several problems available with the monolithic architecture. What are those problems, guys? So the project is tightly coupled because all the functionalities available at one place, and the project maintenance is going to be difficult. The project maintenance is going to be difficult. And if you make a minor change in the application, you need to redeploy the entire application. And so suppose I made a minor change to the credit card functionality, then you need to redeploy the entire project in the server. It is a time-taking process. And if you choose one technology to develop the project, you need to stick to that technology only. The project is technology dependent, and as everything is available at one place, the burden will be increased on the server. Server can crash. So are you guys able to understand what is monolithic architecture and what are the challenges available with the monolithic architecture? Are you able to get the clarity? So to overcome the problems of this monolithic architecture, people started using microservices architecture. To overcome the problems of monolithic architecture, people started using microservices architecture. Sir, what is the meaning of microservices and what are the benefits available with the microservices? The very first thing that you need to understand, microservices is not a technology like Java, not a technology like a Python, not a technology like a .NET. The first thing that you need to understand, microservices is not a technology. First thing that you need to understand, microservices is not a technology. And the next thing, microservices is not a framework. We have a Spring Boot framework, we have a Hibernate framework, we have a Python people having Django framework like this. But microservices is not a technology. Microservices is not a framework, and microservices is not an API also. Sir, we have JDBC API to communicate with the database. We have Servlet API to develop web application. We have Jackson API to convert Java object to JSON, JSON to Java object. But here, microservices is not API. Microservices is not a programming language. Microservices is not a framework. Microservices is not a technology, or microservices is not a language. It is not a language, it is not a framework, it is not API. Then what is microservices? Microservices nothing but it is one design pattern. Microservices is called architectural design pattern. So earlier, companies used to develop the application by using monolithic architecture. So they realized that if we develop the project by using monolithic architecture, there are several challenges available, guys. If we develop the project by using monolithic architecture, there are so many challenges available. What are those challenges? We have already seen. Tightly coupling is one challenge. Maintenance is one challenge. Okay. Burden on the server, redeploying the application, technology dependent. So there are several challenges available when you go for monolithic architecture. So to overcome the problems of this monolithic architecture, people are using microservices architecture. Okay, what is this microservice? Microservice is not a technology. It is not a language. Microservices is not a framework. Microservices is not an API. What is microservice then? Microservice is called architectural design pattern. Microservice is called as architectural design pattern. Okay, this design pattern is a universal design pattern. Anyone can use this design pattern to develop their application. These microservices not only for Java, not only for Python, not only for .NET. Java developers can use this microservices design pattern to develop the application. .NET people can use this design pattern to develop the application. Python people can follow this design pattern to develop the application. So microservices is an architectural design pattern. Anybody can use, any programming language developer, any technology developer can use this microservices design pattern to develop their applications. Okay, earlier people used to develop the project by using monolithic architecture. So there are some challenges available. To overcome the challenges of the monolithic architecture, people are going with the microservices architecture. Microservice is not a programming language. Microservice is not a framework. Microservice is not a API. Then what is microservice? Microservice nothing but a design pattern to develop our application. So our application contains several functionalities. So if you take e-commerce project, set of functionalities like product categories, product checkout, product payment, product order, order cancellation, order tracking, some functionalities are there. If you go for any traveling application like Make My Trip, yatra.com, redbus.com, GoIbibo, bus ticket booking, train ticket booking, flight ticket booking, hotel ticket booking, cab booking, several functionalities available. And if you go for insurance application, health insurance will be available, life insurance will be available, term policies will be available, savings will be available. Okay, so if you take any project, set of functionalities are available. So project nothing but set of requirements, set of functionalities available. If you develop all those functionalities, presentation layer, business layer, data access layer, everything as one single project, then that is called monolithic architecture. That is old style of development. If you go for a monolithic, only one project, everything is available in one project. So lot of problems, tightly coupling, maintenance problem, technology dependent, redeployment required for entire project. And if you want to scale up one functionality, that's not possible. As everything available at one place, burden will be increased on the server. So people struggled a lot with the monolithic architecture based applications in the industry. That's why they want to come out of those problems. So to come out of those problems, what they are doing now? They are using microservices architecture. So what is the meaning of this microservices architecture? Microservice is not a technology. It is not a programming language. It is not a framework. It is not API. Then what is that? It is one design pattern which is used to develop our application. And who can use this design pattern to develop application? Only Java developers, only .NET, only Python. No, this is universal. Anybody can follow this microservices design pattern to develop their application. Okay, so if we develop our application by using microservices architecture, then what are the advantages available? So if we develop our application by using microservices architecture, then what are the advantages we are having? What are the benefits we are having if you develop our application by using microservices architecture? Can anybody guess what are the advantages available if you develop our application by using microservices architecture, guys? If we develop our application by using microservices architecture, what are the advantages available? Can you tell me? Can you type in chat box? What are the advantages available? What are the advantages available with the microservices architecture? Come on, guys, quickly respond. Wow, we reached almost 700 people for the workshop. I'm really shocked. I'm really surprised by seeing this count. Thank you so much, guys. So this is very good number. This is very good number. 700 plus people are attending this workshop. What are the advantages available? What are the advantages available when you go with this microservices architecture? So the first advantage with the microservices, which is loosely coupled. So one functionality is loosely coupled with the another functionality. So here, if you see, if you take one example of Make My Trip application, let me show you one example of Make My Trip application. So if you go to Make My Trip application, in the Make My Trip application, lot of functionalities available. Train ticket booking is available, flight tickets booking is available, hotel booking available, bus booking, cabs booking available. So flight tickets, hotel tickets, holiday packages, trains, buses, cabs, so many functionalities available. If you develop all these functionalities in one project, monolithic. So to overcome that problem, what we are going to do, we are going to follow microservices architecture. So when we go for microservices architecture, what we are going to do here, guys? So here for a hotel booking, I'm going to develop one project, hotels booking. Hotels booking functionality will be available, that is developed as one project. Then similarly, we are having flights ticket booking. Okay, flights ticket booking, I'm going to develop as separate project, flights booking. Okay, similarly, we need to book the train tickets booking, trains booking is available. This one I'm going to develop as a separate project. So this is one microservice, this is one microservice, this is one microservice. All these microservices are belongs to one application. That application is called as Make My Trip application. So earlier, everything is developed as one project. If you develop everything as one project, that is called monolith. There are some problems. To overcome those problems, we are going for microservices. What is the meaning of microservices? Don't develop everything in single project. Hotel ticket booking functionality, you develop a hotel tickets booking as one simple project. So this hotels booking project contains only the functionality to book the hotel tickets. That's it. Hotels booking will be available in that. So no other functionality. Hotels booking is developed as one separate project that is having a separate database. And similarly, flights booking, flight tickets booking. So develop one simple project which contains only the logic to book the flight tickets. For this, let us take a separate database. So this is one microservice. Microservice nothing but a simple project, a single project, a simple project or a small project which contains only one specific functionality. Similarly, train tickets booking I want to implement. For train tickets booking, develop one separate project. This is called one microservice. This is called one simple service. This will contain the logic only to book the train tickets. This will contain the logic to book only the train tickets. So like this, instead of developing all the three functionalities in one project, I'm developing three functionalities as three different projects. That is called microservices development. So earlier, everything is developed in single application. So long back in the IT industry, people used to develop the project. Now, if you take this project, suppose for example, so in this project, I'm writing the logic for hotels booking. Hotels booking is available in this project. Similarly, flights booking is also available and trains booking also available in the single project. Okay, all the three functionalities I have implemented in one project only, a single project. That is called monolithic architecture. Hotels booking available, flights booking available, train tickets booking available, and for this project, single database is also available. Hotel booking, flights booking, trains booking, everything implemented in the single project. That is called monolith. It will have a single database. That is having a single database. So if you develop your application like this, that is called monolithic architecture, the problems are available. So to overcome the problems of the monolithic architecture, we are going for microservices development. So when you go for microservices, what we are doing? Hotels booking, we are developing as one simple project. Flights booking, we are developing as one simple project. Trains booking, we are developing as one single project. Are you clear? What is the advantage now? Loosely coupling. So one project contains only hotels booking code. The code is available to book only hotels in one project. That is separate project. That project you can develop separately. You can test separately. You can deploy separately. You can execute separately. It is completely independent. It is completely independent. Similarly, flight tickets booking is required. We are going to develop a project, a simple project, which contains only flights booking logic. That project you can develop, you can test, you can deploy, you can execute, you can deliver independently, a small service. Similarly, trains tickets booking is available. Create one simple project which contains only the logic to book the train tickets. Develop, test, deliver independently. Okay, and every microservice having its own database, and all these microservices are called as backend APIs. So every microservice is one REST API. Every microservice is one REST API. For these REST APIs, UI application will be available. One UI application will be available, and this UI application is going to communicate with all the backend APIs based on the demand. Hotels booking project is one API. It will run in one server. Train ticket booking API will run in separate server. Flight tickets booking API will run in separate server. These all are the backend APIs. These are called as backend microservices. In the backend, 3 microservices available. Like this, you can develop 20 microservices. You can develop 30, 40, 50, 100. According to your project requirement, you can develop any number of microservices. Microservice nothing but a small service which is independent service. Independently, you can develop, you can test, you can deploy, you can deliver that API to the client. A API, nothing but a REST API. One REST API is called one microservice. One microservice will contain one functionality, a specific functionality. So instead of combining hotels booking, flights booking, trains booking in a single project, we are developing 3 functionalities as 3 microservices. Microservices, nothing but pure backend APIs, no UI. UI part will be available as a separate project. When end user communicate with the UI application will communicate with the backend microservices. Every microservice will run in a separate server, and these microservices are independent microservices. Backend microservices, nothing but REST APIs. So earlier, people used to develop the project by using monolithic architecture. Nowadays, people are developing the project by using microservices architecture. Diagrammatically, are you able to understand? Diagrammatically, are you able to understand the difference between? Are you able to understand the difference between microservices architecture and monolithic architecture, guys? Diagrammatically, are you able to understand the difference between microservices architecture and monolithic architecture? What is the advantage with the microservices? The first one is loosely coupled. Every API will be developed as separate API. Okay, microservices is an architectural design pattern. The advantage of using these microservices, instead of combining all the functionalities in one single project, we are developing the functionalities as separate APIs. Every API is a separate microservice. Okay, so hotels booking is developed as one project, flights booking developed as one project, trains booking developed as one project. So what is the benefit? The microservices are loosely coupled. The microservices are loosely coupled. What is the meaning of loosely coupling, guys? Can you tell me what is the meaning of loosely coupling? Can you guys tell me what is the meaning of loosely coupling? Can you tell me what is the meaning of loosely coupling? Come on, first. What is the meaning of loosely coupling? What is the meaning of loosely coupling, guys? Independent. One microservice is independent on the another microservice. Hotels booking we developed a separate project. We can test separately, we can deploy separately, we can execute separately. Similarly, flights booking we can develop separately, we can test separately, we can deploy separately. So the microservices are loosely coupled. That means when you make the changes to one API, there is no effect on the another API. When you make the changes to one API, there is no effect on the another API, and every microservice will run in the separate server. So burden also reduced on the servers. Burden also reduced on the servers. Earlier, everything is executed in the single server. All the requests will come to single server. So burden is increased on the server. Now, flights booking is running in one server. Flights API running in one server. Hotels API running in one server. Trains API running in one server. So every API is independent, every API running in a separate server. So the burden is also reduced on the server. And the third advantage is easy maintenance, guys. The third advantage is easy maintenance. That means when there is a small problem, in the flight tickets booking API, I need to look into only the flights API. I don't need to touch it. I don't need to change the remaining APIs available in the project. There is a problem in the flights booking. So I will look into only this API. I will make the code changes to only the flights booking API, but not for other APIs. Maintenance of the project will become very easy. The maintenance of the project will become very easy because these APIs are loosely coupled. So we can make the changes to particular API. We can test only that particular API and we can deploy only that particular API. When there is a small problem in one API, you can debug only that API. You can modify the code of only that API. You can redeploy only that API. When there is a problem in the flights booking, there is no effect on the hotels booking. There is no effect on the trains booking. Problem is there only with the flights booking API. Flights booking API is a separate project. It is running in the separate server. There is no problem for hotels booking. There is no problem for the trains booking. You no need to modify them. The maintenance of the project will become easy and every API running in a separate server. Burden is also reduced on the server. When you are going for microservices development. When you go for microservices development, the burden is also reduced on the server. First thing, they are loosely coupled. And they are running in the separate server. Burden is reduced on the server. Maintenance of the project will become very easy. Maintenance of the project is going to become very easy. Independently we can deploy and independently we can execute our services. Independently we can execute our services when you go for microservices architecture. Independently we can execute and independently we can deploy. And another biggest advantage here, no single point of failure. That means if one API is down, there is some problem for one API. If one API is down, the remaining APIs still will be up and running. So hotels booking is not working, but still customers can access flights booking, customers can access trains booking. For example, in our application, hotels booking is not working. There is some issue, some memory issue or some DB issue, some problem is available, that API is not working. So if the hotels booking is not working, but still customers can use flights booking, customers can use the trains booking. So only one API having a problem, the remaining APIs are up and running. But when you go for Monolithic, if there is a problem, entire project will be down. That is a single point of a failure. So when you go for monolithic architecture, there is another challenge available. That is single point of failure. Single point of failure is available in the monolithic architecture. What is the meaning of single point of failure? If there is a small problem in the application, then the entire application is going to be down. If there is a small problem in the application, then the entire application is going to be down. We need to fix the problem and we need to redeploy the entire application. But when it comes to the microservices architecture, there is no single point of a failure. If a hotel's booking is not working, only that API is down. Still, flights booking, trains booking is working. And every functionality developed as a separate microservice, it is deployed in the separate server. Microservices nothing but loosely coupling. Microservices nothing but easy maintenance. Microservices nothing but independently deployable. Microservices nothing but no single point of failure. So what all the problems available in the monolithic architecture, to overcome those problems, people are migrated to microservices development. This microservices is one architectural design pattern. Microservices will tell you how to develop your application with loosely coupling. So application nothing but several functionalities will be available. Instead of developing all the functionalities in one project, you divide them into small services. Hotels booking, develop as one project, microservice, REST API, deploy that into one server. Flights booking, develop as one microservice, develop that as a simple REST API, deploy into one server. Flights booking, develop as one API, deploy into one server. Okay, every functionality we are going to develop as a separate API that we are going to deploy into separate server, so that my microservices, that means my application functionalities are loosely coupled. Every microservice is a separate project. Earlier, we are going to develop a single application. Now we are going to develop 3 applications. Same requirement is same. Earlier, everything in one project. Now they are divided into multiple projects. So if you keep everything in one project, there is a problem. Tightly coupling, maintenance, redeployment, single technology, burden on the server, single point of failure. To overcome all these problems, we are going for microservices architecture. It is not a technology, it is not a framework, it is not API. Then what is this microservice? It is architectural design pattern, and any project can use this design pattern in order to develop the application. Anybody, Java people can use, Python people can use, .NET people also can use this design pattern in order to develop the application. Not only advantages, there are some challenges also available with the microservices. What are those challenges with the microservices? Can anybody tell me the challenges of microservices? We have seen advantages. What about disadvantages? What are the challenges with the microservices, guys? So there are some challenges available with the microservices also. What are those challenges? The first challenge with the microservice, that is bounded context. And the second challenge with the microservices, that is repeated configurations. The third challenge with the microservice, that is visibility. Okay, so these are the 3 challenges are available when you go for microservices architecture. Advantages are available, and there are some challenges also available when you go for microservices architecture. Sir, what is the meaning of bounded context? Bounded context is nothing but deciding how many microservices we need to develop. Client has given 100 requirements. So for these 100 requirements, how many microservices we need to develop? In one microservice, what functionalities we need to implement? Deciding that boundary is a challenging task. Client has given 100 requirements. For 100 requirements, you cannot develop 100 microservices, right? For 100 requirements, do I need to develop 100 microservices? Do I need to develop 50 microservices? So in 50 microservices, so which functionality I need to develop in which microservice? Deciding the number of microservices required for our application is a challenging task. Are you guys getting my point? Deciding the number of microservices we need to develop for our application is a challenging task. So that task, that problem is called as bounded context. That problem is called as bounded context. And the next one, repeated configurations. Next one is the repeated configurations. Sir, what is the meaning of repeated configurations here? What is the meaning of repeated configuration? So in this project, I need to configure database, plus I need to configure security. Okay, so database, security plus Kafka I want to use in one microservice. For database communication, some configuration I need to do for this microservice. Okay, for security some configuration, for Kafka some configuration. So same, my second microservice also want to use database, want to use security, want to use Kafka. Here also I want to use database, security plus Kafka. So the configurations are going to be repeated. So a lot of duplicate configurations we need to do when we go for microservices development. So the first problem with the microservices, or the first challenge with the microservices, is bounded context. Excuse me guys. So when you are going for microservices development, right, so there are some advantages available and there are some disadvantages also available. So advantages we have already seen: loosely coupled, easy maintenance, no need to redeploy all the microservices. Which microservice you modify, only that microservice you can redeploy. So there is no single point of failure, and you can use multiple technologies to develop all the microservices, and your application can be delivered very quickly. Okay, then coming to challenges with the microservices, bounded context. How many microservices we need to develop? Client has given 100 requirements. For these 100 requirements, how many microservices we need to develop? 50, 60, 70, 100, 150? The number, deciding that number is difficult. So that is called bounded context. And the second problem, repeated configurations, guys. So repeated configurations, nothing but in the hotels API, I want to do the DB configuration, security configuration, Kafka configuration. Same thing for the flights booking, same thing for the trains booking. So multiple APIs should have same configurations. So repeated configurations will be available. And the next problem with the microservices is visibility. So when you are working in the microservices project, you will not get the chance to work with all the microservices in the project. You will be working with only few microservices in the project. You will understand the functionality of only those microservices. You don't know the remaining microservices functionality. You will not get the complete clarity on the project. You will not get the complete picture of the project. So they will assign only one microservice for flights booking. Okay, you work on that. How the train tickets are booking, you will not get the chance to look into that functionality. How the hotels booking, you don't know, because you are part of only one microservice development or few microservices development. Visibility problem, you may not get the chance to work with all the microservices in the project, so you will not get the complete clarity on the project. So I will tell you my scenario. So in my project, I'm working for one banking company. Okay, so from last 3 years, I'm working in the banking company, that is US based bank. So I'm working for credit card management system, credit service layer or credit card management system we are developing. So I am part of the project which is dealing with the credit cards for the US citizens. So my bank is there in US. So the customers, the citizens will apply for a credit card. They will use the credit card. So citizen credit cards available, retailer credit cards available. That means for business also we will give the credit card. That is called retail credit card. So normal citizen credit cards available, company related, business related, retail credit cards also available. So we will check the citizen eligibility. We will check the business eligibility to get the credit card payments, reminders, interest calculations. All these functionalities are part of our project. Complete credit card system management. In this credit card system management, from the last 3 years, we have developed 150 plus microservices. 150 plus earlier actually that project was there in mainframes. Earlier, from long back, from so many years, that bank is available. For that bank, credit card is available, project is available, but that project was available in the IBM mainframes technology. Now we are migrated that project into microservices architecture. In the last 3 years, we have migrated that credit card management system to the microservices architecture. That was a legacy project on the mainframes. I was part of that project. I was technical lead of that project. I was involved in migrating that mainframes application to microservices. 150 plus microservices we developed. I was the technical lead for that project. But I don't know all these 150 microservices because I did not get the chance to work with 150 microservices in the project. I am part of the credit card management system, but 150 microservices I don't know. So in the last 3 years, hardly 50 to 60 microservices I have touched. some microservices scratch development, some microservices bug fixing, some microservices code review. I involved in the several phases in the development. Few microservices I developed, I know in and out what is the logic of those microservices. For a few microservices, I have done the bug fixing. I got the idea. So what the code they have done, where is the problem, how to fix it. For a few microservices, my juniors developed. I have done the code review of their microservices. So in the last 3 years of time, I got the chance to touch, or I got the chance to work with 50 to 60 hardly, I don't remember the count exactly. Hardly 50 to 60 microservices only. I know what is the business logic, how they developed, what they are doing, from where the request is coming, where the response is going, what is request, what is response. So I know about only 50 microservices in my project. I don't have complete picture of my project. I don't know how the complete system will work because 150 microservices are there. But I was part of 50 to 60 microservices. 100 microservices I don't know. So that is the reality. Visibility problem. So many people are facing the same problem in the industry. That is called visibility problem. So visibility problem means you will not get the chance to work with all the microservices available in the project. So you will get the chance to work with only few microservices in the application, not with all the microservices. So I hope you got the clarity. Bounded context is nothing but identifying how many microservices we need to develop for one application and deciding which functionality we need to add in which microservice. So client has given 100 requirements. For these 100 requirements, how many microservices we need to develop? For these 100 requirements, how many microservices we need to develop? Deciding that factor is very difficult. Deciding how many microservices we need to develop in one application, that is very difficult, guys. That is very difficult. Deciding how many microservices we need to develop and which functionality we need to add in which microservice, that is difficult. Okay, so that problem is called bounded context. Bounded context means identifying how many microservices we need to develop for one application and deciding which functionality we need to add in which microservice. And the next one, in several microservices, we need to write some configurations like data source configuration, SMTP configuration, Kafka configuration, Redis configuration, etc. So there are 30 microservices available in my application. So in 30 microservices, data source configuration, Kafka configuration, Redis configuration, security configuration we need to do. So that is called repeated configurations will be available. That is called repeated configurations will be available when we go for microservices architecture. And the next one, in the microservices architecture, we might not get the chance to work with all APIs available in the application. So I told you my scenario. 150 microservices available in my project, but I know only 50 microservices functionality. The remaining microservices I don't know. I don't have the complete picture of my project. So that is called visibility problem. What is that problem is called, guys? That problem is called as visibility problem in the microservices architecture. So do you agree with me? These are the challenges we need to face as a microservices developer. All right, let's get started with our microservices architecture, guys. The very first important thing that we need to understand, there is no fixed architecture for microservices, guys. There is no fixed architecture for microservices. People can customize microservices architecture according to their project requirement. We can customize microservices architecture according to our project requirement, guys. There is no standard. That means you need to use API gateway, you need to use a service registry, you need to use separate database for every microservice. Like that, there is no rule. There is no specific rules available in order to follow microservices architecture, guys. So that is the reason I'm trying to say here, there is no fixed architecture for microservices development. So whatever is suitable for your project, whatever is your project requirement, based on that we can customize microservice architecture according to our project requirement. So when we are implementing microservices architecture, as part of microservices architecture, we are going to use below components, guys. And all these components are not mandatory. All the below components are not mandatory. Whatever is required for your project, you can use that component and you can implement that component in your project. So in the industry, there is no fixed architecture for microservices development. We can customize microservices architecture according to our project requirement. As part of microservices architecture, we are going to use below components. All the below components are not mandatory. Sir, what are those components? The first one is service registry. In every microservices development, we are going to use service registry, which is called Eureka server. We are going to use Eureka server as a service registry, and we are going to use admin server in our microservices, and we are going to use Zipkin server in the microservices, okay, and we are going to use config server in the microservices, and we are going to use Kafka server in the microservices, and we are going to use Redis server in the microservices, and we are going to use Feign client in the microservices, and we are going to use API gateway in the microservices. We are going to use API gateway in the microservices. So when we are going for microservices development, there is no fixed architecture for the microservices development. We can customize this architecture according to our project requirement. As part of this architecture, we are going to use below components. All the below components are not mandatory. Whatever the component is required for your project, you can use that. So what components generally we are going to use in the microservices architecture? Service registry will be available. Admin server will be available. Zipkin server will be available. Config server will be available. Kafka server will be available. Redis server will be available. Feign client will be available. API gateway also will be available. Let me show you diagrammatically the microservices architecture. So first one, for every project, when we are going to develop the microservices, first thing that we are going to take, that is service registry. I will tell you what is this service registry, what is the role of the service registry in the microservices architecture. First, let's understand the architecture diagram. Service registry is available, and the next one we are going to use admin server. Next one we are going to use admin server. Just understand the diagram, understand the component architecture now, then we will discuss about what is the purpose of them. Admin server will be available and Zipkin server will be available. Admin server, Zipkin server will be available, and similar to this, config server will be available. Similar to this, config server will be available, and in some projects we are going to use Kafka server. Kafka will be available. Kafka will be available. In some projects, Redis will be available. Kafka server will be available and Redis server will be available, and we are going to use ELK stack also. ELK servers will be available. Okay, so service registry will be available in the microservices. Admin server will be available. Zipkin server will be available. Config server will be available. Kafka will be available. Redis will be available. ELK also will be available. Now, after these things, then actual microservices will be available here. Microservices nothing but our backend APIs. Multiple APIs you can take. API 1, API 2, API 3. According to our requirement, we can take multiple backend APIs in the application. This is my API 1, this is API 2, and this is API 3. So like this, you can take multiple APIs according to our requirement. API 1, API 2, and API 3 is available. Now, what are the backend APIs are available? All these backend APIs are going to register with the service registry. And these APIs will register with the admin server. APIs will register with the Zipkin server. API will register with the config server. APIs will register with the Kafka. APIs will register with the Redis server. APIs will register with the ELK also. And one API can communicate with the another API, that is called inter-service communication. One API can connect with the another API, that is called inter-service communication. Okay. Next one, in order to manage all these APIs, we are going to have one more API which is called API gateway. We are going to have one more API which is called API gateway in our application. Okay, that API gateway also going to register with the service registry available in the project. API gateway will register with the service registry. Then, so this is our complete backend application microservices development. Instead of ELK, you can say that it is a database, or database also will be available. And this is microservices architecture. Okay, in the real time, when we are developing our application with the microservices, generally, this is the architecture we are going to follow. But as I told you, this is not fixed, guys. In some projects, they may not use Kafka. There is no scenario. If they don't need Kafka, they will not use it. If they don't need Redis server, they may not use it. Database, definitely every microservice will have database communication. Some people don't use a config server. Some people don't use a Zipkin server. Some people don't use admin server. Some people don't use inter-service communication. So there is nothing mandatory here. There is nothing mandatory. So according to our project requirement, what is required, that you can use. So that is what I told you. There is no standard architecture for the microservices development. So according to your project requirement, you can develop this architecture. You can customize this architecture according to your project requirement. So what are the components that we are taking here? So service registry is available. Admin server is available. So this is service registry, and this is admin server, and this is Zipkin server, and this is config server. And we are having Kafka server, we are having Redis server, and we are having database also. Whether we are going to use one database or we are going to use multiple databases, that it depends on the project requirement. Some project may use only one database, some project may use multiple databases. And here API gateway is also available. So in the real time, when we are developing the microservices, most of the people, most of the companies, most of the project will follow this kind of architecture, and according to their requirement, they can change this also. It is not mandatory. It is not mandatory to follow this architecture. They can customize this architecture according to their requirement, guys. According to their requirement, they can customize this architecture also. Are you guys able to follow me? Are you guys able to follow me? What is the standard architecture available for the microservices? Guys, is my voice audible for everybody? Is my voice audible? Is my video also visible? Is my video also visible? Both are clear, right? Very good. Good. So we are going to understand microservices architecture. There is no fixed architecture for the microservices development. We can customize microservices architecture according to our project requirement. As part of microservices, microservice architecture, we are going to use below components. All the below components are not mandatory. We can use them based on demand or based on requirement. So what are the components we are going to use? Service registry will be available, admin server will be available, Zipkin server will be available, config server will be available, Kafka server is available, Redis server is available, Feign client is available, API gateway also available. Now let's understand what is the purpose of all these components. Look at the diagram. Just observe the diagram for 1 minute of time, guys. All of you, can you observe this diagram for 1 minute of time? All of you, can you observe this diagram for 1 minute of time? Just look at the diagram. Just look at the diagram for 1 minute. What is this Feign client? What is this service registry? Everything we are going to discuss now only. What is the purpose of all these components I will tell you, and how to implement the project with all these components. Tomorrow we are going to do the coding. Today theoretically we will understand what is the purpose of this. Tomorrow practically we are going to implement them. Today theoretically we are going to understand these components. Tomorrow practically we are going to implement them. 1 microservice, API 3 1 microservice. So total there are 8 microservices are available. So how do you know how many microservices available? What is the name of the microservice? What is the URL of the microservice? What is the status of the microservice? So all the microservices of our application, all the microservices information of our application, we can maintain by using service registry. What is the purpose of this service registry? Service registry is used to maintain all the API's information like name of the API. API means microservice. So service registry is used to maintain all the API's information like name, status, URL and health at one place. So in our project there are 10 microservices available. So what all the microservices available? What is the name of each microservice? What is the status, whether they are running or stopped? What is the health? What is the URL? All the microservices information I want to monitor at one place. That's where service registry microservice comes into picture. So what is a service registry in the microservices architecture? Service registry is used to maintain all the microservices information at one place. It is a register where you can see what microservices available for our project. What is the name of each microservice? What is the status of each microservice? That means running or not running. What is the health of the microservice? What is the URL of the microservice? All the information about our microservices we can access at one place. That is service registry. This service registry is also called as service discovery. By using name of the microservice, we can identify the URL of the microservice. That's why it is called as a service discovery also. And how can we use this one? We are going to use Eureka server as a service registry. Sir, how to set up service registry for our application? To set up service registry for our application, we are going to use one server. That server is called as Eureka server. Which one we are going to use as a service registry for our application, guys? So in the Spring Cloud, when you go for, sorry guys, when you go for Spring Cloud library, let me take water. There is a change in the voice. Yeah, we are trying to, is it clear now? Is my voice clear now? Is it clear now? Yeah, good. So we are trying to understand what is service registry. You got the clarity? What is the purpose of service registry? Service registry is used to maintain list of services available in our application. So in one application, multiple microservices can be available. What microservices are available in one application, we can maintain by using service registry. This service registry is also called as discovery server or service discovery. So which one we can use as a service registry? We can use Eureka server as a service registry. Okay, Eureka server is provided by Spring Cloud libraries. Eureka server provided by Spring Cloud libraries. Okay, so if you want to use Eureka server, then we need to add Spring Cloud library in our application. How we are having Spring Core module, Spring Data JPA module, WebMVC module. Similarly, Spring Cloud module is available. By using this Spring Cloud module, we can use service registry. So what is the purpose of this service registry? Service registry is used to maintain all APIs information like name of the API, status of the API, URL of the API, health of the API, all the APIs information we can access at one place by using service registry. This service registry is also called as service discovery. How to set up the service registry? To set up the service registry, we are going to use Eureka server. Who will give you that Eureka server? Eureka server provided by Spring Cloud Library. Okay, and this service registry will provide one user interface to get the APIs information. It will give you one dashboard. If you create a service registry project, that service registry project will give you one dashboard. In that dashboard, you can access all the microservices information. How many microservices available? What is the name? What is the URL? What is the status? What is the health? How to access them? All the microservices information we can access in the service registry dashboard. Eureka server we are going to use as a service registry. There are some alternates also for the Eureka. In the Spring Cloud, Eureka server available, which we are going to use as a service registry, which is free of cost. What is the alternate for Eureka? The alternate for the Eureka console is available. There is another server, console server, which we can use as a service registry, and cloud, AWS service registry available. AWS service registry available, Azure service registry. That means cloud providers also will give you service registry to monitor your microservices. But cloud service registries are costly. We need to pay the money. But when you go for Eureka, which is free of cost. So that's why as part of our microservices development, we are going to use Eureka server as a service registry, which is free of cost. It is part of Spring Cloud Library. Are you clear with my point? What is the meaning of service registry? Are you clear with my point? What is the meaning of service registry? Service registry is used to maintain all the APIs information like name of the API, status of the API, URL of the API, health of the API. We will use Eureka server as a service registry. That is part of Spring Cloud. So it will provide user interface to get the APIs info. Sir, how to get that user interface? Tomorrow we are going to do the coding for this, right? So in the coding, we will build one microservice called service registry microservice. Then we will see the information of the microservices. Theoretically, are you clear? What is service registry? Theoretically, are you clear? What is service registry? Yes. Good. So Eureka is a service registry. We are going to use the alternates for the Eureka. Console is available. Cloud provided service registries, paid service registries are available in the market. Next one, in the diagram, if you see the next one, admin server. So what is the meaning of this admin server? Admin server is used to monitor and manage all the APIs at one place. That means I want to check the health of the APIs. I want to see configuration properties loaded by the APIs. I want to see what are the beans loaded by the APIs. I want to see logs of the loggers available for the API. I want to change the log level of the API. Okay. So generally in the Spring Boot, we know actuators concept. Actuators are used to monitor and manage the APIs. So for this, microservices, API 1 is having actuator, API 2 is having actuator, API 3 is having actuator. All these actuators I want to monitor by using one dashboard. At one place I want to monitor all the APIs. So to monitor all the microservices, to manage all the microservices at one place, we are going to use admin server. So already in the Spring Boot, actuators concept available. What is the purpose of the actuators? Actuators are used to monitor and manage your microservices, your Spring Boot applications. So API 1, 2, 3, like that, 10 APIs available. 10 APIs are having the actuators. Accessing actuators of 10 APIs individually difficult. I want one user interface where I can monitor all the APIs at one place. That's where admin server comes into picture. So what is this one service registry? Only to tell you what are the microservices available, what is the name, what is the status, what is the URL. By using this admin server, we can manage them. We can monitor and manage all the APIs at one place. Example, health check. We can do health checks and we can see config props. We can see the config props. We can see URL mappings. We can see URL mappings and we can see beans loaded. We can see beans loaded, changing log levels, all kind of things. All these kind of things we can perform by using admin server. So this is used to monitor and manage all your APIs. API in the sense REST API. REST API nothing but microservice. So all the microservices we can monitor and we can manage at one place by using admin server. This admin server also will provide a beautiful user interface to access API's actuator endpoints at one place. So if you know the actuator concept in the Spring Boot, the actuator concept is used to monitor and manage your APIs. So instead of accessing the actuator endpoints separately, all the API's actuators we can access at one place with the user interface. For that reason, we are going to use admin server. Admin server is used to monitor and manage all the APIs at one place. What we can monitor? We can do the health checks of the APIs. We can see the config props loaded by the APIs. We can see URL mappings of the APIs. We can see the beans loaded by the API. We can change log levels of the APIs, thread dumps of the APIs, heap dumps, thread dumps you can download, heap dumps you can download, thread dumps and heap dumps we can download by using this admin server. Admin server will provide you user interface in order to manage and monitor all the APIs at one place. Are you guys able to understand what is the purpose of service registry and admin server? Both are same or both are different? Guys, service registry and admin server both are same or both are different? Service registry to know what all the services available. Admin server to monitor and manage all the APIs at one place. Okay. And the next one, there is another server which is called Zipkin server. There is another server available which is called Zipkin server. So what is the meaning of Zipkin server? What is the purpose of Zipkin? Zipkin server is used for tracing the request. It is used for distributed tracing of our requests. So that means by using this Zipkin server, we can understand how much time taking to process one request processing time. So customer send one request to our application. In our application, microservices available. How much time it is taking to process the request? Which microservice is taking? Which microservice taking more time to process? Okay. How many services involved in the request processing? How many services involved in one request processing? So when I send one request, that request executed by only one microservice, or that request executed by multiple microservices? If the request executed by multiple microservices, how much time each microservice has taken to process that request? Which microservice is fast in processing the request? Which microservice is slow in processing the request? All that information we can track by using Zipkin server. So what is a Zipkin server? Zipkin server is used for distributed tracing of our requests. So what we can get by using this Zipkin? We can understand how much time taking to process one request, which microservice is taking more time to process, how many services involved in one request processing. All that data we can get by using one server called Zipkin server. This Zipkin server also will provide one dashboard. Zipkin server will provide one beautiful user interface to access API's execution details. So customer sent one request to our application, which microservice executed to process that, how many microservices processed that request, which microservice taking more time, which microservice is taking less time. All that information we can access by using Zipkin dashboard. Zipkin server we are going to use to implement distributed tracing of our requests in the microservices architecture. Service registry, admin server, Zipkin server. Service registry to know the APIs available in the application. Status, name, URL. Admin server to monitor and manage all the APIs at one place. And the next one, Zipkin server. Zipkin server is used for distributed tracing of our request. So which request came, which service executed, how much time they taken, which service is taking less time, which service is taking more time. All this information we can access by using Zipkin server. Okay, are you guys clear with the purpose of Zipkin server in the microservices architecture? Next one, another server that we are using in the microservices architecture, that is called config server. Another microservice component, that is config server. What is the config server? Config server is used to separate application code and config properties. Application properties. Earlier in the Spring Boot project, when we developed the Spring Boot application and properties file will be available. Database properties, Kafka properties, Redis properties, everything we will configure within the project application and properties file or application and YML file. So if you keep the database properties within the application, it is tightly coupled. So we need to separate configuration properties and source code. So that's where we are going to use config server. Config server is used to externalize config properties. It is used to make our application loosely coupled with the properties file or YML file. Earlier, when we are developing the boot application, properties file by default will be created. Data source we will configure. Data source details we will configure in the properties file. But tomorrow, if I want to connect with a different database, I need to change the properties file. I need to recompile the project. I need to repackage the project. I need to redeploy the application. Application will be tightly coupled with the properties file. If you write your properties, data source properties, SMTP properties, and the next one, Kafka properties, Redis properties, anything, if you write within the project is tightly coupled. Tomorrow, I want to connect with a different database. I want to change the database credentials. Then again, you need to repackage, you need to recompile, repackage, redeploy. To overcome that problem, we are going to use config server in the real time. So what is the purpose of config server? It is used to separate application code and application properties. Application and properties file we will load from outside of the project. Earlier, whenever we are developing a boot application, properties file and YML file is there within the project. But in the real time, we need to keep the properties file outside of the project and we need to load into our application. To make our application loosely coupled with the properties file or with the YML file, we are going to use config server concept. Very important in the real time. Nowadays, in every microservice application, config server is used, which is used to externalize configuration of properties from our application. So earlier, when you create, generally, when you create a boot application, start class will be created, properties file also will be created. Properties file is there within the project. If you keep the properties file within the project, tightly coupled. We need to load it from outside. How to load the properties file from outside? By using config server. So what we can achieve by using config server? By using this config server, we can achieve loosely coupling with the properties file. Service registry, that means Eureka server, admin server, Zipkin server, config server. Are you clear with my point? Service registry, admin server, Zipkin server, config server. So what is the meaning of service registry? Service registry is used to maintain all the APIs information at one place. It is also called as service discovery. We are going to use Eureka server as a service registry. It is provided by Spring Cloud. Next one, admin server. What is the purpose of admin server? Admin server is used to monitor and manage all our APIs at one place. We can do health checks, config props, URL mappings, beans loaded, thread dump, heap dump. So change the log level. In the interview, they asked this question. Currently, my project log level is info. Without restarting the project, I want to change it to debug level. How do you do that? by using admin server? So this is very famous interview question. My application running in the production, my application log level is root log level is info. Now I want to downgrade it to the debug level without restarting the project. How can you change the log level without restarting the project? That's where admin server comes into picture. So what is the purpose of admin server? It is used to monitor and manage all the APIs at one place. So this kind of information we can access by using admin server. So this Eureka server will provide user interface, dashboard will be given to you. Admin server also will give the dashboard for you, and Zipkin server is available. That Zipkin server also will provide a dashboard for you. What we can do by using Zipkin server? Zipkin server is used for distributed tracing of our request. Okay, how many microservices involved in the request processing? Which microservice is taking how much time to process the request? And the next one, config server is available. What is the purpose of config server? Config server is used to separate application code and application properties. So generally when you are doing the practice, when you are developing the boot application, properties file will be available within the application. That's not recommended. So in the real time, properties files will be available outside of the project and we will load them by using config server. Are you guys clear with these concepts? Service registry, admin server, Zipkin server and config server. Are you able to understand? Are you able to understand what is the purpose of service registry, purpose of admin server, purpose of Zipkin server, purpose of config server? Could you please respond in the chat box? Could you please respond in the chat box? Come on. Yes. Yes. So today, theoretically, we are understanding. Tomorrow, we are going to develop a project, guys. Whatever I am discussing today, tomorrow we will develop the code. Practically, we will see everything. So I told you, this is not just a theoretical session. Java Microservices Development, Java Microservices with a mini project development. So tomorrow, in the tomorrow Sunday session, tomorrow morning at 8 o'clock, we are going to start, right? So in the tomorrow session, we are going to develop a project. Whatever the theory you are learning today, tomorrow we will implement that in our project. Got it? So tomorrow, once you do the coding, then you will get the clear picture. Once we do the coding, then you will get the clear picture of that. Next one. Here, our actual microservices are available. API 1, API 2, API 3. These are our REST APIs that we are going to develop. API 1, API 2, API 3. These are our microservices we are going to develop. Whatever the microservices we are developing, those are called backend APIs, which will contain the business logic. So API 1, flight tickets booking. API 2, train tickets booking. API 3, hotel ticket booking. So according to our requirement, you can develop any number of APIs in the project. So in the diagram, I have taken 3 APIs. And observe, whatever the 3 APIs I am taking, this API is acting as a client for Eureka. Our API will act as a client for Eureka. Our API will act as a client for admin server. Our APIs will act as client for Zipkin server. Our APIs will act as a client for config server. Eureka server available, admin server available, Zipkin server available, config server available. Okay, and our APIs, our actual microservices we are going to develop. Our microservices will act as client for Eureka, will act as client for admin server, will act as client for Zipkin server, will act as client for config server. How to act as a client? In the coding, we are going to do that. I will develop one microservice. My microservice will register with Eureka. You can see the arrow marks I have given. So my APIs, API 1, 2, 3, up to 100 also, no problem. All our microservices will register with Eureka, will register with admin server, will register with the Zipkin server, will register with the config server. So our APIs are going to act as a clients for Eureka, for admin, for Zipkin, for config server. Now, whatever the APIs we are developing, one API want to communicate with the another API. When one API want to communicate with the another API, we are going to use Feign client. We are going to use Feign client. What is the meaning of a Feign client? Feign client is used for inter-service communication. What is the meaning of Feign client? Feign client is used for inter-service communication. So one microservice want to communicate with the another microservice is called inter-service communication. So this inter-service communication will happen with the help of service registry. So API 1 want to access API 2, API 2 want to access API 3, then we are going to use Feign client to achieve inter-service communication. Under these microservices, I'm going to implement load balancing also. That means one microservice I'm going to deploy in multiple servers in order to achieve load balancing. For the load balancing, we are going to use ribbon concept. For my microservices, load balancing. If you see two boxes I have given, two boxes nothing but two instances. My second API will run in two servers. Same microservice I will run in two different servers for load balancing. So those are called two instances. How do we achieve those two instances with load balancing? Ribbon concept we are going to implement. I will show you microservices load balancing also. I will show you microservices load balancing also by using ribbon. So if you see API 1 having one box, nothing but it is running in one server. API 2 having two boxes, nothing but it is running in two servers. Why we will run one microservice in two servers? For load balancing. How to achieve load balancing? By using ribbon. Where is that ribbon? Available in the Feign client. Okay, what is this Feign client? Feign client is used for inter-service communication. If one API is communicating with another API within the same application, then it is called inter-service communication. So I'm developing multiple microservices here. One API want to communicate with the another API, then it is called inter-service communication. How we will achieve that inter-service communication? By using Feign client concept. Are you clear? What is the meaning of a Feign client and why we need to use the Feign client? Are you clear? What is the meaning of a Feign client and how do we use the Feign client? What is the purpose of the Feign client? Feign client is also Spring Cloud library. Feign client is also Spring Cloud library that is used for inter-service communication. That is used for inter-service communication. What is the meaning of inter-service communication? Within my project, there are multiple microservices available. One microservice wants to communicate with the another microservice. That is called inter-service communication. Are you clear with my point? Next one. What is API gateway? So here, API gateway is like a security guard for our microservices project. So what is the meaning of API gateway? API gateway is going to act as a front controller. API gateway act as entry point for all the backend APIs in our application. API gateway is going to act as entry point for backend APIs. That means here UI application will be available. UI is a separate Angular project or React project. When customers are accessing the UI application, the UI application will communicate with the API gateway and API gateway will send the response back to the UI. So from the UI application, how the request will come to the backend application? Through API gateway. API gateway is an entry point for our backend microservices. A UI application cannot access our microservices directly. That's not possible. If any request coming to our application, first that request should go to API gateway, then API gateway will validate that request. Is it valid request or not? Is this request we need to accept or not? That kind of checks, request checks will happen at the API gateway. If request is valid, then only API gateway will forward that request. If the request is invalid, API gateway will reject the request. API gateway is like a security guard. So it will check ID. Suppose if you go to any company, security guard will be available. They will check ID. If ID is valid, they will open the gate. If ID is not valid, they will not open the gate. Same thing. API gateway will act as a security guard for our backend microservices. API gateway is an entry point for the microservices. So we can validate our request by using API gateway. It is going to act as a mediator between front-end application and back-end APIs. API gateway is going to act as a mediator between our front-end application and our back-end APIs. So in the API gateway, mainly we are going to write a filter to verify the request is valid or not, and the routings we are going to write. Filter is used to perform some pre-processing and post-processing. This request is valid or not, we are going to check by using filter. If the request is valid, then forward the request to the particular backend API. For that, routings will be available. If the request is invalid, then we will send error response back to the client. So client is sending a request through UI. The request will go to API gateway. It is our front controller. It is entry point. It is a mediator between incoming request and backend API. So in the API gateway, we will write a filter to validate the request. If the request is valid, then process. If the request is invalid, don't process. So when the request is valid, that request should go to which API? That's where routings concept comes into picture. So inside the API gateway, we are going to implement filters plus routings. Filters will be available and routings will be available in our API gateway. Filter to verify whether that request is valid or not. If the request is valid, then it should go to which microservice in the backend. It should go to which API in the backend, that we will configure by using routings concept. So API gateway is a mediator between our front-end application and backend microservices. Are you clear with my point? So in the real time, we are going to use Kafka also for our applications. Our microservices will use Kafka for distributed streaming. Our microservices will use Redis server for caching, and our microservices will communicate with the database to perform the operations, CRUD operations. So this is, some companies are going to follow this kind of microservices architecture, but it's not mandatory. Some companies may not use Kafka. Some projects may not use Kafka. Some projects may not use Zipkin. Some projects may not use API gateway. It depends on their choice. I told you, before starting this microservices architecture, there is no fixed architecture for the microservices. There is no fixed architecture for the microservices development. We can customize this architecture according to our project requirement. As part of this architecture, we are going to use some components. All the components are not mandatory. We can use them based on the demand. What are them? What are those? Service registry, admin server, Zipkin, config server, Kafka, Redis, Feign client, API gateway. So today, let us start the development of this project, guys. So first I am going to start with service registry. First we are going to start with service registry. So as we discussed, it is going to act as a discovery server. It is used to maintain all the services which are available in our application. What is the name of the service? What is the status of the service? What is the URL of the service? All these things we can maintain at one place by using service registry. So how to develop this service registry application? In our microservices architecture, the very first thing that we are going to develop, that is service registry application. So in this application, we are going to use Eureka server as a service registry. So what is the first thing that we need to do? Create one Spring Boot application with below dependency, which is Eureka server. This Eureka server dependency we will access from Spring Cloud library. Spring Cloud Starter, Netflix Eureka server. Create Spring Boot application. Create one Spring Boot application with this dependency. So with this dependency, we are going to get the Eureka server. And here, to represent this application as a Eureka server application, we are going to use one annotation called enable Eureka server annotation in the boot start class. So when we create Spring Boot application, by default one start class will be available. On top of this class, we need to write one annotation called enable Eureka server annotation. Then that application will be considered as a Eureka server, and configure the properties in the properties file or YML file. So we are going to configure server port number. So in general, when we create the boot application, we will get the Tomcat as a default container. Tomcat container will use default port number 8080. You can use 8080 also, but it is recommended to run the Eureka server on the port number 8761. Sir, why we should use the port number as only 8761? If you use port number as 8761, then our microservices will be auto registered with the Eureka server. So whenever you create a Spring Boot application with this dependency, then you will get the Eureka server for your application. How to start this Eureka server? You configure one annotation in the boot start class. Configure enable Eureka server annotation in the boot start class. Then you change the server port number. The default port number is 8080. We are customizing the port number to 8761. Why we are customizing the port number to 8761? If you configure the port number as 8761, our backend microservices, our APIs are available, right? Our APIs will be auto register with the Eureka server. If you run your microservice, it will register with the Eureka server by default. It will act as a Eureka client. Eureka server, Eureka client. Our microservices, API 1, API 2, API 3, they should act as Eureka clients. They should act as Eureka clients. So that is the reason I'm going with the port number 8761. Okay, so this is the procedure in order to develop our first microservice in this architecture. The first microservice I'm going to develop, service registry. What is the role of service registry? It is used to maintain all the APIs information at one place. Now, let me start that, guys. Okay, let me create a new workspace folder. Whatever the projects I'm developing, after the class is completed, I will push all these projects to my GitHub repository and I will share the link also, guys. Okay, I'm creating this as my microservices workspace. I'm choosing the new workspace here. Open my Spring Toolsuite IDE. You can use any IDE, guys. IntelliJ IDE also you can use in order to develop these applications. If you go with IntelliJ Community Edition, directly you cannot create the project. First, you need to create the project from Initializer website, then download that project, then import that project. Okay. With this, my Toolsuite IDE is open. Let me change the font, colors and fonts. Let me increase the font size. Yeah. Okay. With this, my IDE is ready. Now let me create Spring Starter project. Create new Spring Starter project. So this is my first application. I'm going to name this as 01 Service Registry. 01 Service Registry. I'm using Maven as a build tool. Packaging type is a jar. Group ID, I'm using in.ashokit. And package, start package, base package, in.ashokit. So my first project, 01 Service Registry. Now, so we need to select one dependency, guys. As we discussed, we are going to select a dependency for Eureka server. So it is from Spring Cloud Discovery Server. Let us select this Eureka server. Spring Cloud Netflix Eureka server. So this is Eureka server is coming from Spring Cloud Netflix library. Select that dependency. Then if you want, you can select DevTools also. If any changes happened in the project, server will be reloaded. Server will be restarted immediately. So click on next, click on finish. So with this, our first microservice got created, which is service registry. So by default, it will run on the port number 8080, but recommended to use 8761. Why we need to use 8761? If Eureka server is running on the port number 8761, our microservices can be auto registered with the Eureka server. If you don't configure port number as 8761, then our microservices should be registered with the Eureka server manually. I will show you auto registration and I will show you manual registration also. And today you need to have 100% focus, guys. Today you need to have 100% focus because yesterday theory completed. Today completely practical session. Today completely coding part will be available. So you don't attend the classes from mobile, and don't use your mobile when you are attending the class, because it is completely coding session. If you deviate for 2 minutes of time, then you cannot understand the next concept. If you deviate from the session, you can't understand the next concept. So you need to give 100% attention. You need to be very strict in order to attend this session. So concentration is very important. Otherwise, you cannot get the clarity. So it is not theory. It is completely coding session today. Okay, so we are going to develop a mini project on the microservices. So if anybody attending from mobile, please immediately join from your laptop and concentrate on the class properly. Okay, so I have created one application which I am going to use as service registry. So I'm going to use Eureka server as a service registry. For that, I'm using Spring Cloud Netflix library. Before going to start the coding, could you please confirm, is my voice clear for everyone? Could you please confirm, is my voice clear for everyone? My voice, my screen, my video, everything is clear? Very good. So I created one Spring Boot application. In this Spring Boot application, I added one dependency called Eureka server, and I added one more dependency called DevTools. That Eureka server dependency we are getting from Spring Cloud Starter Netflix library, and here boot application got created. So you can check in the pom.xml. In this Spring Boot application, pom.xml is available. There you can find out the dependencies I have added. Two dependencies I have selected, guys. One is Eureka server dependency I have selected. Another one is DevTools dependency I have selected. By default, test dependency also will be available. And you remember which version of the Spring Boot we are using. We are using latest version of the Spring Boot, that is 3.3.3. In the interview, they will ask you which is Spring Cloud version you are using. So when we are adding Eureka server dependency, Spring Cloud Starter Netflix Eureka server, this is the dependency that we are adding. This is the Spring Cloud library. So which version of the Spring Cloud you are using, that also you need to remember. 2023.0.3. So Java version 17, Spring Boot version 3.3.3, and Spring Cloud version 2023.0.3. So in the interviews, they will ask this question also. Are you using Eureka server in your project? Then if you say yes, then can you tell me which version of the Spring Cloud you are using in your project? So you need to remember this version number also. Okay, so project is created. Now let us go here. Start class is available, which is entry point for our boot application. Now here, this application class, this is start class of the Spring Boot, entry point for the boot application. So let me represent this application is working as Eureka. So for that, we are going to write one annotation called enable Eureka server. I'm writing one annotation which is called enable Eureka server. If I write this annotation, then this application will act as a Eureka server application, which we can call as service registry application, and we can call as service discovery application also. So let me import this annotation, enable Eureka server annotation. I'm importing the annotation called enable Eureka server annotation, which will represent this application is going to act as a Eureka server. Currently, I'm not changing the port number. Just let me do the Maven update. Update this project and run this application. Start class is available, right? Run this as a boot application and let us see Eureka server dashboard. Right click, run as boot application, run as Spring Boot application. So it will run with the embedded container. So that is a Tomcat. By default, we are going to get Tomcat as an embedded container. It will run on the port number 8080. So my Eureka server project is getting started. You can check the console. Bean factory is created. Tomcat server is started. Okay, what is the port number? With the port number 8080, it is getting started. Now it is exposing actuator endpoint also. Exposing actuator endpoint, we are getting some error. Cannot execute request on any known server. That is fine. Now you can see here our Eureka server application got started, which is using the port number 8080. Now let's go to browser and let us access localhost colon 8080. Localhost colon 8080. So when I hit this URL localhost colon 8080, can you see Eureka dashboard is coming? Are we able to access Eureka dashboard? Here you no need to add the web starter. If you add the Eureka server, by default it will take care of the Tomcat container. Web starter is not required because we are adding Eureka server. So when we add the Eureka server, it will take care of the web server which is required to run our application. Are you guys clear with my point? Are you guys clear with my point? We are able to create the boot application by adding one dependency, and we configured one annotation at the start class of the Spring Boot, and I'm able to start my application. My application is running. Eureka server I'm able to access. Eureka dashboard is available. So localhost colon 8080 Eureka server dashboard I'm able to access. Currently, any microservice registered with the Eureka? Do you have any clients with the Eureka as of now? No. Just Eureka server is available. There are no clients available. Who are going to act as a client for the Eureka? Our microservices. Flights API, hotels API, trains API, cabs API, or your credit card API, debit card API, net banking API, whatever the backend microservices we are going to develop, those backend microservices will register with the Eureka server. So Eureka server is available. It is running on the port number 8080. Let me change that port number to 8761. Why I am changing the port number to 8761? Clients will be auto registered with the Eureka. You don't need to register the clients manually. How to change it? Go to this properties file. So you can configure that port number in the properties file, or you can change the properties file to YML file also. Now let me change this properties file to the YML file. Application or properties file is available. You can convert this properties file to YML file. I think they removed that option. Earlier here, directly there will be one option called, yes, we have the option now also. Application properties, Spring option, convert to dot properties to dot YML. Currently, the properties files are outdated, guys. In the market, people are using YML files. So I am converting the dot properties file to dot YML. Spring converted to YML. Okay. Yes, the properties file is updated to YML file. Now let me configure a port number. How we are going to configure port number? Server.port. So YML syntax, server.port we are going to use. So the YML syntax we need to follow, and you can use control space if you don't know that syntax. So it is complete, it is computing that proposal. Server.port I need to configure. Generally server.port. Yes, that is the syntax. The port number I am configuring as 8761. The port number I configured 8761 in this YML. Okay, let us do the Maven update. Update this project, force update. Application or properties file is available. Let me delete that, it's not required. We are going with only application.yml. Yeah, properties file got deleted and I am using only YML file. Application name is available, server port is available. So application name is one property and server name, server port is the another property. Let me update the project. As we are changing the properties file or YML file, we need to update this Maven project, and let us run this application. Start class is available, run as boot application. Now it is going to start on the port number 8761. If you don't configure the port number, default port number, it is going to use 8080. So once the application is started, we can access Eureka dashboard. In the Eureka dashboard, it will show you what are the services which are registered with the Eureka server. Now you can see that Tomcat server is started with the port number 8761. Okay, application started with the port number 8761. Now let us go to Eureka server dashboard and refresh. Yes, so I'm trying to access this dashboard with the port number 8761. Yeah, Eureka server dashboard is loaded. In the Eureka server dashboard, here you can see one option, instances currently registered with the Eureka. That means what are the microservices, which microservices are acting as clients for the Eureka. That information you can see in the dashboard. What is the name of the microservice? How many instances available for the microservices? What is the status of the microservice? What is the URL of the microservice that we can identify. But currently, if you observe, one instance already registered. Which instance is registered? Same project is registered with the Eureka server. So I created a service registry application. It is acting as a Eureka server and it is also acting as a Eureka client also. I created one application. That application name is 01 service registry. Same application is registered with the Eureka client also. So that this application is acting as a server. This application is acting as a client also. I don't want this application as a client. I want other applications to register as clients. Okay. So currently what is happening? I created one Spring Boot application. In that Spring Boot application, I added Eureka server dependency, which is coming from Spring Cloud Starter Netflix library. And I added DevTools to reload the server. In the boot start class, I added one annotation called enable Eureka server annotation. And I configure the port number. And I configure the port number as 8761. So when I run this application is acting as a Eureka server and it is also acting as a Eureka client. That is the reason in the Eureka dashboard you can see instances currently registered with the Eureka. Same application is registered as a client also. I don't want the same application to register as a client. Okay, this should act as only server. It should not act as a client. My clients are actual microservices. How to stop this application to register as a client? For that, we need to write one property, Eureka.client.register with Eureka false. I'm writing Eureka.client.register with Eureka false. I am going to write. If I write Eureka client register with Eureka false, then what is going to happen? This application will act as only server. This application will not act as client. Now you see no instances available. Earlier, same application displayed as a client also. Eureka server, Eureka client. What is the role of Eureka server in the microservices? Eureka server is used to provide a dashboard with the information of all the microservices available in the application. Which microservice available? What is the name? What is the status? What is the health? How many instances available for one microservice? What is the URL of the microservice? Everything we can access from the Eureka dashboard. So why we are configuring Eureka's port number as 8761, guys? What is the reason for configuring Eureka port number as 8761? If a service registry project port is 8761, then clients can discover service registry and will register automatically with the service registry. If service registry running on any other port number, then we have to register clients with the service registry manually. Okay, note 1 and note 2. You can run the service registry on any port number. So what is the difference? If you run the service registry on the port number 8761, then clients can discover service registry and will register automatically with the service registry. If a service registry project running on any other port number apart from 8761, then you need to register clients with the service registry manually. Once your application is started, you can access Eureka dashboard by using this URL. 8761 is the port number. Are you guys able to understand how to develop a service registry application for our microservices? So first, what is a service registry? Yesterday we learnt that concept theoretically. Service registry is used to maintain all the microservices information at one place by using a dashboard. Name, status, URL, and the health of the microservices we can access at one place. It is also called as service discovery. We can use Eureka server as a service registry. How to use this Eureka server as a service registry? This Eureka server provided by Spring Cloud Netflix library, not our OTT Netflix guys. That is different. This is different. OTT Netflix is different. Spring Cloud Netflix is different. Eureka server provided by Spring Cloud Netflix library, and it is providing user interface to get all the microservices information. How we created the service registry? I'm repeating once again. I created one boot application. At the time of creating the application, I selected Eureka server dependency and I selected DevTools also. Then in the start class, I added one annotation and I configured port number as 8761. Then I'm starting my application, which is running with the Tomcat server on the port number 8761. Why I am using port number as 8761? If the port number is 8761 for Eureka, that microservices can discover the Eureka server, can register automatically. If your port number is not 8761, then clients cannot register automatically. Manually, we need to register the clients. So with this, my Eureka server project is ready. I'm able to run this application and I'm able to access my Eureka dashboard. My Eureka server is ready, but currently no clients available for the Eureka. Earlier, same application acted as a server as well as client also. That's why I have disabled that registration by using Eureka client register with Eureka false. So this application, the first application I created, it should act as a server, not as a client. So that's why I'm configuring Eureka client register with Eureka is equal to false. So this is my application.yml file. How I created application.yml file? I have used the IDE option. I converted the properties file to YML file directly. The properties file concept is outdated in the market. For the configurations, people are using YML. And currently, the YML file is available within the project. This is not recommended. This is our first project. So that's why YML file is available within our project. If a YML file is available within our project, then our application is tightly coupled with the YML. In the real-time projects, the YML files, properties files will be available in the GitHub or outside of the project. How to load the YML files from outside of the project? That's where yesterday I told you one concept called config server. What is the purpose of config server? Config server is used to read the properties from outside. So we should not keep the properties file, YML file inside the project. If you keep them inside, application is tightly coupled with the properties. Tomorrow, if you change the properties, you need to recompile the project, you need to repackage the project, you need to redeploy the project. Maintenance will become difficult. To simplify the deployment process of our application, properties files we need to separate from the application. How can we separate and how can we load it? That's where config server concept will be used in the project. Are you able to understand what is the service registry and why we are using service registry and how we are able to develop our service registry application? If you are clear with the first microservice development, can you respond in the chat box? If you are clear with the service registry development, can you respond in the chat box so that I will go for the next microservice development? Theoretically and practically, you should get the clarity. If anybody joining from the mobile, you can't concentrate on the class. You can't see the code, whatever I'm writing. Today, there is no theory. Today's session is completely practical session. We are developing one project. If you don't utilize, then it is your bad luck. I can't do anything. I'm giving my 100%. I'm putting my 100% efforts to deliver the microservices project. Whatever the theory we have learned, today we are implementing that. How to register manually? I will show you that. If I develop one client application, then I will show you how to register a client manually with the Eureka if the port number is different. Are you clear? I'm not getting the response. I'm not getting the response from the people who are attending in the Zoom class and the people who are watching YouTube live. People who are watching in the YouTube live, please like this video and support us. If you give one like, then I will get more energy. Good. Fine. So I hope you got this point. If project port number is 8761, our microservices can register automatically. If a port number is not 8761, manually we need to register. How to register manually? I will show you by developing one client application. Now my Eureka server is running on the port number 8761. Okay. Now next one, let us start the admin server development. So first microservice development is completed, guys. So this first microservice is running on the port number 8761. Why I am using port number 8761? I already told you. Clients can auto register with the Eureka if a port is 8761. Next, let me go and develop admin server here. Let me go and develop the admin server. What is the role of admin server in the microservices? Admin server is used to monitor and manage all the microservices at one place. Our application can contain 30, 40, 50, 100 microservices also. All those microservices I want to monitor at one place. For that we are going to use admin server. Admin server will provide a beautiful user interface to access all the microservices actuators at one place. What we can monitor by using this admin server? We can do health checks of the microservices. We can check the config props of the microservices. We can check URL mappings of the microservices. We can check the beans loaded by the microservices. We can change the log levels of the microservices. We can download thread dumps. We can download heap dumps of the microservices by using this admin server. Then how to develop admin server application? I'm going to develop a second microservice here. First microservice is service registry, which is Eureka server. Okay, steps to develop admin server application. So we need to create one Spring Boot application and we need to use that application as an admin server, and by using that we are going to monitor and manage all our applications at one place. So how to develop a admin server project? Create one boot application with below dependencies. Okay, we need to create one Spring Boot application with admin server dependency. At the time of creating the project only, we are going to configure one dependency called admin server. And to enable the admin server, we are going to configure, in this project we will use one annotation called enable admin server annotation at the start class. For Eureka application, we use annotation called enable Eureka server. For admin server project, we will use annotation called enable admin server. Then changing the port number, it's not required, it is optional. By default, we'll go with 8080. But two projects cannot run on the same port number. It's better to change the port number. Once it is configured, then you can run your application and you can access your application in the browser. Then we can see admin server UI. So create one Spring Boot application with admin server dependency. Create one Spring Boot application with the admin server dependency. Then this dependency we can select while creating the project. And once the project is created, to represent this project as an admin server project, we are going to configure enable admin server annotation at the start class of the application. Then we are going to change the port number. Changing the port number is optional. Then you can run the application. Once the application is started, you can access its URL in the browser and you can see admin server dashboard. Okay, let me go and develop that project. Second application I am going to develop 02 service. This is Spring Starter project. 02 project I am going to create. I am going to name it as admin server. I'm going to name it as admin server Maven project. Packaging is jar, Java 17, group ID and base package. Click on next. Yeah, dependencies. So let me search for the dependency called admin server. Yes, code centric Spring Boot admin. Actually, this is Spring Boot admin server we are using. This is not from the Spring Boot libraries, guys. code-centric company provided this admin server. Spring Boot is integrating with that admin server. So actual this Spring Boot admin server topic that we are using, this is developed by code-centric company, and Spring Boot integrated that library for us in order to monitor and manage our microservices. So you see, required for your application to register with a code-centric Spring Boot admin server interface. So I'm selecting Spring Boot admin server, sorry, not admin client, guys. So we need to select admin server dependency. Admin server will be available, admin client will be available. So code-centric Spring Boot admin client, yes. Admin server dependency we need to select. So when we are developing the microservices, then we are going to select the client dependency. For Spring Boot admin, client available, server available. Currently we are developing the server. Can you see this? A community project to manage and monitor your Spring Boot applications. It provides a UI on top of the Spring Boot actuator endpoints. So in the Spring Boot, we are having actuators concept to monitor and manage our applications. On top of those actuators, this user interface will be provided by admin server. So by using this admin server, all the microservices can be monitored, can be managed at one place. Who provided this admin server? Admin server provided by code-centric company. It is a community project. Spring Boot people has taken that community project and integrated with the Spring Boot. So Spring Boot will give actuators. To monitor the actuators, to access the actuators at one place, this admin server project we are going to create. Admin client, admin server. Currently we are creating admin server. Client we are going to use for microservices. When I am going to develop a microservice, then I will use client dependency. Currently, let me go with admin server dependency. Click on next, click on next one. Dev tools dependency also we can add. If any changes are required, then the server will be automatically reloaded. Two dependencies I'm selecting. Dev tools, admin server. Click on next and finish. So with this, my second microservice is getting created, which is admin server project. Now, here also we need to configure the annotation, that is enable admin server annotation. To at the start class of this Spring Boot, we need to configure that annotation called enable admin server. Project is getting created. Go to pom.xml file and let us see the dependencies which are available. Now, Spring Boot admin version 3.3.3. Spring Boot version 3.3.3, admin version is also 3.3.3. There is no cloud dependency here because admin server not from the Spring Cloud, admin server from the code-centric, Eureka server from the Spring Cloud. Okay, so this is admin starter server dependency added, dev tools dependency is added. That's it. Now go here, go to the start class of the application, configure one annotation, that is enable admin server. Let us write that annotation, enable admin server. Enable one annotation called enable admin server. That's it. Port number by default 8080, right? I'm going to change it. You can configure any port number. Convert the properties file to YML file. Spring, convert to dot properties to .yml. YML file is available. Still properties file available. Let me delete it. I don't need the properties file. I'm going to use YML. 02 admin server. Configure server port number. Configure server port number. Server dot port. Configure server dot port. You can give any port number for this. I'm giving 1111. Okay. You can give any port number. I'm giving the port number as 1111. Good. Now let me do the Maven update. Update Maven project because the YML file content got modified. Whenever you change the properties file or YML file or pom.xml, let's do Maven update so that it will download the latest dependencies. Right. So with this, my admin server project is ready. Let me go to the start class and let me run this application. Right click, run as boot application. Admin server project I am starting. For admin server, the port number I configured as 1111. It's not mandatory. You can use any port number. There is no problem. You can use any port number, there is no problem. Are you able to follow me? Are you able to follow me, guys? Now Eureka server dashboard is available. Currently no instances available with the Eureka. Now let me go and access my admin server. Localhost colon 1111. 1111 is the port number I configured for my admin server. Yes. With this I'm able to access my admin server dashboard. Currently admin server available, but there are no applications available with the admin server. No applications registered with the admin server. So what is the meaning of that? Eureka server is ready, no clients available, admin server is available, currently no applications are registered. What is the meaning of no applications registered? Our actual microservices are not available. Client applications are not available. The client applications are currently not available. Are you able to follow this? Are you able to follow this? Eureka server is ready, admin server is ready. Eureka server running on the port number 8761, admin server is running on the port number 1111. Admin server running on the port number 1111. What is the process we are following to develop this admin server? I created boot application with admin server dependency and I configured one annotation called enable admin server annotation at the start class. And I have changed my port number also. I configured port number as 1111, but it's not mandatory. You can give any port number. There is no problem. Then we are going to run our application and we are able to access that application in the browser. This is the URL to access our admin server dashboard. Currently in the admin server dashboard, no clients are available. Eureka is running on the port number 8761. Admin server is running on the port number 1111. Eureka is running on the port number 8761. Admin server is running on the port number 1111. So what is the purpose of this Eureka and what is the purpose of this admin server? Eureka server will provide you all the microservices information at one place. Admin server will give you user interface to monitor and manage your microservices at one place. Is this clear for you? Is this clear for all of you? Come on, guys. Is this clear for all of you? What is the purpose of admin server and what is the purpose of this Eureka server? If you are clear, please respond in the chat box. Then I will develop, I will work on Zipkin server setup now. I will work on Zipkin server setup now. If you are clear, please respond in the chat box. If you are clear, please respond in the chat box. Come on. If you are clear, please respond in the chat box. What is the purpose of Eureka server and what is the purpose of admin server that we have created? I'm not getting response in the chat box. Admin server is used to monitor and manage all the APIs at one place. Currently, Eureka server is available and admin server is available. Currently, Eureka server is available, admin server is available. Next one, let us go for Zipkin server. So what is the meaning of Zipkin server? What is the Zipkin server, guys? Zipkin server is used for distributed tracing. Zipkin server is used for distributed tracing. You see in the diagram here, admin server is ready, Eureka server is ready. Eureka server maintains all the microservices information at one place. Admin server is used to monitor all the APIs at one place. Now I'm going with a Zipkin server. What is the purpose of Zipkin server? Yesterday we discussed theoretically. Zipkin server is used for distributed tracing of our requests. Zipkin server is used for distributed tracing of our requests. How much time taking to process? How much time taking to process one request? How many microservices involved in the request processing? Okay, and which microservice is processing the request quickly? Which microservice is taking more time to process the request? That information we can identify by using Zipkin server. Which microservice is processing the request quickly? Which microservice is taking more time to process the request? How many microservices involved in one request processing? We can understand by using Zipkin server. So how can we work with this Zipkin server, guys? So actually Zipkin server project you no need to develop. Okay, so Eureka server project we developed, admin server project we developed, but for the Zipkin server we no need to develop that project because Zipkin project is already available in the internet as a jar file. So Zipkin server jar file is already available. You can download that Zipkin jar file from the internet. Once the jar file is available, you can run that jar file directly. Zipkin is also a Spring Boot application, but it is a ready-made project. Already they developed it and they provided the Zipkin jar in the internet. What you need to do, you just download the Zipkin jar file and you run the Zipkin jar file by using this command. So the Zipkin server by default will run on the port number 9411. Zipkin server will run on the port number 9411. So once the Zipkin server is started, you access your Zipkin server dashboard by using below URL. So if you can follow these 4 steps right, then your Zipkin server will be ready. If you use these 4 steps now, then your Zipkin server will be ready. Download Zipkin jar file. This is the URL for that. Run the Zipkin jar file using this command. Then Zipkin server will run on the port number 9411 and you can access the Zipkin server dashboard with this URL. So let me go to this URL and let me download the Zipkin server from internet. Go to this, use this URL, paste in the browser. Yes, we are able to access Zipkin website. So they are telling that you can download the Zipkin jar. If you have Java 17 or a higher version installed, you can download the latest release of the Zipkin jar. If you click on the latest release here, the Zipkin jar file will be downloaded into your system. Now you can see the Zipkin jar file is getting downloaded in my system. So that is a Spring Boot project. It is downloaded as a jar file. Let me open. In my downloads folder, that Zipkin jar file is downloaded. You can check this. So Zipkin jar file is downloaded. Zipkin server 3.4.1 exec.jar. Let me take this Zipkin jar file. Let me keep into our folder classes. Yeah, something like 27 JRTP. Here I am keeping this one. My Zipkin server jar file is available. How to run this jar file? Let me open a command prompt from the location where the jar file is available. My jar file is available in this location, e-classes 27 JRTP. So you can check it. You can check it that Zipkin jar file is available in this location. 27 JRTP folder is available. In this folder, Zipkin server jar is available. How to run this jar file? Java space -jar space Zipkin server.jar. So the jar file is downloaded from the internet. Now I am running this jar file. Run this jar file. It will start the Zipkin server. Yes, this is the Zipkin banner. Zipkin server is getting started and the Zipkin server will use port number 9411. Okay, the Zipkin server is getting started. You can see the port number. It is running on the port number 9411. You can access the Zipkin server by using this URL. Let's go to browser, localhost colon 9411. Localhost colon 9411. We are able to access our Zipkin dashboard. What is the purpose of Zipkin dashboard? to check the traces. Distributed tracing we can achieve by using Zipkin server. So we are going to develop the microservices. How much time our microservice is taking to process a request? How many microservices involved in our request processing? We can track that information by using Zipkin server. So with this, Eureka server is ready, admin server is ready, Zipkin server is also ready. But our microservices are not available as of now. Just we developed Eureka server, admin server. Eureka server running on the port number 8761, admin server running on the port number 1111. My Zipkin server is running on the port number 9411. Are you guys clear? Are you guys clear with the Eureka server, admin server, Zipkin server, and what is the purpose of them and how to work with them? Admin server is used to monitor and manage all the APIs at one place. Zipkin server is used for distributed tracing. Zipkin server is used for distributed tracing. Admin server is used for monitoring and managing the APIs at one place. Service registry, it is used to maintain the services information at one place. So Eureka server is available running on port number 8761. Admin server available running on the port number 1111. Zipkin server is available running on the port number 9411. Zipkin server project I have not developed. I downloaded the jar file of the Zipkin server and I have executed that jar file. So this is the URL from where you can download the Zipkin jar. Then you run this command. Go to the location of your jar file. Then run this command. Then Zipkin server will start. Its port number is going to be 9411. Then you can access the Zipkin dashboard. Are you guys clear with my point? Are you guys clear with my point? Are you guys clear with my point? What is Eureka? What is Eureka server? And what is admin server? And what is Zipkin server? Come on, respond in the chat box. Yes. Next one, config server is available, guys. This part we will develop later point of time because config server itself will take 1 hour to understand. So config server project we will develop separately. So first we are going to develop our microservices. I will develop 2 microservices now. Whatever the microservices I'm going to develop, this microservice will act as a client for service registry, will act as a client for Eureka server. I mean, as acting as a client for admin server, will act as a client for the Zipkin server. As of now, Eureka server is ready, admin server is ready, Zipkin server is ready. Now I want to develop actual microservices, API 1 and API 2. These API 1 and API 2 are going to act as clients for Eureka server, client for admin server, client for Zipkin server. Okay, so let me develop first microservice. Microservice nothing but our REST API. What is the meaning of microservice, guys? Microservice nothing but our REST API. So let me develop one simple REST API. Let me name it as welcome API. If you send the request to that welcome API, it will give you welcome message. Okay, so how to create one welcome API and observe the diagram. Whatever the welcome API I'm going to develop, that welcome API acting as a client for Eureka, client for admin, client for Zipkin. So one microservice is going to act as a client for Eureka server, act as a client for admin server, act as a client for Zipkin server. Why that microservice should act as a client for these many servers? Eureka server should provide the information about the microservice. If our microservice acting as a client for the Eureka, then only Eureka can display name of the service, status of the service, URL of the service. If our microservice is registered with the admin server, then only admin server will provide the UI to monitor and manage our microservice. If our microservice acting as a client for the Zipkin, then Zipkin server will provide the distributed tracing. How many requests are coming to our microservice? How much time it is taking to process each request? which request it is for which request it is taking less time, for which request it is taking more time. All that information we can access. So if you want to access this information of your microservice should act as a client for Eureka, should act as a client for admin server, should act as a client for Zipkin server also. Are you guys able to follow me? Eureka server, admin server, Zipkin server. Whatever the microservice we are going to develop, that microservice should act as a client for all these servers. So how to develop our microservice which is going to act as a client for Eureka, for admin, for Zipkin. Let's start the development. So first let us create one Spring Boot application with several dependencies, guys. You need to create one Spring Boot application with the discovery client dependency and with the admin client dependency. Our application should act as a client for Eureka server. So Eureka discovery client we need to add. Our application should act as a client for admin server. Admin client dependency we need to add. Our application should act as a Zipkin client. So we are going to add a Zipkin dependency. So to represent our microservice is a client for Eureka. Eureka client dependency we are adding. To represent our application is admin client. Admin client dependency we are adding. To represent our application as a Zipkin client, Zipkin dependency we are adding. With these three dependencies, our microservice is going to act as a client for Eureka server, for admin server, for Zipkin server. Then in our microservice, I need to develop one REST controller. Microservice nothing but a REST API. To develop a REST API, REST controller is required. To develop the REST controller, I'm using web starter dependency. If any changes required in the application to restart, if any changes if you make any change in the application, server should be restarted. For that, I'm using dev tools. And to monitor and manage application, actuator. If you add the actuator, then admin server will provide the UI to access the actuator endpoints. So whatever the microservice we are going to develop, for that microservice we need to add all these dependencies. So in the future, config server will come, then config client dependency also we need to add. Look at the first step to develop a actual microservice. Steps to develop the welcome API. Eureka discovery client, admin client, Zipkin, web starter, dev tools, actuator. So total 6 dependencies we are adding for our microservice development. Microservice nothing but one REST API. Microservice nothing but one REST API. Are you guys able to follow me? Are you guys able to follow me? I'm not getting response. Anybody feeling it is difficult? I'm trying my best to explain you. If you are not able to understand, let me know. I will repeat once again. Your Sunday should not be wasted. You are giving 2 to 3 hours of time for me. So there should be some benefit. You need to get some benefit out of this. I don't want to waste your time. Okay, whatever the concept I'm explaining, that should be injected into your brain. If you are not able to understand, then I will repeat that once again. It is a free workshop. Sir will not teach completely. No. Whatever that I have promised, I'm going to complete everything practically. Very good. Now let me create my microservice application, guys. Actual as of now, I configure my servers only. Service registry, admin server, Eureka server. Servers I configure for managing purpose. For managing the microservices, my servers are ready. Now I need to develop actual microservice. So let me go here, file, new, Spring Starter project. Actually, I'm giving the name as a 04, guys. 03 is a Zipkin. Zipkin we are not creating. Zipkin jar file we downloaded. So let me give the name as a 04 welcome API. I'm giving the name it as welcome service or welcome API. This is our actual microservice. Okay, dependencies we need to add very carefully, guys. Dev tools, first let me add one by one. Eureka discovery client. My microservice should act as a client for the Eureka. So that's why I'm selecting one dependency called Eureka discovery client. What is this Eureka discovery client? REST-based service for locating the services for the purpose of load balancing and failover of middle tier servers. So Eureka discovery client dependency we are adding. So with this dependency, we can make our application as a client and it will register with the Eureka. Next one, I want to make this application as a client for admin server also for managing and monitoring purpose. So let me add one dependency called admin server dependency. So admin client server is already available. We need to add the client dependency. Code centric Spring Boot admin client dependency I have added. Okay, required for your application to register with the admin server instance. Server is already running on the port number 1111. So this welcome service I'm going to make as a client for the admin server. And Zipkin server already running on the port number 9411. So my microservices should act as a client for the Zipkin. So observability purpose. So Zipkin dependency I'm adding. Enable and expose span and trace IDs of the Zipkin. So select the Zipkin dependency. Okay, 3 dependencies I have selected. Discovery client dependency, admin client dependency, Zipkin dependency. Now web starter, dev tools, actuator. Web starter to create a REST controller, dev tools to reload the server, to restart the server, actuator for monitoring endpoints we need to provide. Now let me select web starter, Spring Boot, Spring web dependency I need to select. Spring web dependency I have to select. Yes, Spring web dependency I selected. Dev tools dependency I am selecting to restart the server when there is some change in the application, and actuator I am selecting. Spring Boot actuator, providing the production ready features of the application. Built-in actuator endpoints available. So total 6 dependencies I selected. In future, config client also will be added. If config server project is ready, then in our microservice we need to add config client also. Config server is little confusing topic, guys. I will discuss that separately. Click on next and click on finish. So with this, my microservice is created. Just project is created. I want to represent this project as a Eureka client. To represent this project as a Eureka client, I'm going to configure discovery client annotation at the start class. So for the server, enable Eureka server. Now this project enable discovery client annotation. That means this application is going to act as a client for the Eureka server. Server is running on the 8761, it will be registered automatically. If server running on the different port number, manually we need to register. How to register manually? I will show you. Once this Eureka's client dependency is added, then we need to create one REST controller for processing the request and configure the properties in the YML. Server port number, application name, admin server URL, that Eureka server URL, actuator endpoints we need to configure. Let's do that. First, let me go here. My welcome service is ready. Go to pom.xml and see the dependencies which are available. See the dependencies which are available here. So what are the dependencies we configured? Yeah. Actuator dependency configured, web starter dependency configured, admin client dependency configured, Zipkin we added na, micrometer dependency is added, Eureka client dependency is available, dev tools dependency available, test is coming by default. So total 6 dependencies we have added. Admin version, cloud version, Spring Boot version. All these version numbers we need to remember. Java version we are using 17. For Spring Boot 3.x version, Java 17 is mandatory, guys. Now go to start class of our application. Let me represent this application as a Eureka client. For this, we need to write one annotation, that is enable discovery client. Yes, I'm writing one annotation called enable discovery client annotation. Okay, next, let me change this properties file to YML file. and I can configure port numbers here. Application name is available, which is 04 welcome service is available. Configure port number for this application. Okay, so the port number I will configure server.port. Server.port number I am giving this one as 8081. Server port number I am configuring as 8081. Application name welcome service. Server port number 8081. This application should register with the Eureka server. Do I need to register manually or no need to register manually now? Guys, my application should register with the Eureka server manually. No need to register with the Eureka server manually. Eureka already running on the 8761. No need to register manually. Automatically it will register. Suppose if Eureka server is not running on the 8761, then we need to register manually. How to register our application with the Eureka server manually? For that we should write one property. What is that property we need to write? Eureka dot client dot service URL dot Eureka dot client dot service URL dot default zone. That we need to configure http colon localhost colon 8761/Eureka. So if you write this property, then our microservice will register with the Eureka server. But if Eureka server is 8761 port, this property not required. It will automatically register with the Eureka. If your Eureka server port number is anything something like 9090, then this property we need to write in the microservice. This is called manual registration with the Eureka server. If you write this property, then your application will register with the Eureka server manually. If it is 8761, you no need to write this property. Are you guys able to understand? Eureka client service URL. That means where is Eureka server available? You need to tell the URL of the Eureka. And remember that point. I already told you. If Eureka server is running on the 8761, client will be auto registered. If Eureka server running on the any other port number, manually we need to register. How to register manually? In our microservice we should write this property. Then only it will be registered with the Eureka server. Now my application should register with the admin server also. How to register with the admin server? Spring dot boot dot admin client dot URL. Okay, I need to specify client URL. So where is your admin server available? The admin server is running on the port number 1111. http colon / localhost colon 1111. So this is the admin server URL. I'm configuring admin server URL. My application should register with the Eureka server. My application should register with the admin server. My application should register with the Zipkin server. My application should run on the port number 8081. And my application should have actuator endpoints. How to configure actuator endpoints for our application? To configure actuator endpoints for our application, we will use management dot endpoints dot web dot exposure dot include star. I'm going to include all the actuator endpoints. I want to expose all the actuator endpoints for my application. So this is the configuration we need to do in the YML. Application name, nothing but our microservice name we configured. So admin server URL we configured, port number we configured, Eureka server URL we configured, actuator endpoint also we enabled and exposed. Currently this property optional because it is running on the 8761. Client will auto register with the Eureka. If Eureka running on the 8761. If Eureka not running on the 8761, client should be registered manually with the Eureka. Are you able to follow me? Are you able to follow me? How I am developing my client application? Yes. So I developed my client application here. In this, I will create one REST controller also. New class, welcome REST controller I am going to create. I'm using the package as .controller. Yes, welcome REST controller to handle the request and response. Welcome REST controller I am taking. To represent this class as a REST controller, I will use one annotation called @REST controller annotation. Let me write one method, public string get welcome message. This is my actual REST API, guys. Public string get welcome message. String message is equal to welcome to Ashok IT. Welcome to Ashok IT. Now let me map it to a get request @get mapping @get mapping / welcome. The URL pattern I am giving as /welcome and return that message. You can return the message directly or you can return response entity also. I'm returning the message directly. Okay, good. So with this, we are done with our microservice development. So what are the steps we have completed here? We created boot application with these dependencies. We configured enable Eureka server dependency. We configured enable Eureka server dependency, Eureka client enable discovery client dependency, and we created REST controller and we configure properties in the YML file. Okay. Good. So these are the properties I configured in my YML file. So application name, admin server URL, port number, Eureka server URL, endpoints I have enabled. So as I told you, this Eureka's configuration optional now because Eureka running on the port number 8761. Change it, remove that. Okay, we are good. We are good with this. Our applications are ready. Admin server is ready. Eureka is ready, Zipkin is ready. Finally, I'm going to run actual microservice. Okay, so this one, do the Maven update because YML file is modified. Force update of this project, updating this Maven project. Yep, project is updated. Check the Eureka. Currently, any client is registered with Eureka, guys? Currently, any client is registered with the Eureka. There is no client registered with the Eureka. There is no client registered with the Eureka. Go to admin server. Currently, any application registered with the admin server? No, no application registered with the admin server. Can you go to Zipkin server? Currently, any distributed traces are available in the Zipkin? No. Distributed traces also not available in the Zipkin. So first time I'm going to run actual microservice. So microservice nothing but a small API, a small REST API which will perform only one action. I developed welcome REST API. How I developed welcome REST API? This is the process. I created application with these dependencies and I configured enable discovery client annotation. I created one REST controller, very simple REST controller, which is having a get request method called /welcome. If you send the request to that method, it will return the response as welcome to Ashok IT. And I configure properties in the YML file. Application name, admin server URL, port number, Eureka server URL, actuators I have enabled. That's it. Now, let me run this application now. Before running, I have already shown you. In the Eureka, currently no client is registered. In the admin server, currently no client is registered. In the Zipkin, currently no information is available. Now let me go and run our first microservice, guys. So if you see in the diagram, so our Eureka server running on the port number 8761, admin running on the port number 1111, the Zipkin running on the port number 9411. Now I have started my API. So this API is running on which port number now? This API is running on the port number 8081. The first microservice we developed, first API. It is running on the port number 8081. Go and start it. Go to the start class. Go to the start class, which is application.java. Right click, run as boot application. Actual microservice we are running. Yes, our welcome service is running. How can we check welcome service is running or not? Go to Eureka, refresh Eureka dashboard. Can you see in the Eureka dashboard, welcome service is registered? Guys, can you see in the Eureka dashboard my welcome service is registered? In the Eureka dashboard my welcome service is registered or welcome service is not registered? Welcome service is registered in the Eureka dashboard, not registered in the Eureka dashboard. Come on, respond. So can we say welcome service is acting as a Eureka client? Can I say welcome service is acting as a Eureka client? Okay, now go to admin server. Can you see? Earlier it was saying no applications registered. Now in the admin server, welcome service is available. One instance is available. Open this one. Okay, welcome service is available. Now let me click on this welcome service. So this is the monitoring. Wall board is available, applications available, welcome service available in the admin server. Open this welcome service now. Open this welcome service, application Spring Boot admin server, wall board, applications. Yes, application is available, welcome service is available, localhost colon 1111. Yes, welcome service is registered with this admin server. Let's go here, environment, beans, configuration properties, dependencies, loggers, all this information we can access and we can monitor our application. What are the URL mappings available in your application? What are the cache available in your application? What the metrics of the application we can get, environment details of our application, configuration properties, loggers. Currently, the application log level is info. We can change it to debug. Without restarting the server, we can change the log level of the application. This is one interview question. How can you change the log level of the application without restarting the server? So that's where admin server comes into picture. By using this admin server, we can monitor our application and we can manage. So what are the threads information available? What are the processes running? How the garbage collection is working in our project? What is the heap memory in our application? What is the non-heap memory in our application? All the memory details, logger details, JVM details, thread dump, download the thread dump of our application, what all the threads running in our application, and download the heap dump. Heap dump contain the sensitive data, so you can download the heap dump of the application. You can download the thread dump of the application. What are the URL patterns available in our application? So dispatcher servlet acting as a front controller for our application. All these kind of things we can access by using this Spring Boot admin server. But what the Eureka server providing? Eureka server is telling you what all the microservices available, what is the status of the microservice, what is the name of the microservice, what is the URL of the microservice that we can access by using Eureka. Admin server will give you the facility to access the actuator endpoints at one place with the beautiful UI. Go to Zipkin, click on the run query. Zipkin traces how many requests came to our application, when the request started, for when the request came to our application, how much time it has taken to process the request. I access the actuator endpoints of our application. So what request came to our application, when that request came to our application, at what time, what date, what time the request came for our application, how much time it has taken to process that request, everything we can access by using Zipkin dashboard. Eureka will give you microservices information, name, status, URL, all that. Then admin server will give you actuator endpoints access. Zipkin server will give you the time taken to process your request. So for your microservice, what request came, when the request came, at what date, what time the request came for our microservice, how much time it has taken in order to process that request. All this information we can access by using this Eureka server, admin server, and Zipkin server. Are you guys able to follow me? Are you able to see the microservice we have created now? Are we able to see the microservice that we have created now? Are we able to see the microservice that we have created now? I'm not getting the response from the people. I'm not getting the response from the people. Now you understand the purpose of Eureka server, admin server, Zipkin server, how they are helping us in the microservices. Are you able to understand the purpose of them? What is the purpose of Eureka? What is the purpose of admin server? What is the purpose of Zipkin server? Is it clear? People who are watching in YouTube, able to follow me? I think 100 people are watching in the YouTube live. 97 people are watching in the YouTube live. Are you guys able to follow me? And please give me a like for the video. That will give more energy that you are able to follow me. Give the like for this video. What people who are attending in the Zoom, are you able to understand? Yes. Just if you add the Zipkin dependency, that is sufficient. Our microservice is automatically registered with the Zipkin server. I have not configured Zipkin URL in our microservice, guys. If you see the properties file or YML file, is there any URL of the Zipkin server in our YML? Is there any URL of Zipkin server? No. Automatically, our application is registered with the Zipkin server. If you add the Zipkin client dependency, automatically it will register with the Zipkin server. Am I configuring Eureka server URL or I am not configuring Eureka server URL? Am I configuring Eureka server URL? I'm not configuring Eureka server URL. I'm not configuring Eureka server. So then how our application registered with the Eureka server? How our application registered with the Eureka server? Because of 8761 port number. If Eureka running on the different port number, then we need to register that manually. Do you know how to register manually? One property we need to add. I have given the property. You need to give the URL of your Eureka server for this property. Then your application registered with the Eureka server manually. Okay. So are you good with this development? Are you good with this development now? So once this is done, run the application and check in the Eureka dashboard. It is displaying in the Eureka dashboard. Check admin server dashboard. We are able to access our application details in the admin server. And we are able to send the request to the actuators. And you can access your REST API also. Localhost colon 8081/welcome. Localhost colon 8081/welcome. Welcome to Ashok IT. This is the actual REST API method. We are able to access that REST API method also. We are able to access our REST API method. Now see here, welcome service got the HTTP GET request. How much time it is taking for processing that request? That complete information we are able to access. So 23 milliseconds it is taking in order to process our HTTP GET request. Go to admin server. It will give you the information of your application. Actuator details you can access. Info endpoint is not enabled. So this is going to give you actuator endpoint details of your application. And Eureka server will give you what is the API is available, how many instances available, what is the status, and what is the URL of your microservice. We can see in the Eureka dashboard. Okay. Now, So with this, we are able to understand how to develop one microservice, which is acting as a client for Eureka server, acting as a client for admin server, acting as a client for the Zipkin. So if you just add the Zipkin dependency, it will register with the Zipkin server. If you use enable service discovery client, it is registering with the Eureka server. Okay, are you clear with our microservice development? So total 4 projects are running in my system. Eureka server project is running, admin server project is running, Zipkin server project is running, my welcome REST API is running. So total 4 projects are running in my system. That means we can say 4 microservices are running in my system. One is Eureka server, second one is admin server, third one is Zipkin server, and fourth one is welcome REST API. 4 microservices are running, and 4 microservices are running in 4 different servers with 4 different port numbers. Eureka running in the Tomcat with port number 8761. It is not our Tomcat, it is embedded Tomcat. Eureka server running on embedded Tomcat server with 8761. Admin server running in one embedded Tomcat server with the 1111 port number. Zipkin server running in another Tomcat server, embedded Tomcat server with 9411 port number. My welcome REST API, my welcome microservice running in embedded Tomcat server with port number 8081. So total 4 servers are running in my system. 4 microservices are running in my system. Able to follow this? You can check the CPU utilization because 4 processes are running in my system. Go to the task manager, performance, CPU utilization, it is increasing. So around 30 to 40% of CPU is utilized in my system because 4 servers are running, 4 microservices. Every microservice running in a separate server. Every microservice running in a separate server. Now, can we develop one more microservice, guys? Can we develop one more microservice now? Same process, but one dependency I will add extra, Feign client I will add extra for the inter-service communication. So I'm going to develop another microservice which is used for inter-service communication. I'm going to develop another microservice. Okay, that microservice is going to maintain inter-service communication. So what is the meaning of inter-service communication? One microservice is going to communicate with the another microservice. For that we are going to use Feign client. Okay, can we develop one more microservice now? Come on guys, can we develop one more microservice? I'm not getting response. Yes. So that this time I'm going to develop one microservice with a name called Greet API. I'm going to develop one microservice with a name called Greet API. The procedure is same. The procedure is same. Create a boot application with below dependencies. Create a boot application with below dependencies. One extra dependency I will add, that is called Open Feign dependency. It is a new dependency I am adding, which is called Open Feign dependency. What is the meaning of this Open Feign dependency? It is used for Feign client. What is the meaning of Feign client? Feign client is used for inter-service communication. I'm using one dependency called Open Feign, used for inter-service communication. The remaining complete process is same. Configure this annotation, create a REST controller, configure the properties in the YML file, run the application and check it. That's it. Only one thing different, one thing extra, Open Feign dependency I have added. Remaining all the process is same. Steps to develop the Greet API, enable discovery client. Here Greet REST controller I am going to create. Here I am going to use the message as greet, get greet message, and I will give the message as good morning. That's it. Yeah. Create a Greet REST API. Greet microservice I am creating. These are the dependencies. You know already what is the purpose of them. One dependency extra we are adding, that is Open Feign. Then configure this annotation at the start class. then create one REST controller with the required method, then configure these properties. So this is going to be our fifth microservice, 05 greet service. This port number I will use 9091. This port number I am going to use as 9091. This is Eureka client URL, and these are the actuator endpoints we are going to configure. Then run this application, and you can check that in the Eureka dashboard, and you check the server dashboard, admin server dashboard. You can send the request to the REST API, and you can check the request details in the Zipkin dashboard. Okay, so let me create this greet REST API. Go to this IDE. Let me create the fifth project. File, new Spring Starter project. Give the name 05 greet API or greet service. 05 greet service, Maven project, jar file, Java version 17. Click on next, dependencies. Discovery client, dev tools, code centric admin client, okay, Spring web starter, actuator, Zipkin. Okay, you see the dependencies I'm adding. One more dependency that we need to add, which is open Feign dependency. Open Feign dependency we need to add, which is a Feign client. For the inter-service communication, I need this open Feign. REST client for dynamic implementation of interface decorated with the MVC annotation. Select the open Feign. This is the new dependency I'm adding. So in the first microservice, there are 6 dependencies available. In the second microservice, there are 7 dependencies available. So I want to register with the Eureka server. Eureka discovery client dependency I have taken. I want to register with the admin server. Admin client dependency I have taken. I want to register with the Zipkin server. Zipkin dependency I have taken. I want to develop a REST API. So web dependency I have taken. I want to restart the server. Dev tools dependency I have taken. I want to configure actuators, actuator dependency I have taken. I want to enable inter-service communication, Feign client dependency I have taken. Are you clear with the 7 dependencies I have added for the second microservice? Click on next, click on finish. Yes, project is getting created. This is our 5th microservice, guys. Third one is not available here because Zipkin server directly we downloaded as a jar file. Greet service is created. Go to pom.xml. Check the new dependency we have added, which is Feign client. What is the purpose of Feign client? One microservice wants to communicate with the another microservice. That is called inter-service communication. We will achieve the inter-service communication by using Feign client. So Spring Boot Starter actuator dependency available. Spring Boot Starter web dependency. Admin client dependency. Zipkin dependency is available. Eureka client available. Feign client is also available. This is the new dependency we added. Dev tools dependency available. Okay. Now first step, let me configure Eureka discovery client annotation in the start class. So let me go to boot application start class, second microservice start class, the annotation which is enable discovery client annotation. Done. After this, create a REST controller. I'm creating one REST controller with a name called greet REST controller. New class. I'm keeping this in a controller package. And I'm giving the class name as greet REST controller. To represent this class as a REST controller, I will write one annotation called @REST controller annotation. This annotation will make our class as a REST controller. It will make our class as a distributed component. Now inside the REST controller, let me write one method, public string get greet message. Okay, string message. I'm taking a message as good morning. I'm taking this message as a good morning, and I'm going to return this message. Let me map this method to HTTP GET request by using get mapping annotation /greet. So if you send a HTTP GET request to the greet URL pattern, it will respond with good morning as a response. Okay, REST controller is ready. Then configure the properties in the YML. What are the properties we need to configure? First of all, properties file is available. Change this properties file to YML file. Spring, convert the dot properties to dot YML. Properties file I am going to delete and I am keeping only YML file. Name of the application is available. Configure server port number, server dot port. This is a second microservice. I am giving the 9 series for this. Server port is 9091. Register with the admin server spring.boot.admin.client.url. Okay, I am registering this application with admin server. For this admin server URL http://localhost:1111. This is my admin server URL. Server port is also available. Next one, configure actuator endpoints. Eureka server I am not configuring because port number is same. Configure actuators. How to configure actuators? management.endpoints.web.exposure.include star. I'm going to enable and expose all the actuator endpoints for my application. Okay, that's it, right? So these are the properties. Name available, admin server URL, port number, actuators. Eureka server URL, optional. I'm not configuring. That's it. So once it is done, then run the application and check in the dashboard. For that, first let me update my Maven project because I changed the properties file to YML and I added new properties in the YML. Update the Maven project. Remember, whenever you change anything in the YML file, immediately it will not reflect, guys. So you need to update that. You need to update that. Yes, my properties are updated. Now let me run the fifth application. Before going to run, let me show you Eureka. In the Eureka currently only welcome application available. Let me show you Spring Boot admin server. Only welcome is available. Let me go to Zipkin server. Only welcome service traces are available. So greet service traces are not available. Greet service is not available in the Eureka dashboard. Greet service not available in the admin dashboard. Greet service not available in the Zipkin dashboard also. Okay, now let me start my second microservice. As per our diagram, this is our second REST API that we have created. First REST API, second REST API. Okay, so let me run this application as Spring Boot application. It will register with Eureka. It will register with admin server. It will register with the Zipkin server also. Go to this dashboard and check it. Go to this dashboard and check it. Refresh. It is still getting started. Greet service is getting started. Once the greet service is ready, you can check. Yes. So in the Eureka dashboard, Eureka running on the 8761 port number. In the Eureka, you can see greet service available as a client. It is running in one instance. That means in one server, the greet service application is running. The greet server application status is up, and this is the URL of the greet service. So welcome service is one microservice. Greet service is another microservice. Two microservices are available. So like this, how many microservices are available in our application? What is the names of those what are the names of those microservices? What is the status of each microservice? In how many servers the microservice is running? That is called instances. How many instances available for the microservice? And what is the URL of that microservice? We can access by using Eureka dashboard. Now go to admin server. There are two applications registered with the admin server. One is the welcome service, another one is the greet service. Now go to Zipkin server. Welcome service is available. Run the query. Greet service is also available. So greet service is started. So it took 32 milliseconds of time. So you can monitor your application. You can monitor your microservices by using admin server. You can see how many microservices available by using Eureka dashboard. So currently we have welcome service and we have greet service. And the next one, we are having Zipkin server. What is the purpose of the Zipkin server? By using Zipkin server, we can understand how much time it is taking to process each request. How much time it is taking to process each request, we can understand by using Zipkin. Now let me go for 8081/welcome. This is first microservice response. Let me go to second microservice. Localhost colon 9091. Localhost colon 9091/greet. Localhost colon 9091/greet. We are getting good morning. So first REST API, first microservice giving the response as welcome to Ashok IT. Second REST API giving the response as good morning. So two microservices are running as expected. Two microservices are running as expected. Now, can I say my two microservices are acting as a client for Eureka, acting as a client for admin server, acting as a client for Zipkin server? Can we say them? Can we say that our two microservices are acting as a clients for Eureka, acting as a client for admin server, client for Zipkin server? Admin server is used to monitor and manage. Zipkin server used for distributed tracing. Eureka server to get the information about the microservices. So API 1 and API 2, two microservices available. These two microservices are registered with the Eureka server, registered with the admin server, registered with the Zipkin server. Our two microservices, Greet API, Welcome API, are acting as clients for the Eureka server, for the admin server, for the Zipkin server. My API 1, that is Welcome API, running on 8081. My Greet API is running on the port number 9091. Different port number I have given. Two applications cannot run on the same port number. That's why for every microservice, there is a different port number. For the service registry, port number 8761. For admin server, port number 1111. For Zipkin server, port number 9411. For the Welcome REST API, port number 8081. For the Greet API, port number 9091. So total 5 microservices running in my system. Currently 5 microservices running in my system. Now, is there any relation between Welcome REST API and Greet REST API as of now? Is there any relation between Welcome REST API and Greet REST API as of now? There is a relation or there is no relation between these two REST APIs? There is no relation. But I want to establish the relation. So when I send the request to the Greet REST API, I want to communicate from the Greet REST API to Welcome REST API. So if I send a request to the Greet REST API, Greet REST API should communicate with the Welcome REST API. So one microservice wants to communicate with the another microservice which belongs to same application. That is called inter-service communication. Okay, in the real time, one application will communicate with the another application. One REST API can communicate with the another REST API, provider and consumer. Provider concept and consumer concept will be available. So this is provider application, that means which is giving the services to other applications. And this is consumer application, which is accessing the services from other application. Provider application, consumer application is available. Consumer application wants to communicate with the provider application. One application wants to get the services from other applications. So these are distributed applications. How many ways one application can communicate with the another application? You have 3 approaches, guys. One is by using REST template. By using REST template, one application can communicate with the another application. REST template is one option. And the second option is web client. And the third option is Feign client. One is by using REST template. Second one is by using web client. Third one is by using Feign client. So now I want to go with the Feign client. Sir, why only Feign client? So why not REST template? Why not web client? When you go for REST template, you need to write like this: rt.get for entity, something like this. You need to specify the URL. You need to hard code the URL. When you go for web client also, client.get, you need to specify the URL. with which API you want to communicate. That API URL you need to give to the REST template and you need to give the URL to the web client. But when you go for Feign client, what is the benefit? When you go for the Feign client, load balancing will be available. Without giving the URL, you can access the API by using service name of the API. So generally, when one application wants to communicate with the another application, so that means consumer is available, provider is available. If a consumer wants to communicate with the provider, three approaches available in the Spring Boot. What are those three approaches? One is REST template, second one is web client, third one is Feign client. REST template, web client. If you use REST template, get for entity method, URL you need to configure. If you go for web client .get method you need to call, you need to configure the URL. But for example, tomorrow, if my provider is running in multiple servers, if there is a load balancing for the provider, if a provider running in the multiple servers, then how do you send the request by using REST template? My provider application running in 3 servers for the load balancing. Then how the REST template will access the provider? Only one URL available or 3 URLs available for the provider? 3 URLs available for the provider. When you go for REST template, always you need to send the request to single URL. That means you are keeping burden on the single server. So in the real time, our application will not run on the single server. For the load balancing, our application will run on the multiple servers in the real time. So when you go for the REST template, what is the problem? You need to specify to which URL you should send the request. When you go for the REST template, get for entity, you need to specify to which URL you should send the request. But my provider is having one URL, my provider is having 2 URLs, my provider is having 2 URLs. Then how do you send the request? To which URL you will send the request? Confusion. If you configure particular URL, always the request will go to single URL. But I want to implement load balancing. I want to run my provider in multiple servers, multiple instances I want to use. Same application I want to run in the multiple servers for the load balancing. Then how do you establish communication from one microservice to another microservice? You should not communicate with the URL. If you want to access one REST API from the another REST API, you should not use the URL. You need to use the service name. So that's where in the Eureka server, service names are available. By using this service name, my greet API will communicate with the welcome API. Welcome API service name available. So my greet API wants to communicate with the welcome API, but not with the URL, with the name of the service. So that's where Feign client will come into picture. So when you go for the Feign client, by using Feign client, we can establish the communication from one microservice to another microservice by using the name of the microservice, not with the URL of the microservice. Generally, when you go for REST template or web client, you need to establish the communication by using URL. If you have only one server, if you have only one URL, no problem. But if I have multiple URLs for one application, if I run my application in the multiple servers for the load balancing, 3 or 4 URLs available. Then to which URL you will send the request? Will you send the request to the same URL every time? Not recommended. If you send the request to the same URL every time, burden will be increased on the server. We need to use that load balancing technique. My request should go to different URL every time. My first request should go to first URL. My second request should go to second URL. My third request should go to third URL. So then how you will establish the inter-service communication? That's where Feign client comes into picture. What is the benefit of Feign client? Feign client will establish the communication from one microservice to another microservice by using name of the microservice, not with the URL of the microservice. When you go for REST template or web client, that is communication with the URL. In the Feign client, communication with the name of the microservice, not with the URL of the microservice. Are you able to understand what is inter-service communication? Damn sure interview question. When you are attending the interview as a Java developer, microservice is mandatory. They will ask you how one microservice can communicate with another microservice. Can you tell me what is the meaning of inter-service communication? Can you tell me what is the meaning of inter-service communication? How do you establish inter-service communication? What is the difference between REST template and web client? REST template and web client, and when to go for Feign client? Feign client is used for inter-service communication. Why we are going for Feign client? Because my provider is not running in one server. My provider is running in the 3 servers, 3 URLs available. Then how do you access provider? With which URL you will access the provider? Confusion, conflict. So that's why Feign client will come into picture. If you use Feign client, what is the benefit? No need to specify the URL of the provider. Specify the name of the provider. If you specify the name of the provider, then Feign client will get the URL of the provider based on the name. If a provider having multiple URLs, then every time it will use one URL to first request go to first URL, second request go to second URL, third request will go to third URL. That is load balancing. So we can achieve load balancing by using Feign client. Inter-service communication. Are you able to follow me? Are you able to follow me? So if you are establishing inter-service communication, so your consumer application, provider application, both are registered with the service registry, then you can use a Feign client for the inter-service communication. For example, my consumer and provider are from different projects. My consumer and provider from the different projects, then you can go for REST template. External service nothing but provider is developed by someone. Provider is not from our company. Provider is not from our project. Then external service communication. For external service communication, REST template or web client. For inter-service, so consumer provider in the same project. One is Greet API, another one is Welcome API. Both are in the same project. Both are registered with the service registry. Both are available in the Eureka. When both wants to communicate, then why to go for URL? Because URL can change in the future and the number of URLs can be increased. Today I am running in my Welcome API in one server. Tomorrow I will run the Welcome API in the multiple servers. Tomorrow my Welcome API running in one server. After a few days I will run that in the 10 servers, 10 different URLs. Then how do you communicate? So that's where we will use a Feign client, which is used to achieve inter-service communication. Okay. Are you able to understand what is the purpose of a Feign client? Yes. Okay. Good. Now, can I establish inter-service communication by using service name now? Can I establish inter-service communication by using Feign client now? So let me go to Greet API and let me create a Feign client for the Welcome API. So Greet API is available. Let me name it as Greet and this is Welcome. Greet API is available. Welcome API is available. When I send the request to the Greet API should communicate with the Welcome API by using Feign client. Now tell me where we need to create the Feign client. Which service want to access which service, guys? By looking at the diagram, can you tell me which service want to access which service? Which service want to access which service now? Welcome want to access Greet or Greet want to access Welcome as per the diagram arrow mark? As per the diagram arrow mark, who want to access whom? Greet want to access Welcome. So Feign client should be available in the Greet API or Feign client should be available in the Welcome API? Feign client should be available in the Greet API or Feign client should be available in the Welcome API? In the Greet API. in the greet API. Feign client should be available in the greet API. That Feign client is going to communicate with the welcome API. So Feign client will communicate with the welcome API by using welcome API URL or by using welcome API name. Inter-service communication we will establish with the name of the API or URL of the API, which is recommended. Communicating with the name of the API or communicating with the URL of the API, which is recommended. Can you please respond? Which is recommended? Name is recommended. Why not URL? Name is recommended. Why not URL, guys? What is the problem if I use URL? URL can change in the future, and that server can run in the that API can run in the multiple servers. Then multiple URLs will come into picture. So that's why inter-service communication always we need to establish by using name of the service, not with the URL of the service, because today one URL, tomorrow URL can change, and tomorrow multiple URLs can be available. Okay, so after this Feign client is completed, now I will show you load balancing by running one server, by running one application in the multiple servers. Okay, now let me create the Feign client in the greet API. New interface, guys. Feign client is an interface. You no need to provide the implementation also. Client package, welcome Feign client. Welcome Feign client interface I am creating. How to represent this as a Feign client? By using a annotation called @Feign client annotation. By using one annotation called @Feign client annotation. So to represent this is a Feign client, na, I'm using one annotation which is @Feign client. For which service it is going to act as a Feign client? For which microservice we are going to configure this as a Feign client, guys? We are going to configure this as a Feign client for the welcome service. What is the name of the welcome service? You can access from the Eureka dashboard. This is the name of the welcome service. Copy this name and give that name here. That's it. So this is a welcome Feign client which is going to access welcome service. I'm giving the name of the service, not URL. Feign client will get the URL from the service registry based on the service name. URL can change. Multiple URLs can be available. Then Feign client will get the URLs of the service based on the name of the service. Now, by using this Feign client, what request you want to send to the welcome service? By using this Feign client, I want to send one GET request, GET welcome message. How to send a GET request? Let us write @GET mapping. What is the welcome service method URL pattern? /welcome. Now observe, there is a lot of work will happen in the background in this scenario. Whenever you call this welcome message method available in the Feign client will go to service registry, and Feign client will get the URL of the service. For that URL, it will send a GET request with the welcome URL pattern. That is the meaning of that. So lot of internals are going to happen here. Whenever you call get welcome message method, Feign client is going to contact with the service registry, service discovery. Why people will call it as a discovery? It is used to discover the service URLs based on the service name. So when I call this method using Feign client is an interface. I don't need to provide the implementation. Spring Cloud will take care of the implementation. So when you create the JPA repository, we are not creating the implementation. Data JPA will provide the implementation. Similarly, when we create the Feign client interface, implementation will be provided in the runtime by the Spring Cloud. So when you call this method of Feign client, then what will happen in the background? Feign client will go to the service registry, will get the service URL based on the service name, and will send the GET request to that service by using /welcome URL pattern. In the welcome REST controller, we have that GET request method. So if you see welcome service, welcome REST controller, there is a GET request method available with the /welcome. So I want to send a GET request to the /welcome. That's why I'm configuring that in the Feign client method. get welcome message method available. So I want to send a get request to the welcome service by using this method. So when you call this method, Feign client will get the URL of the service. That service can have one URL, it can have multiple URLs. If it is having one URL, send the request to that URL directly. If it is having multiple URLs, then Feign client will implement load balancing. First request will go to first server, second request will go to second server. I will show you practically. Now, send a get request to the welcome service / welcome URL pattern. Where is the URL of the welcome service? Eureka server knows that. My Feign client will talk to Eureka server, will get the service URL, and to that service URL, it will send a get request with the / welcome. That is Feign client inter-service communication. Now let me call this Feign client method. Go to greet REST controller. Let me inject my Feign client private welcome Feign client, which is welcome client. How to inject it? @auto wiring. @auto wiring. Now let me call the welcome client method. Welcome client dot get welcome message. Welcome client dot get welcome message. I'm calling welcome client dot get welcome message. So it is going to give you the response of the welcome API, and this is greet message. Okay, now I want to combine the response. Good morning, which is greet message plus welcome message. Greet message plus welcome message. Combined response I am going to send. Combined response I am going to send. Are you clear with my point? Greet REST controller is available. In the greet REST controller, I injected Feign client. What is this Feign client? It is used to access the welcome API. Send the get request to the / welcome. Welcome REST controller will give some response. Store that response into your variable. This is a greet message. This is a welcome REST API response. Combine the greet message and welcome message. Send the final response to the client. So if you send the request to the greet API will use a Feign client, will send the request to the welcome API, get the response from the welcome API, combine that response and send the final response to the client. So this is inter-service communication. We are sending the request to the welcome API. We are sending the request to the greet API. Greet API sending the request to the welcome API. Welcome API will give the response to greet API. Greet API will give the final response to the client. One service communicating with the another service. No REST template, no web client. I'm using Feign client. By Feign client, we can communicate from one microservice to another microservice by using the name of the microservice, not with the URL. Why not with URL? URL can change in the future, and one microservice can have multiple URLs if you go for the load balancing. So never communicate by using URL. Communicate by using service name. So when you use a service name, Feign client will go to that service registry, Eureka server. Hey Eureka, I want to communicate with the welcome service. Can you give me the URL of the welcome service? Welcome service can have one URL. Welcome service can have multiple URLs. Service registry will give the URLs to the Feign client. So if you have multiple URLs, from those multiple URLs, Feign client will choose one URL, will communicate with the welcome service. Are you guys able to understand my point? Are you guys able to understand my point? Difficult or easy? Lot of depth is there. If we really work on the microservices, then only we can teach these concepts, guys. It's very, 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 very important. It's very, very, very important. Okay, can we test it? The Feign client is working as expected or not? So now you observe, greet REST controller having welcome Feign client injected. Welcome Feign client is what? It is an interface. It's not a class. It's an interface. What about implementation? Spring Cloud will provide in the runtime by using proxy. Okay, I'm configuring the name of the welcome service. So whatever the name you are giving for the service, guys, that name should not be changed. Whatever the name you are giving, that is fixed name, you should not change in the future, because if you change the name of the microservice, then Feign client will not work, because Feign client is completely working based on the name of the service only. So you should not change the names. Are you guys clear with my point? Are you guys clear with my point? Can we test it? Feign client is working or not? Yes. Feign client is, let me stop all the services and let me restart everything. System will be hanged because 4-5 services are running at a time in our laptop. If your laptop is having 4 GB, using that laptop you can do iron for your shirts also. That much heat will generate. Clean everything. Yeah. First let me run the service registry. Greet API is available. Okay, let me run the service registry. Run as a Spring Boot application. I'm restarting my service registry. Fresh Eureka server will come. No clients for Eureka now. We need to restart all the services again. Okay, I'm running my Eureka. It's waiting. Yeah, Eureka server started. Eureka dashboard we can see. Currently, any instances available in the Eureka? No instances available in the Eureka. Brand new Eureka server started. Now let me go with the admin server. Run as boot application. Run as boot application. It will run on the port number 1111. Currently, there is no relation between Eureka and admin server, guys. Eureka is separate. Admin server is separate. Admin server will run on the port number 1111. So currently no applications are available in the admin server also, because I have stopped everything. I'm restarting them. Yes, Eureka server started. 8761 is the port number. No instances available. Admin server started. 1111 port number. No applications registered. Zipkin server is available. Okay. So Zipkin server is started. These are the earlier things. I have not restarted Zipkin. If you want, I can restart the Zipkin also. Control C. Let me stop the Zipkin. Yes, Zipkin stopped and restarted. It will run on the port number 9411. Zipkin server we are taking as a jar file and we are running that jar file. It will run on the port number 9411. It will run on the port number 9411. Guys, one more thing. Today we cannot complete everything. We have the class tomorrow also. Tomorrow 7 to 9:30 a.m. 7 a.m. to 9:30 a.m. continuation class is available. Tomorrow we will understand load balancing, API gateway, config server. Another 2.5 hours class we are extending for tomorrow. Tomorrow same Zoom link, 7 a.m. to 9:30 a.m. class will be available. You can join with the same Zoom link tomorrow morning also. Tomorrow morning we are going to understand API gateway, load balancing, config server concepts are available. Today I can't complete everything. So tomorrow we are going to continue the same session. Okay. Yeah. Tomorrow JRTP people, Spring Boot people will attend the same class, continuation class for tomorrow. Yeah. Go for the Zipkin. Check the Zipkin dashboard. Is Zipkin started? Sorry, I have not executed this file. Yeah. My Zipkin server is getting started. Eureka started. No instances available in the Eureka. And admin server started. No applications available in the admin server. My Zipkin server started. I'm waiting. Yeah. Zipkin is started. Currently, no traces available in the Zipkin. Now let me run my welcome API. Welcome microservice I am running. Run as boot application. Welcome microservice I am running. Okay. This video and class notes. Yes, sir. I am already telling you that you will get the video and class notes in our WhatsApp channel. Channel link I have given in the chat box. For the Zoom people, WhatsApp channel link I have given in the chat box. You can join in that. You will get the notes and video and the project also which I have developed. I will share it. Whatever the code I am writing now, I will store all these things into GitHub repository. The people who are watching in the YouTube also, you can join in the WhatsApp channel to access these notes and to access this video. WhatsApp channel link I am giving in the YouTube comment also, and then the Zoom comment also I have given. Okay, good guys. Next up, welcome API is started. Let us go to Eureka, refresh. In the Eureka, my welcome API is registered. Welcome REST API is available in the Eureka server running on the port number 8081. Now go to Greet application, run this as a Spring Boot application. Greet REST API I am running. Greet REST API also I am running. Inside the Greet REST API, Feign client is available. Feign client is available, which is used to communicate with the welcome REST API. One microservice is going to communicate with the another microservice now. Yes, I'm waiting for Greet REST API to register with the service registry, admin server, and Zipkin server. Then we can test our microservices are working as expected or not. Currently, welcome service registered with Eureka. It is up and running. It is running on the port number 8081. Greet service is terminated. Application failed to start. Welcome Feign client that could not be found. Okay, so welcome API, when I use Feign client, it is not able to read that. So let me write one annotation called enable Feign client's annotation. 2 minutes. Enable Feign client's annotation I am configuring. Okay, let me start my Greet API again. Run as boot application. I'm running my Greet API, guys. I forgot to add this annotation called enable Feign clients. Now I added enable Feign clients. Service ID not legal name. 0 first welcome service. It is not considering that service name properly. Okay, let me change the name of the service. Instead of this one, let me give welcome -service. And for the greet also, welcome Feign client, welcome -service. I'm going to configure. Underscore, it is not accepting for the service name. So I'm giving hyphen for this. And in the greet also, the service name, it is greet service. I'm going to configure, which is greet -service. Okay, let us check it. In the Eureka, welcome service is available, and let me start the greet service. Run as boot application. Greet service I am running. If the greet service is started, we are good. We can test the inter-service communication. I'm waiting for the greet service to start. Inside the greet service, we injected the Feign client. This is my greet service REST controller. In the greet service REST controller, Feign client is injected. So Feign client is having the name of the service, and it will send the GET request to that service. It will get the service URL from the service registry. Refresh. Yeah, we are good. Welcome service registered with Eureka, having the port number 8081. Greet service also registered with the Eureka, having the port number 9091. Now go to welcome service, send a request to the welcome service 8081. We are able to get the response, welcome to Ashok IT. Send a request to the greet service. Earlier, when I send the request to the greet service, I got the response as good morning. Now send the request to the greet service. Am I able to get greet API response plus welcome API response? Can we say inter-service communication is working now? If you send the request to the greet API, it is giving greet API response plus welcome API response also. Can we say inter-service communication is working? Can we say inter-service communication is working? Now, if you see in my greet REST controller, what is available? Welcome Feign client is available. Using this Feign client, we are calling the get welcome message. So what is there? Am I giving the URL of the welcome service? I'm giving the name of the welcome service. Am I giving the URL of the welcome service? I'm giving the name of the welcome service, name. Then how it will get the URL? From the Eureka server. In the Eureka server, service name available, service URL is available. So Feign client will get the service URL based on the service name and will send a request to that service and it will give the response from that. Whatever the response we are getting from the welcome API, we are combining that response with the greet API response and we are sending final response to the client. If you send request to welcome service, you will get only welcome message. If you send the request to greet API, greet message plus welcome message. That means one microservice is communicating with the another microservice, which is called inter-service communication. To establish inter-service communication, we used Feign client. Are you clear with my point? Server application, and we completed Zipkin server also. We completed welcome API development. We completed greet API development, and we also completed inter-service communication among those APIs by using Feign client concept. Okay, so today we are going to understand what is load balancing and why we need to work with the load balancing and how to set up the load balancing in our microservices. So can anyone tell me what is the load balancing? Any idea on the load balancing concept, guys?
Yeah. One microservice running in different servers.
So what is the main purpose of load balancing and why we need to go for the load balancing?
Distributing the load to the different servers.
Move the request to the target server.
Okay, load balancing is basically used to distribute the load to multiple servers. For example, if you are having application that is running in one server, assume that this is our microservice. This microservice is running in one server. Okay, assume that this is a server. Inside this server, our application is running. So when the application is running inside the server, so many people are going to send a request to that application and they are going to access our application. Assume that this is our application which is running inside one server. Now, when it is running in one server, so many requests are coming to our application. So all the requests are going to single server. Then the burden will be increased on the server. The burden will be increased on the server. So what are the problems available? Single server is running our application. When the single server is running our application, burden will be increased on the load. Burden will be increased. Burden on server. And another problem, server can crash and response delay for the customers. These all are the challenges available when we are running our microservice in the single server. So you have one application, that application you are running in the server, that server is responsible to handle the load. So as there is only one server, all the customer requests will come to single server. As the customer requests are coming to single server, the burden will be increased on the server. When the burden is increased on the server can crash and customers will get the responses with late delay. Response delay will happen when you run our application in one server. So in the real time, we are not going to follow this approach because it is not recommended. Because multiple customers will be available in order to access our application. That's why in the real time, what we are going to do, in the real time, our application will be deployed into multiple servers, guys. Instead of running our application in one server, our application will be deployed into multiple servers in the real time. That is called load balancing. This is one application. This application will be deployed into one server. This application will be deployed into one server. Same application will be deployed into one more server. Same application will be deployed into one more server. So all these servers are running the same application. So what is the benefit if we are running all these application with multiple servers? The advantage is one load balancer will be available for our application. One load balancer will be available for our application, and all the servers will be registered with the load balancer. All the servers will be registered with the load balancer. Customers are going to send a request to the load balancer. Then load balancer is going to distribute the request to all the servers which are running our application in the round robin fashion. First request will go to first server, second request will go to second server, third request will go to third server, again fourth request will go to first server, fifth request will go to second server, sixth request will go to third server. Like this, all the requests will be distributed. Like this, all the requests will be distributed when we are going for the load balancing concept. So what is the benefit of load balancer? It is used to distribute the request to multiple servers. It is used to distribute the request to multiple servers. Instead of running our application in one server, we are going to run our application in multiple servers. Instead of running our application in one server, we are going to run our application in multiple servers, guys. Are you able to follow me? Here only one server is running our application. Here multiple servers are running our application. So if you run application in one server, burden will be increased on the server, load will be increased on the server, then server can crash. So to overcome that problem, instead of running our application in one server, we are going to run our application in multiple servers. We are going to run our application in multiple servers. So when you run the application in the multiple servers, the load will be distributed. The load will be distributed and responses will be quick to the customers. Customers will get the responses very quickly. Application performance also will be faster. Okay, so what is load balancing? If we run our application in one server, in one server, then burden will be increased on that server. If we run our application in one server, then burden will be increased on the server. Okay, so what are the challenges available? Single server to handle all the requests. Single server should handle all the load. Single server should handle all the load. Burden on the server. Response delay to the customers. Okay, and the servers can crash. Server can crash. Single point of failure. If a server is crashed, then the entire application is going to be down. So this is single point of failure. So only one server is available in order to run that application. If the server is crashed due to some problem, due to burden, if the server is crashed, then the whole application will be down. So to overcome this problem, we are going to run our application with multiple servers. To overcome the above problems, we will run our application in multiple servers. We will run our application in multiple servers so that we can distribute the request to multiple servers. Instead of running our application in the single server, we are going to run our application in the multiple servers. Okay, so load balancer is used to distribute the request to multiple servers. Load balancer is used to distribute requests. Whatever the requests are coming, distribute requests to multiple servers. Okay, so what are the advantages when you run the application with multiple servers? Less burden on servers, okay, quick responses to the clients, no single point of failure, that means if one server is failed, no problem, the remaining servers are going to handle that load. If one server is failed, no problem, our application is running in the remaining two servers. So if first server is failed, second server will provide the response to the customer, third server can provide the response to the customer. So instead of running our application in one server, we are going to run our application in multiple servers by using round robin technique. So that's where we are going to implement load balancing concept. So if we run our application in one server, then burden will be increased on that server. So single server should handle all the load, burden will be increased on the server responses will be delayed to the customer. There is a chance of server crash also, and if the server is damaged, the whole application will be down. That concept is single point of failure. So to overcome all the above problems, we will run our application in multiple servers so that we can distribute the request to multiple servers. So here load balancer is used to distribute the request to multiple server. We have below advantages with the load balancer. What are those advantages? Less burden will be there on the servers, and responses will be quick to the customers, and no single point of failure. If one server is failed, the remaining servers are going to handle that load. Okay, good. Now here I'm going to welcome API. In the welcome API, I'm going to make some code changes and I will show you load balancing practically. So in the welcome API, I'm making some code changes and I will show you this load balancing is working as expected or not. So I'm injecting one object in the welcome REST controller, which is private environment object I am injecting. Okay, Spring Core environment bean I'm injecting here. Let me import Spring Framework Core environment bean I have injected. For injecting that environment object, I'm using one annotation called auto void annotation. We already know what is the purpose of auto wiring. Auto wiring is used to perform dependency injection. Auto void annotation we are using to perform dependency injection. Okay, next let me get the port number in which server our welcome API is running. Environment dot get property. So I'm going to get the property that is server dot port. On which port number our server is running, I want to get that port number and I will send that port number in the response. Okay, port. Okay, welcome to Ashok IT. So here I'm going to display the server port number, on which port number this server is running. Okay, so we are getting the response from the which server. Yesterday when we developed this application, we have deployed welcome REST API only in one server. So if you see our diagram, welcome REST API I have deployed in only one server. So today I'm going to deploy welcome REST API in multiple servers for the load balancing. So in our application, what is happening, guys? So here there is a greet API is available. This greet API is communicating with the welcome API. Greet API is communicating with the welcome API by using Feign client. So today what I am going to do is this welcome API I'm going to run in multiple servers. Those are called as instances. Instead of running the welcome API in one server, I'm going to run the welcome API in multiple servers in order to achieve load balancing. So 3 servers I'm going to use. I will run the welcome API in 3 servers to achieve load balancing. 3 servers, nothing but for the welcome API, 3 instances will be available. 3 instances, nothing but same application I'm going to run in 3 servers with 3 different port numbers. Okay, first server will run on the port number 8081. Second server will run on the port number 8082. Third server will run on the port number 8083. So like this, welcome API, I'm going to run in 3 servers. 3 instances will be available for the welcome API. So from when it is running in the 3 servers, when the greet API send a request by using Feign client, from which server it is providing the response. For that, I am injecting environment object. Environment.get property, server port number I am getting, that server port number I'm sending in the response. So by looking at the port number, you can understand out of these 3 servers, which server is providing the response to us. Are you guys able to understand why I am using environment object in the welcome REST controller? Yes, in the last Sunday, welcome REST API, I have deployed in only one server. There was only one instance for the welcome REST API. But today, I'm going to run the welcome REST API in 3 servers. Nothing but 3 instances will be available for the welcome REST API. Why I am deploying welcome REST API in 3 instances? For load balancing. Instead of sending the request to the single server, you can send the request to multiple servers. Same application running in the multiple servers, which is called load balancing. One server is called one instance. Welcome REST API, I will run in 3 instances, 3 servers. Okay, first server will run on port number 8081. Second server will run on the port number 8082. Third server will run on the port number 8083. So in which server it is executing? When the greet API communicating with welcome API by using Feign client. Feign client is communicating with the first server. Feign client communicating with the second server or third server. So from which server we are getting the response? Welcome API is responding from which server? To understand that, I have injected environment object in the welcome REST API, and from that I am getting the port number. That port number I'm sending in the response. If you get the port number as 8081, that means first server giving the response. If you get from 8082, second server responding. 8083 means third server responding. Now, so I want to use different port numbers for different servers. That's why I'm removing the fixed port number from the welcome REST API. So I have fixed the port number as 8081. So if you fix the port number as 8081, always it will try to start on the 8081. Only one server we can start. So I want to run this application in 3 servers for load balancing. So remove the port number from the YML file and pass that port number in the runtime. I'm removing port number from the application.yml. That's it. Okay, guys. So in the REST controller, I have done one change. I injected environment object. Using environment object, I'm getting the port number. And the second change I have done, from the YML file, remove the port number so that we can pass the port number in the runtime. Okay, very good. So these are the 2 changes I have done to implement the load balancing. Go to service registry, run this application, right click, run as boot application. My Eureka server is getting started, which will run on the port number 8761. Eureka server will run on the port number 8761. Clear this. Go and access Eureka dashboard. Localhost colon 8761. Localhost colon 8761. Yes, I'm able to access my Eureka dashboard. So in the Eureka dashboard, currently no instances are available. Nothing but no applications are registered with the Eureka as of now. And let's go and start the admin server also. Run as boot application. Admin server is used to monitor and manage our applications. Admin server will run on the port number 1111 as per our configuration. Admin server will run on the port number 1111 as per our configuration. Okay. Go to the browser and let us try to access that also. Localhost colon 1111. Admin server dashboard we are accessing. Currently, no applications registered with the admin server. Now Zipkin server is available as a jar file. So we need to run the Zipkin server from the jar files. Okay, Zipkin jar we are downloading from the internet, and that jar we will run by using command prompt. Okay, let me run that Zipkin jar file in the command prompt. Okay, this is my command prompt. Here my Zipkin jar is available. Java space -jar space Zipkin jar file. I'm trying to start. So this jar we downloaded from the internet. So when you run this Zipkin jar file, Zipkin server will start. Zipkin server will run on the port number 9411. So we can access Zipkin dashboard also in the browser. Localhost colon 9411. Yes, Zipkin jar file started, Zipkin server started, but currently we don't have any output in the Zipkin server. Traces are not available in the Zipkin server. Okay, next let us start our microservices, guys. So yesterday we directly started welcome service. We configured port number as 8081. Today I removed that port number here. Now observe carefully. Currently in the Eureka server, no application is available. No instance is available in our Eureka server. So how I am going to start this Eureka server? It is already started. Now welcome service. So welcome service name is available. Admin server URL is available. Actuators are enabled. Port number is not available. Why I am not configuring the port number? If I configure the port number, always it will try to start with the same port number. I don't want to run only in one server. I want to run the welcome API in multiple servers. So every server should use different port number. So that's why right click on the welcome service, run as run configurations. I want to run welcome API with different port numbers. 3 times I will run with 3 different port numbers. That is called 3 instances. So how to start this welcome API? Right click on the welcome service, run as run configurations. So when you go for run configurations, there will be an option. You can select the application that you have. Spring Boot application, welcome service application is available. So whenever you go to application, right click, run as run configurations. This is important step for load balancing, guys. Run as run configurations. So in this run configurations, you select for which application you want to supply the port number. Go to Spring Boot applications, welcome service application is available. Go to arguments, VM arguments option, -d server dot port is equal to 8081. So I am passing port number to the server dynamically. Okay. So first time I am running with 8081. Second time I will run with 8082. Third time I will run with 8083. So -d server.port is equal to 8081. Here -d nothing but it is a system argument that we are passing to the JVM. Right. So I am telling to this welcome API, you start the server with 8081 port number. Apply and run. So with this, welcome service is running in one embedded server with the port number 8081. Now you go to Eureka dashboard and you can check that. What are the instances currently registered with the Eureka server? And so here if you observe the Eureka dashboard, welcome service is running. It is running up and running up is the status of welcome API. Number one is displaying, that means instances. In how many servers your welcome API is running? Welcome API is running in one server, and this is the URL of that server. This is the URL of the API. The port number is 8081. Now, I want to run this welcome API in one more server with the port number 8082. How to do that? Right click on this one, run as, run configurations. Right click on this one, run as, run configurations. Go to welcome service, arguments, this time 8082, apply and run. So I am running welcome API, one more server. That means 2 times I am running the same application. So two servers are running. Same application we are running in 2 servers for load balancing. So 2 instances available for the welcome API. We are having 2 instances for the welcome API. Are you clear with my point? 2 instances available for the welcome API. Okay, 2 instances available for the welcome API, guys. Now let me go to the Eureka dashboard and let me check it. Now earlier there was only 1 instance available. Now 2 instances available for the welcome API. So 2 URLs also available. Welcome service 8081 is available. Welcome service 8082 available. Similarly, we can run one more instance also. How? Right click, run as, run configuration, select welcome service, select arguments here, server port number 8083. Third server I am trying to start. Click on apply, click on run. It is getting started. Now go to Eureka dashboard and see how many instances available for the welcome service. Currently 2 instances available. It should be updated to 3. I started third instance also with a 8083 port number. I'm waiting for that. Third instance I have started for the welcome service. Now, can you see how many instances available for the welcome service, guys? Can you see how many instances available for the welcome service now? Can you see how many instances available for the welcome service now?
3 instances.
So there are 3 instances available for welcome service. There are 3 instances available for the welcome service. So 3 instances are running with the same port number. 3 instances are running with the different port number.
Different port number.
How I started same application with the different port numbers. So I removed the port number from the YML file. If you configure port number in the YML file, you can run it only one time. If you try to start second time, it will say port already in use. So that is the reason I removed the port number from the YML file. And how I supplied that port number, right click on the project, run as, run configurations, and here select your Spring Boot application here in the left side menu, select your boot application and give the arguments. -d server.port is equal to what is the port number. First time I used 8081, second time I used 8082, third time I used 8083. So with this, I can say that my welcome API is running in 3 servers. That means 3 instances available for the welcome service. Okay. In the admin dashboard also you can see welcome service having 3 instances. What is the meaning of 3 instances? 8081, 8082, 8083. Same application we are running in 3 servers. So why we need to run same application in 3 servers, guys? What is the need of that? Why we are running same application in 3 servers? What is the need of that?
Distributing the load.
Yes. So instead of sending the request to the single server, we are sending the request to 3 different servers here. Okay. So instead of sending the request to the single server, we are sending the request to 3 different servers here. Now, let me start my greet API. So greet API, I'm going to run only in one server, that is 9091 port number. In the greet API, there is a Feign client is available. What is the role of the Feign client here, guys? What is the role of the Feign client?
Intercommunication.
Service communication.
Should communicate from the greet API to welcome API. Feign client is available in the greet API. So when I send the request to the greet API, it should communicate with the welcome API by using Feign client. So Feign client is communicating with the URL of the API with the name of the API.
The URL. Name of the API.
Name of the
Feign client is
Name of the
communicating
API, sir.
Name of the API. With the URL of the API or with the name of the API?
Name of the
API.
Name of the API.
Name of the API.
Why not URL? Why we are using name of the service? Why we are not using URL of the service?
Maybe change in future.
URL may be changed in the future, sir,
Yes.
for
URLs
individual
can change in
application.
the future, and there are 3 URLs available for the welcome API. Okay. So if you want to communicate with the URL, out of 3 URLs, which URL you will use? And today 3 URLs available. Tomorrow it can become 5 also. It can become 10 also. It can become 2 also. So can we depend on the URLs for the communication now? No, because
Yes, sir.
URLs can change in the future. URLs can be increased. URLs can be decreased. That means for the welcome API, number of instances can be increased. Number of instances can be decreased also. That is the reason we should not use the URL for the communication. If you go for REST template and web client, you need to use the URL for the communication. Whereas if you go for the Feign client, you can use. Whereas if you go for the Feign client, you can use name of the service for the communication. Now you see here, greet REST controller is available. Greet REST controller is available. So when we are sending the request to the greet REST controller, it is calling welcome client.welcome message. What is the meaning of welcome client.welcome message? You go and talk to welcome service. You send a get request /welcome get request to welcome service. Feign client is having the name of the service. Feign client don't know URL of the service. Who will maintain service name and service URLs in the microservices, guys? Who
Service registry.
Service name and service URLs in the microservices? Come on.
Service
Eureka server.
Service URL. Come on. Who is going to maintain that? Service URL and service name in this scenario?
Service discovery.
Yes. Service discovery is going to maintain that service name and service URL. So whenever we are saying to the Feign client to communicate with the API, then here that Feign client is going to communicate with the service registry in order to identify the URLs of the API. It is going to communicate with the service registry in order to identify the URLs of the API. So there is only one URL available, or there are multiple URLs available for the welcome API. One URL is available, or multiple URLs available for the welcome API.
Multiple URLs.
Multiple URLs available for the welcome API. That's where load balancing comes into picture. So here, whenever Feign client is going to communicate with the service discovery will tell that, boss. So here I am sending a request to the greet API. I'm sending a request to the greet API. Greet API is communicating with the Feign client. Feign client is having the name of the service to get the URLs. Then Feign client will go and talk to service registry of our application. So Feign client will tell to service registry, hey, service discovery, I want to communicate with the welcome service. Could you please give me the URLs of the welcome service? So how many URLs available for the welcome service? One URL is available. Multiple URLs available for the welcome service, guys?
multiple URLs.
One URL is available, or multiple URLs available for the welcome service?
Multiple URL.
URLs available for the welcome service. Multiple URLs available for the welcome service. Then it is a confusion for the Feign client. So there are multiple URLs available. We should communicate with the which URL now. There are multiple URLs available. We should communicate with the which URL now. That's guys, are you understanding my point?
Yes, sir.
Yes, sir.
Are you understanding my point?
Yes, sir.
So what is the confusion for the Feign client here?
There are multiple servers available.
URLs. On which server it is going to run?
Yes, so it should communicate with the which server, because so greet API is going to communicate with the welcome API. Greet API is not communicating with the welcome API directly. Greet API is using Feign client. Feign client should communicate with the welcome API. Feign client don't know URL of the welcome API. Feign client don't know the URL of the welcome API. Feign client knows only name of the service. Then here Feign client should communicate with the Eureka server in order to identify what is the URL of the welcome API. So for the welcome API, it's not one URL. For the welcome API, there are 3 URLs available. So out of these 3 URLs, which URL it should use for communication? Out of these 3 URLs, which URL it should use for the communication? That is a confusion for the Feign client. So that's why what this Feign client is going to do, first Feign client is going to communicate with the service registry. Feign client is going to communicate with the service registry. So in our application, we are using Eureka as a service registry. So it will give the URLs of the welcome service. For the welcome service, there are 3 URLs available. Now, with which URL it should communicate? So it is a confusion for the Feign client. That's why inside the Feign client, there is a concept called ribbon concept is available. There is a concept called ribbon concept is available. Feign client is going to communicate with the ribbon for the load balancing. So what is the role of the ribbon? We no need to configure the ribbon manually. The ribbon is already part of the Feign client. That ribbon will take a decision for which server we need to send the request. For which server we need to send the request. That decision will be taken care by ribbon. So Feign client, we are going to send a request to the greet API. Greet API will use Feign client. Feign client is having the name of the service. So with this service name, Feign client will communicate with the service registry. Hey service registry, I want to access welcome API. Can you give me URLs of the welcome API? If there is only one URL, then no problem. Directly it can communicate with that service by using service URL. But in our scenario, welcome API is not having single URL. Welcome API is having multiple URLs. Welcome API is having multiple URLs. Okay, so when there are multiple URLs available, how it is going to communicate with those URLs? It is a confusion for the Feign client. So then what Feign client is going to do? That Feign client is going to communicate with the ribbon. So what is the role of the ribbon? Ribbon is going to provide the load balancing. Ribbon will tell to the Feign client, hey, send the first request to first server, send the second request to second server, send the third request to third server. Like this, Feign client is going to talk to the ribbon. Ribbon is going to implement the load balancing here. Now, how do you understand? The request is going to first server or second server or third server. That's why what I have done in the welcome REST controller, I am sending port number also in the response. So first server running on 8081, second server running on 8082, third server running on 8083. So from which server we are getting the response, that we can see the port number also in the response. Okay. Now, so let me start the greet API now. Greet API having a Feign client, run as boot application. Greet API will run on the port number 9091. Welcome API running in 3 instances, 3 servers available for the welcome API, 3 instances available for the welcome API, 8081, 8082, 8083. Now I am starting greet API. Now I am starting the greet API, which will run on the port number 9091. Now can you see in the Eureka dashboard what all the APIs available and what is the name of the API? How many instances available for the API and what is the URL of the API? Are you guys able to understand?
Yes,
Are
sir.
you guys able to understand what is the name of the API? How many
Yes, sir.
instances available for the API? How many instances available for the API? What
Four.
are the
Great
URLs?
service.
What is the status? What is the name? What is the URL? So everything that we can see in the Eureka dashboard. Everything we can see in the Eureka dashboard. Now, can you tell me what is the purpose of Eureka? Now, guys, can you tell me what is the purpose of Eureka?
Discovery of the services or register of the service.
It is going to register all our microservices and it will provide the service details based on the service name. Okay, now I want to send a request to Greet API. So what will happen if I send the request to Greet API now, guys? What will happen if I send the request to Greet API now? Greet API will give only greet message, or Greet API will communicate with the welcome API and will provide the welcome response also.
It combines the greet and welcome
API.
Greet API will provide only greet response and will provide the welcome API combined response for us.
Combined
response.
Combined response.
Now, I'm going to send the request to the Greet API. Look at this one, localhost colon 9091 /well greet 9091 /greet. So I'm sending the request to the Greet API. What happened now, guys? Which server responded for the welcome API request? 8082 server responded. Now refresh this. Now which server is responding?
8081.
Now check it, which server is responding?
8083.
So can we say the load balancing is working now?
Yes, sir.
Yes, sir.
So now every request is going to the same server, or the requests are distributed to multiple servers now?
Distributed to multiple servers.
Multiple servers. Who will be distributing the request to multiple servers here? Ribbon. Who is using that ribbon?
Feign client.
Now you understand how one service can communicate with the another service. So we have three options, guys. If one application wants to, if one microservice wants to communicate with the another microservice, there are three options available. What are those three options we are having, guys? One is template option is available, and the second
Web client.
web client option is available, and the third one is Feign
Feign
client
client.
option is also available. So when you use REST template now, you need to configure the URL of the API for communication. If you go for web client also, you need to specify the URL of the API for communication. When you go for Feign client, what is the advantage, guys? Load balance also will work. You no need to specify the URL of the API. You no need to specify the URL of the API. You can communicate by using service name only. Now you see greet REST controller. We are sending the request to greet REST controller. We are sending the request to greet REST controller. Greet REST controller is communicating with the Feign client. We are sending the request to greet REST controller. Greet REST controller is talking to Feign client. Feign client is talking to service registry in order to get the service URL based on the name of the service. Based on the name of the service. Are you guys clear with my point? So welcome service name is.
Sir, I have a doubt.
Feign client is going to communicate with the service URL in order to communicate. So for that service, it's not one URL. For that service, there are three URLs available. So Feign client will get the three URLs. Out of these three URLs, with which URL it should communicate, that is a confusion for the Feign client. That's why Feign client is going to communicate with the ribbon. Ribbon is going to provide the load balancing mechanism for the Feign client. Ribbon will tell to Feign client, boss, there are three URLs available. You do one thing. This request you send to first server. The next request you send to second server. The next request you send to third server. Like this, ribbon is going to distribute the load to multiple instances. of the
Sir.
same application.
Sir, ribbon automatically it detects. We
Yes,
need to
sir.
enable.
Yes, whenever the Feign client gets more than one URL from the service registry, immediately Feign client will talk to ribbon internally. Ribbon will tell the mechanism to distribute the load.
Sir, I'm having also one doubt.
Yes.
Sir, how can ribbon decide which URL we have to use?
Sorry, can you come again?
Yeah, sir. On basis of which criteria ribbon decide which?
It is a round robin mechanism. First request go to first server, second request will go to second server, third request will go to third server. That is a round robin mechanism that will be taken care by ribbon internally. That ribbon is part of the Feign client.
Hey, hi, sir. I have one question.
Sir, questions I will take at the end of the session, guys. Okay.
Okay, sure. So related to this thing,
Yeah.
only, sir.
Any question that I'm going to answer at the end of the class.
Okay, sure.
So we are trying to understand what is Feign client and what is inter-service communication and how we are able to implement this load balancing. So I have started my welcome API in multiple instances. So how I have done this load balancing for welcome API. Load balancing for welcome API. What are the changes I have done in order to implement the load balancer for welcome API? The very first step that I have done, I removed port number from welcome API YML file. I don't want to fix the port number. Port number I will supply in the runtime. Port number I will supply in the runtime and make the changes in the REST controller to display port number in the response. So if you see my welcome REST controller, earlier it was sending only message as a response. Now along with the message, it is sending port number also in the response. Okay. So let me take this REST controller. So these are the changes I have done for this REST controller. So with these changes, it will send the port number also in the response. So in which server this REST API is getting executed and which server processed our request. I'm running this API in 3 servers, nothing but 3 instances. Okay. So I removed port number from the configuration file and I have made some changes to the REST controller to send port number in the response. Then next one, how to run this application with the multiple port numbers. Okay. So for that, right click on the application, run as run configuration, select the welcome API, go to VM arguments and give the port number and run this application. So with this, one instance is going to run. Then next one, I'm going to run with the another instance 8082 and I'm going to run another instance with the 8083. Okay. So with this, my welcome API is going to run in the 3 servers. So nothing but 3 instances available. It is running in 3 servers and 3 instances available. Okay. So how we are implementing that load balancing? Why we are going for the load balancing? Load balancing is used to run our application in multiple servers and distribute the load to all the servers. If we run application in one server, then burden will be increased on that server. To overcome the burden problems on the server, we are going to implement load balancing. Our application will be deployed in multiple servers. Same application we are deploying in multiple servers, nothing but multiple instances available for the same application so that the requests can be distributed to multiple servers. What are the advantages we have with this approach? Less burden will be there on the server, quick responses to the clients, no single point of failure. So how we have implemented this load balancing? I removed port number from configuration file, remove port number from configuration welcome API YML file, remove server port number, remove that server port number from welcome API YML file, then make the changes in the REST controller to display port number in the to send port number in the response. So what are the changes? I injected environment object and I'm getting server port number. I'm adding that to the response. Okay. Then I'm running this application in 3 instances, guys. How to run this application in the 3 instances? Right click on the application, run as run configuration, and I'm giving the server port number dynamically. So first server, I'm starting with 8081. Second server, I'm starting with 8082. Third server, I'm starting with 8083. Once it is started, then next one, start greet API, start greet service, or else you can check Eureka dashboard. Once it is started, 3 servers are started, check Eureka dashboard, and observe 3 instances available for welcome service or not. Okay, so in the Eureka dashboard, very clearly it is going to show you how many instances available for your welcome service. Up 3 instances are up and running and 3 URLs available. You can see the port number differences also. Then after this is completed, then the next step now, start greet service and send request to greet service, and check inter-service communication. So in the greet service, already we have implemented Feign client. So whenever the request comes to the greet service will communicate with the Feign client. That Feign client is used for service communication. So my requirement is, whenever a request comes to the greet API, that greet API should communicate with the welcome API. For this communication in the greet API, I developed Feign client, right? For the Feign client, I am not giving the URL because URLs can change in the future. So that's why I am giving the service name. So Feign client wants to communicate with the welcome API. Welcome API service name is available with the greet API, Feign client. Then what it will do? It will go to the service discovery and it will ask, it is going to ask, hey, service discovery, I want to communicate with the welcome API. Can you tell me the URLs of the welcome API? For the welcome API, it's not one URL. For the welcome API, there are 3 URLs available. So out of these 3 URLs, with which URL Feign client should communicate with the welcome API? That's where that Feign client is going to communicate with the ribbon. Ribbon is a internal component for the Feign client. Ribbon is internally working in the Feign client. You no need to do any configuration for the ribbon. It is inbuilt in the Feign client. So Feign client will talk to ribbon. It will tell to ribbon, boss, I have 3 URLs to communicate with the welcome API. You tell me what to do. Then ribbon will tell to the Feign client with which URL it should communicate. So here ribbon will provide a mechanism for distributing the request to multiple servers. What mechanism it is going to follow? It will follow round robin mechanism. So what is the meaning of round robin mechanism? First request will go to first server, second request will go to second server, third request will go to third server. So that is the reason when we are sending the request to the greet API communicating with the welcome API running in 3 servers, every time we are getting the response from a different server. So if I don't display this port number in the response, you will not understand load balancing is working or not. Now see, for every request, different port number is coming. That means every request is processing by different server. Welcome API request is processing by different server. So we are able to achieve load balancing for the welcome service. So greet API communicating with the welcome service running in 3 instances. So greet API having a Feign client. Through Feign client, it is communicating with the welcome API, and Feign client communicating with the different server every time by using ribbon. So this is all about load balancing in the microservices. So this is about load balancing of microservices. Are you guys clear?
Sir, you cleared the port number from property file. So environment.get property, it's picking from it will pick null, right?
No, sir. Environment.get property, whatever the port number it is running, server port number, I am supplying that server port number in the runtime.
Okay.
Instead of passing from the YML file, I'm setting the port number in the runtime as a runtime argument and I'm sending. So once the server is started, so in which server it is running, that server port number it will pick up. First server running on 8081, second server 8082, third server 808. It will take the port number in the runtime from the server in which this application is running. So that is the reason every time in the response you can see a different port number.
Okay.
That is a proof to say that every request is going to different server, load balancing.
Sir, I have a small doubt, sir, here.
Yes, tell me.
Sir, is it possible to use load balancing concept through REST template or web client? Because, sir, if it's possible, sir.
No,
Yeah,
sir, this
sorry.
kind of load balancing we can't use with REST template or web client because if you go with the REST template, you need to give the direct URL with which URL you want to communicate.
Sir, but it's not possible, right? So, but in the Feign client, we are going to give the service
If you
name,
want to
right?
use REST template or web client, then load balancer should be available at the server side. Currently, load balancing happening at the client side. If you want to use REST template, then this kind of load balancing, all these servers should be configured with one load balancer. This load balancer we can take in the AWS cloud. Then REST template can send the request to the load balancer of AWS. So that is server side load balancing. Currently, whatever we implemented, that is a client side load balancing. Feign client only deciding to which server it has to send the request. Server having 3 URLs. So which URL it should use for communication, that is decided by the Feign client. This is client side load balancing. Suppose if you don't have the Feign client concept and all, how to implement load balancing? Then you need to go for server side load balancing. You need to go to AWS cloud. There you need to create a load balancer. All the servers should be added to that load balancer. Then you will send the request to the load balancer URL. Then load balancer URL will distribute the request to all the servers. Client side load balancing will be available. Server side load balancing will be available. If you want to implement server side load balancing, you need to use cloud. AWS will provide, Azure will provide the load balancer. Currently, we are not using cloud. So that's why we are going for client side load balancing. Client side load balancing means client only will decide with which server it should communicate. That is the difference.
Sir, welcome service. Sir, welcome service running in different port number, but they actually uses only one Tomcat server or not?
3 different Tomcat servers, sir.
Okay, sir. Means number of port numbers when we define at the runtime, then multiple same server is running Tomcat.
So first time it will run in one Tomcat server, first server. When you run second time, second Tomcat server will start. When you run third time, third Tomcat. These are embedded Tomcat servers, right? For every instance, separate server. 3 servers are running for the same application with 3 different port numbers.
Sir, if we do not provide any port number at runtime, then what will be taken by JVM?
Default port number.
Okay, sir. Thank you. Thank you.
Sir, we have configured only one Tomcat server. Within the Tomcat server, 3 port number you have been configured.
Yeah, we have not configured one Tomcat, sir. It is an embedded server. When you run a Spring Boot application, it will start the Tomcat server automatically. So we started application 3 times means 3 Tomcat servers are started. Every Tomcat server using different port number. It's not one Tomcat.
IP address is different.
3 Tomcats.
Only here we have configured IP addresses, not the server names. If you deployed in the AWS, how we configure here?
If you deploy in the AWS, same processor, your services will be available in the AWS. Means in the AWS, one Linux machine we are going to take and we will deploy in the Linux machine. That's it. Here we are running in the Windows machine. So in the real time, we will run these things in the Linux machine.
Okay, sir. Then here Feign client is work only for the 2 projects within the same server only.
Correct, sir. So if you are having microservices with the same service discovery, if these two APIs are registered with the same Eureka server, that's why we are able to achieve this inter-service communication with the service name. If these 2 APIs are not in the same service registry, then you need to use the service URL for the communication.
Okay, sir.
Okay. Instead of doing the load balancing in microservices in multiple Tomcat, if we are going to do the load balancing in AWS with multiple EC2 instances, So which one would be better? Actually, that is the
Sir, it depends on your scenario, sir. Whether you want to go with, if you are using cloud platform in your project, then server-side load balancing is better. If a cloud platform is not there for your project, then client-side load balancing is better. It depends on your project scenario. Whether you want to go with server-side load balancing or client-side load balancing. If your project is using cloud, then go with server-side load balancing. If your project is not using cloud, then go with client-side load balancing.
Okay. So what will be the scenario in single EC2 instance? We will deploy multiple Tomcats.
Yes, sir.
Or multiple EC2 instance we will have.
Correct. So what type of load balancing we implemented today, guys? Is it server-side load balancing or is it client-side load balancing?
Client-side.
Client-side load balancing. Why we are calling this as a client-side load balancing?
Because you're going to validate in the client side only.
Yes, it is deciding at the client side with which URL it has to communicate. If you go for server-side load balancing, it will decide at the server which type of which server we have to connect. For establishing server-side load balancing, AWS cloud concept, AWS load balancer we have to set up.
Sir, a small confusion, sir. So as per my project specific, so in my project, sir, we are using a REST template, so we can't able to configure this Feign client, sir.
Are you using service registry?
Yes, sir.
Then you can replace that REST template with Feign client.
Okay, so
in that service registry, you can replace that REST template with the Feign client.
So in all the places we need to change the URL, right, sir?
Correct.
Okay. Thank you.
Fine, guys. So with this, we understood what is load balancing and load balancing, implement load balancer for welcome API. In the document, I'm giving everything clearly. So what are the changes you need to do in the REST API and how you will run that API in the multiple servers. Okay. So here you need to remember, as we are running this API for 3 times, it will run in 3 different servers with different port numbers, guys. So with this, our API will run in 3 servers with 3 different port numbers. It's not one Tomcat server, guys. So when you execute this, one Tomcat will start. That is embedded Tomcat server with the port number 8081. And when you do this, it will start another Tomcat server with port number 8082. When you do this, it will start another Tomcat server with 8083. That means 3 instances are running for the same API. Same application will run in 3 servers. Why we are running same application in 3 servers, guys? Why we are running same application in 3 servers?
For load balancing.
High availability and high availability.
Yes. In order to implement the load balance. Okay.
Sir, where we configure the ribbon configuration?
We don't do that, sir. It is internal. It is inbuilt.
Yes, sir. It's internal. Yeah.
It is taken care by Feign client. We are not configuring ribbon anywhere. It is inbuilt.
Sir, if there is any scenario where both will be implemented, sir, client side, server side?
So only one we are going to use.
Only one, sir. Sir, sometimes there are distributed data centers, right, sir? Some place one data center, other place other data center. Can
then
we
server
use
side load balancer concept will come into picture, sir.
Okay, sir. Okay.
So in the client side, is the ribbon is the only one, or is there any other alternative?
No, sir. Ribbon in the Feign client only ribbon is available.
We have multiple flavors of other than round robin. We have different flavors also, right?
Yes, sir. Sticky session is available. IP hashing is available. So all those things will be configured using that server side load balancing mechanism. Okay. Which request should go to which server, that can be configured with the load. Those are called load balancer algorithms.
When we have multiple data centers, then we use that, right?
Yes, we will use that.
Ashok sir, like in a real-time scenario, do we follow the same approach or there is some another approach?
I told you, if your project having cloud infrastructure, then better to go with the server side. If your project don't have the cloud, okay. Yes, perfect. Now, next one. So with this, we understood how to set up our microservice application with the inter-service communication using Feign client and by using load balancing also. Our service registry is running on the port number 8761. Our admin server is running on the port number 1111. Zipkin server is running on the port number 9411. Okay, then our greet API is running in the 9091. Our welcome API is running with the 8081 series. So welcome API, instead of running in one server, I'm running the welcome API in 3 servers. Nothing but 3 instances I'm running for the welcome API. So when we have 3 instances, load balancing we can achieve. The load can be distributed to all the instances in the round robin fashion. All the instances in the round robin fashion. Okay guys, now, so Feign client we are using for inter-service communication. The benefit of using this Feign client can communicate with the APIs by using API name, not with the API URL. So greet API using Feign client, and it is configured with welcome service name. So Feign client will talk to service registry, will get the service URL. So that service is having more than one URL. So it will communicate with that by using ribbon. Ribbon will help to the Feign client to identify which load balancing algorithm it should follow. So by default, it is going to follow round robin algorithm. First request will go to first server. Second request will go to second server. Many people are getting confused. So the welcome service running in 3 instances. That means how many servers are running? 3 servers are running. Every instance means one application which is running in one embedded Tomcat container. So here for the welcome service, 3 Tomcat containers are running with 3 different port numbers. Okay, good. Next one, that is API gateway in the microservices. So we already discussed it theoretically. What is the purpose of API gateway in the microservices? API gateway is going to act as a entry point for all the backend APIs in our application. This API gateway is going to act as a mediator between front-end application and backend applications. API gateway will act as a mediator between front-end application and backend application. Mainly we are going to write filters and routings in the API gateway. So as we see in our diagram, so backend microservices are available and front-end UI application will be available. So directly we don't share the URLs of the backend microservices, because in the backend 20, 30, 40 microservices can be available. We don't give all these microservices URLs to the UI application. For the UI application, we will give API gateway. So any request that is coming to our application should go to API gateway. API gateway will verify that request is valid or not. If the request is valid, then only API gateway will forward that request. Otherwise, API gateway will stop that request. Okay, so now how to set up API gateway for our application? As of now, what we are doing, I'm directly sending the request to greet API. I'm directly sending the request to welcome API. We should not do this. We should not give our API URLs directly. Always the backend microservices should be accessed through API gateway only. So what is the API gateway in the microservices? It is the entry point for all the backend APIs. It is going to act as a mediator between front-end application and backend applications. What we will do in the API gateway? In the API gateway, we are going to implement filters and routings concept. Filter is used to validate that request is valid or not, and routing is used to forward the request to particular microservice. So how we are going to work with API gateway? Working with a Spring Cloud API gateway. Working with the Spring Cloud API gateway application. Okay, good. Now, first step, you create one Spring Boot application with below dependencies, guys. In order to work with the API gateway, create one Spring Boot application with below dependencies. Eureka client dependency, cloud gateway dependency, DevTools dependency we are going to create. And the next one, configure enable discovery client annotation. So whatever the API gateway we are developing, that API gateway is acting as a client for the Eureka server. whatever the API gateway that we are trying to develop, that API gateway will act as a client for the Eureka server. So that is the reason we are configuring enable discovery client annotation in the start class. So to create API gateway, Eureka client dependency, cloud gateway dependency. This is the new dependency we are going to add in our application, and we are going to configure discovery client. And the next one, configure routings in the API gateway. That means which request should go to which API, greet API available, welcome API available. So from the UI, the request will come to API gateway. So which request should go to greet API, which request should go to welcome API. Those routings we are going to configure in the API gateway. Those routings we are going to configure in the API gateway. Then if you want, you can create a filter also in the API gateway in order to verify that request is valid or not. You can create a filter. Create filter to validate incoming request. Create filter to validate incoming request. So that request is valid or not, we can verify that by using a filter concept. You can verify that by using filter concept. Now I will show you normal filter. In the Spring Security, JWT filters we are going to create. JWT token we are going to validate by using filter. Okay, good guys. Now let me start API gateway project creation. So I'm going to create a 6th application, file, new, Spring Starter project. File, new, Spring Starter project. 06 API gateway project I am creating. 06 API gateway I am creating. Click on next. Dependencies, discovery client, dev tools, cloud gateway. New dependency we are adding first time in order to represent this application as a gateway application. Okay, so I'm using gateway dependency. Cloud gateway dependency. Yes. So we are taking the gateway, provides a simple, effective way to route the APIs in the server-based applications with cross-cutting logics. Reactive API gateway is available and a normal API gateway is available. So let me select this reactive gateway or normal gateway. Okay, anything is fine. Next and finish. So with this, I created my API gateway project. So I will represent this API gateway as a Eureka client, guys. Gateway project is getting created. Gateway project is getting created. So let me configure this as a discovery client application.java. So to configure this as a discovery client, we are going to use one annotation, that is enable discovery client. We are going to use one annotation that is called discovery client. Yes, let us write this. Enable discovery client annotation. And coming to the properties file, I'm converting this properties file to YML file. Okay, so API gateway, this is the name of the service I am taking, and port number I am configuring, server port number. API gateway should run on the port number. Server port I'm configuring as something like 3333. API gateway port number I'm configuring as 3333. That is good. Now we need to configure routings here, guys. So which request should go to which URL we need to configure. Think 1 minute. And the API gateway, the dependency it is coming as MVC dependency. I think it is wrong. Reactive gateway we need to select. Okay, cloud starter gateway, not this MVC gateway. We should not use this MVC. At the time of creating the project, select reactive gateway, guys. Okay, so cloud reactive gateway. You need to select the dependency as reactive gateway. and a DevTools dependency available. Yes. Now, so if you observe, Cloud Starter Gateway dependency available, Netflix Eureka client dependency available, DevTools dependency available. Perfect. So I'm able to create my API gateway application, and I'm configuring this application as a Eureka client by using enable discovery client annotation, and I configured routings in the YML file. What routings? Which request should go to which service? I need to configure the routings. Observe very carefully how we are going to configure routings. So to configure routings, so what I am going to tell to the API gateway, if any request comes with the /welcome, then send that request to welcome API. If any request comes with the greet, then send that request to greet API. So what I am going to tell to the routings in the API gateway, if request comes with the /welcome, then you send that request to welcome service. If any request comes with the /greet, then you send that request to greet service. So that is the routing we are going to update. So high level. So any request which is coming to our application, the request will come to the API gateway. What I will tell to the API gateway, boss, you need to do the routing. If the request URL is /welcome, then you send that request to welcome service. If the request URL is /greet, then you send that request to greet service. So that is the routing we need to do in the API gateway, because API gateway is a mediator between front-end application and back-end microservices. And the API gateway is the entry point for all the back-end microservices. Now, how we are going to configure the routings? Observe carefully. Spring dot cloud dot gateway routes. Cloud dot gateway dot routes. Spring dot cloud dot gateway dot routes we need to configure. Okay, gateway routes. So what are the routes? First, ID. So this is my first API. So I'm going to specify my welcome API. So when the request should go to welcome API, this is the URI load balancing /welcome service. Name of the service I am going to specify. When the request should go to this service, so let me configure some predicates. I'm going to configure the predicates. So in the predicates, I'm going to specify what is the path. I'm going to specify what is the path. That path is equal to /welcome. So this is my configuration. So what this configuration is going to represent, guys, whenever a request comes with the /welcome, I want to send that request to welcome service. I'm telling load balancer of the welcome. LB : nothing but load balancer of the welcome. Here ID, you can say API 1. Okay. Similarly, I'm going to configure another ID. Which is API 2. For this, I'm going to specify the URI, that is the load balancer /greet service. And for this, predicates represents the rules. When that request should go to which API, if the request path is equal to /greet. If the request path is equal to /greet, it should go to greet service. If the URL pattern is /greet, go to greet service, load balancer of greet service. Greet service can have more than one URL also. So whenever you configure the cloud gateway, internally cloud gateway also will use the ribbon for doing the load balancing. It will use a ribbon concept, right? So what is the meaning of this? In my application, there are two microservices available, API 1 and API 2. So whenever a request comes to the API gateway with the URL as a /welcome, you route the request to welcome service. /welcome URL pattern belongs to welcome service. /greet URL pattern belongs to greet service. So So that is the meaning of this configuration. You observe the configuration that we are doing in the API gateway. Guys, observe the configuration that we are doing in the API gateway. Whenever a request comes to the API gateway, if the URL is /welcome, I am telling to API gateway to forward that request to welcome service. If any request comes with URL as /greet, I am telling to forward that request to greet service. So what is this LB colon? LB colon means I am telling to API gateway to forward the request based on the name of the service, not with the URL, because welcome service can have multiple URLs, greet service can have multiple URLs in the real time. So one service can have multiple URLs. That's why I am telling to forward the request with the load balancing mechanism. Internally, API gateway also will use a ribbon, because whenever a request comes with /welcome, welcome service having 3 URLs. So to which URL it has to send the request? Internally, the ribbon load balancing mechanism will work in the API gateway also. So in the API gateway, these kind of routings we are going to configure. So what are the routings here? If a request comes with the /welcome, send that request to welcome service. If a request comes with the /greet, send that request to greet service. So this is the name of the API gateway and this is the port number of the API gateway. Are you guys able to understand how to create API gateway now? Are you guys clear with this one? How to create API gateway? Working with the Spring Cloud API gateway. Eureka client, we are adding as one dependency because I want to register this application with the Eureka client and I want to configure the gateway. So that's why I'm configuring Cloud Reactive Gateway dependency and I'm configuring DevTools. So how to represent this application as a Eureka client? By using enable discovery client annotation, we are configuring this. Then configure routings. So which request should go to which microservice in the backend, that we are configuring in the API gateway routings YML file. What routings I configured? If request comes with /greet, forward that request to greet service. If a request comes with /welcome, forward that request to welcome service. Here I am giving URL LB. LB means load balancer. These services can have multiple URLs. Ribbon will be used in the API gateway to identify which request should go to which URL. Which request should go to which URL, that we can specify. Along with this, if you want to implement a filter for your application, you can create the filters also in the API gateway. So let me create one class as a filter in .ashokit.filter. So I'm creating my filter. You can create filter according to your requirement. So my filter I'm creating. So this filter I am making as a global filter. Implements one interface called global filter. Yes, to represent this as a Spring Bean, I'm using one annotation called @component annotation. So when we are implementing global filter, we need to override a method called filter method. So how do you want to validate that request? So if you are having OAuth tokens, JWT tokens, then you can validate that request. You can validate that request by using this filter. So inside this, just I will show you whether this filter is getting executed or not. System.out.println, I'm going to say a message, filter is executed. I will just show you the message whether this filter is getting executed or not. If the filter is getting executed, then what logic we can do? We can validate request. We can validate the request. If the request is valid, then only we'll proceed. Chain.filter, I'm going to pass that exchange object. So if you do this, the request will be forwarded. Otherwise, the request will be failed. Now I will show you how to validate that request also by using this API gateway. This is pending. How to validate the request, that is pending. First, let us verify really this filter is getting executed or not, and the routing is working or not. If this filter is executed, then I will implement the logic to validate that request. Okay, good. Now let me start our API gateway project, guys. Let me do the Maven update. Maven update this project. API gateway is ready. Now you no need to send the request to greet API, welcome API directly. We will send the request to API gateway. API gateway will run on the port number 3333. API gateway will forward the request to backend microservices. In the API gateway, filter also available, but currently there is no logic available in the filter. I will implement this logic also to validate that the filter is working as expected or not. Okay, good. Let me run API gateway application, run as boot application. Go to Eureka server and check it. API gateway is registered with our Eureka or not. Check this. API gateway is registered with Eureka or not. Come on. Yes. Now you can see API gateway is registered with the Eureka. API gateway running on which port number, guys? API gateway is running on the port number 3333. Now I want to access greet API. I need to send the request to greet API directly, or I need to send the request to API gateway, guys. My API gateway is running, which is entry point for all the backend microservices in our application. So I need to send the request to the greet API directly, or I need to send the request to the API gateway. Come on. I need to send the request to the API gateway, or I need to send the request to the greet API directly. API gateway. Which port number it is using? API gateway running on which port number? API gateway running on which port number? API gateway running on which port number, guys? 3333. Now can you tell me how to access this API gateway application now? I want to access greet API. I want to access greet API. How to access it? What is the URL to access greet API now? Yes, localhost colon 3333 /greet. 3333 port number belongs to which application in our microservices now? Which application running on the port number 3333? API gateway running on the port number 3333. I'm sending a request with a /greet. What is the meaning of that? So request will go to API gateway 3333 port number, URL greet, then forward the request to greet service. Greet service having a Feign client. It will communicate with the welcome service. Load balancing also will work. Now send the request to the greet URL and check the console. The filter is working or not. And check the console. The filter is working or not. Open the API gateway console. Clear the API gateway console. Now let us see filter is working or not. Send the request. I'm sending the request. Yes. Am I able to get the response from the greet API? I am sending the request to API gateway and I'm getting the response from the greet API. Can I say my routing is working now? Guys, can we say my routings are working? Whatever the routing I configured in the API gateway, is that routing working as expected or not? I'm sending the request to the API gateway. I'm getting the response from the greet API. Go to here, check the console of the API gateway. The filter is working or not. Filter is also executed. Filter is working. API gateway also working. Routings also working. Now, anybody able to send a request to the API gateway 3333 greeter 3333 welcome also working. Load balancing working for the welcome API. So 3333 /welcome. First request processed by first server, second request processed by second server, third request processed by third server. So this is also working. This is also working. So now With this, we are able to say that routings are working. With this, we are able to say that routings are working. Now, filter is also working. For every request, my filter is executing. Can we validate the request? Can we validate the request by using filter? If the request is valid, then only I will process. Otherwise, I will stop the request. If the request is valid, then only I will process the request. Otherwise, I will not process the request. So you can, because implementing the security for all the microservices not recommended. So security is common for all the microservices. So will you implement security for every microservice in the application, or security will be available at only one place in the application? Request validation. So will you write the logic to validate the request in every microservice, or we will write the logic to validate the request in the API gateway? Come on, guys. Will you write that logic in every microservice, or you will write that logic in the API gateway? We will write that logic in the API gateway. So what is the request validation I will do? What is the request validation I will do? So if request contains secret token, if request contains secret token, so if request contains below header, then it is valid request. What I will do, header key I will keep secret is equal to ashokit@123. So when anybody sending a request to my API gateway, so if it is my client application will send one request header. Header key is secret, header value is ashokit@123. If the request contains below header, then it is valid request. So process it. Header secret is equal to ashokit@123. If header is not present, if above header is not present, then it is invalid request. Don't process it. So this is not from our client. If the request is coming from our client, then this header will be available in the request. If this header is coming in the request, then only it is valid request, then process that request. If the request does not contain this header, that means it is invalid request, then don't process that request. Create a filter to validate incoming request. If request contains below header, that means it is valid. If above header is not present, that means it is invalid request. So this request validation, instead of doing this request validation in every microservice, we can do that in the API gateway. API gateway is an entry point for our application. So API gateway filters will be available, routings will be available. Filter is working. For every request, the filter is working, routing also working. The request is able to forward to the particular microservice. Now, I want to validate that request by using this condition. Are you clear with my condition to validate the request? Are you guys clear with my condition to validate the request, guys? If request contains the header, key is secret, value is ashokit@123, then only it is valid request, I will process it. If the request does not contain the header, if a header value is not matching, then it is an invalid request. I will throw the exception. I will not process invalid request. Are you able to follow me? What kind of logic we will do in the filter? Filter is used to pre-process. The request. Okay. So currently this is basic request validation. Advanced request validation, JWT token. In the Spring Security, JWT token we are going to learn. So in that JWT Spring Security topic, I will explain about the JWT token, how to validate the token by using filter. We will discuss in the upcoming classes. Are you clear? Yeah, this is just for our understanding. Secret token I am just using for our understanding purpose, how to validate. In the real time, token will not be available like this. In the real time, JWT tokens will be used. So today I'm using hard-coded token. for your knowledge how to validate the request, just for our idea purpose. This is not the best practice. In the real time, JWT token will be used to validate the request. Today concept not about the token. Today concept how to validate, how to work with the filter. You got the clarity? Guys, come on. Yes. So how to check that request is having that header or not? So to check that request is having the header or not, we are going to first take the request from this exchange object. Exchange is one object for the filter method, right? Exchange dot get request. I'm getting that request object, which is servlet HTTP request will be available. Server HTTP request we got. Then request dot get headers. What are the headers coming in the request? HTTP headers I'm accessing. Then from this HTTP headers, I'm going to get the keys. Headers dot key set. All the keys I am getting from the headers. Now in that keys, my secret token is available or not, I will verify. If key set dot contains secret, that means the header is present. Suppose if that keys, whatever the request is coming, in that request, what are the headers coming? In those headers, what are the header keys available? So those keys contains my key called secret or not. If key set does not contain this token, this header, then I will throw new runtime exception. Throw new runtime exception saying that it is invalid request. Throw runtime exception, I will say that it is invalid request. Okay. Suppose if the token is available, token value is matching or not. So token header should be secret, value should be ashokit@123. First of all, so whatever the request is coming, I'm taking that request by using this exchange object, exchange.get request. I got the request object. From that request, I'm getting all the headers from the request I'm receiving. Headers.keyset. What are the keys available in the header? I'm getting all the keys. In that keys, secret key is available or not? I am validating. Okay. Key set dot contains of secret. I'm validating. If the key does not available in the header, then it is a invalid request. Suppose if the key is available, let me check its value. Headers dot get of key. I want to get its value now. How to get it? Headers dot get of my key. My key is secret. Let me get the value of this. List of values we are going to get. List of get. I'm going to see if list dot get of 0, which is not equals to ashokit@123. Fixed value I am using now for our understanding. If this list of values does not contain this value, then this is a invalid request for me. I will not process. I will throw the exception. So if the header contains secret and if secret contains the value as ashokit@123, then only that is a valid request. Then only I will process. Otherwise, I will not process this request. So this is very basic filter implementation, guys. So in the real time, this will not be hard coded like this. In the real time, token will be dynamic. JWT tokens will be used in the real time. So in the upcoming classes, we will see how to work with the JWT token and how to validate that token. Currently, I am taking hard coded token just for filter implementation part. Are you clear with my filter logic? What is the purpose of a filter in the API gateway? What is the purpose of the filter in the API gateway? What is the purpose of the filter in API gateway? What is the purpose of a filter in the API gateway? To perform pre-processing, to validate the request. How I am validating the request here? I'm getting the request object. From the request, I'm getting the headers. From the headers, I'm getting all the keys. Okay, keys I am checking. Is there any key with a name called secret? If this key not available in the header, I will not process the request. I will say invalid request. And if that key present, what is the value of that key? If that value is ashokit@123, then only I will process. Otherwise, I will throw the exception. Okay. If these two conditions, first condition to check secret header is available or not. Second condition, that header value is ashokit@123 or not. I'm going to check this now. So now let us verify. Now can I access my application from the browser now? Is it possible to access our application from the browser directly? Can you access application from the browser? API gateway, send the request. What is saying, guys? 500 error. Why it is failing now? So user able to access our application, or user is not able to access our application? User is able to access our application. User is not able to access our application. Not able to access our application. Why user is not able to access our application now? Why user is not able to access our application? Header is not available. So application is expecting a header. Client is not sending the header. That's why it is failing. So now how to send the request along with the header? How to send the request along with the header now? Postman. Okay, go to Postman and let us send the request to the API gateway. To access our microservices, we need to send the request to the API gateway along with the header. If a header is present, if a header is valid, then only our request will be processed. Otherwise, our request will not be processed. Now, so let me go to this one. Get request I want to send to the application. So which is http://localhost:/3333/greet. 3333 is the port number of which application, guys? So which microservice running on the port number 3333 in our project? Which microservice running on the port number 3333? API gateway. So I'm not sending any header. Click on send request. When I send the request, what is happening, guys? Request is processed or the request is failed? Request is processed or request is failed? Request is failed. Why the request is failed? Header is not present. Okay, 500 error, header is not present. Now send the header in the request. The header key, which is secret, I'm using that key. For that headers key is a secret. Its value ashokit@123. Now I'm sending a header. Key is secret. Value is ashokit@123. Send the request. Now when I send that request, am I able to get the successful response? 200. If I'm sending a request along with the valid header, am I able to get the successful response from the API? So with this, can we say filter is working, routing also working in the API gateway? Filter is working, routing also working in our API gateway. If I send the request without this header, I remove this header, delete this header. Okay, I deleted the header, send that request. Now it is failing. 500 internal server error. So now our application is a secure, basic security, very basic security. If the token is coming in the request header, then only API gateway will validate that request. Otherwise, API gateway will not process your request. So what is the role of the API gateway in our application? API gateway is acting as a entry point for all the microservices. So what logic is available in the API gateway? In the API gateway, filters logic is available and routings logic is also available. In the API gateway, filters logic is available, routings logic is also available. Are you clear with my point? how to implement filters and how to implement routings in our API gateway. So this is the filter I have implemented. I will give you filter logic. Anyhow, this code I will push to GitHub repository. You can access it. Yes, so we are able to complete API gateway project also. What is cloud config server and what is the purpose of going for cloud config? So what is cloud config server and why we need to go for cloud config server? So anybody having any basic idea what is cloud config server? Do you know what is cloud config server and what is the purpose of this cloud config server, guys? What is cloud config server? Anybody having any idea on that?
Actually, the common properties which we are writing in all the services, so we can write an
external properties that can
in
able
our
to
application,
configure
guys.
and run.
Yeah, when we are working with application, we are configuring application config properties in the properties file or in the YML file. So in the Spring Boot application, by default one properties file will be created. You can convert that properties file into YML file also. So we are configuring our application properties, config properties in the properties file or in the YML file. What type of properties we will configure? These properties will be like this. Database properties will be available. SMTP properties will be available. Kafka properties will be available. And some application messages also will be available. So all these properties we are going to configure in the application.properties file or in the application.yml file. So when you configure them in the properties file or in the YML file, then they will be part of our application package. So in order to run our application, we are going to package our application as a jar file. Every Spring Boot application will be packaged as a jar file because it will execute from the main method. Application properties or application YML file will be packaged along with our application. It will be part of our jar file. So in the real time, how our application deployment process is going to happen, guys. So application code, as a developer, we are writing the code. That code will be available in the Git repository. Development team will write the code and a development team will store that code into Git repository. Then operations team is going to take that code by using Jenkins. Okay, we are going to take that code by using Jenkins. Then we will build that code by using Maven. Jenkins will pull the code from the GitHub. Then it will communicate with the Maven in order to build that code. Then after Maven build got completed, Jenkins will perform code review by using SonarQube. After code review got completed, then for that code, security scan will happen by using Trivy. Security scan will happen on that code by using Trivy. Once all these scans are completed, then that code will be uploaded into Nexus or JFrog artifact repository. That code will be uploaded to JFrog repository. And once it is done, then finally that code will be packaged as a Docker image. So that code will be packaged as a Docker image. After the Docker image is created, finally that code will be deployed into Kubernetes. So in the real time, this much process will be available in order to deploy our application. So development team will write the code in the project and they will push that code into GitHub repository. Once the code is pushed to GitHub repository, we need to pull that code from the GitHub by using Jenkins CI/CD pipeline. Then Jenkins will communicate with the Maven in order to build that project. Then Maven will communicate with the SonarQube to perform the code review. Then it will talk to Trivy for security scan. Then it will upload the project jar file into JFrog repository. Then it will build a Docker image for our application. Then finally, that Docker image will be deployed in the Kubernetes cluster. So this much process will be available in order to build and deploy application build and deployment process. Application build and deployment process. So this is the process that we need to follow in the real time in order to deploy our application to the server. So code is available in the GitHub. We need to take the code from the GitHub by using Jenkins. Then we will build that code by using Maven. Then we need to review that code by using SonarQube. Then we need to perform security scan by using Privy. Then we need to upload the code artifact into JFrog. Then we need to build a Docker image for our application. And we need to convert that image into execution by using Kubernetes. So here, if you observe in our project, application properties file or application YML file is available. It is part of our project. So in that properties file or YML file, we are configuring database properties, SMTP properties, Kafka properties, and application messages also we are configuring. Now tomorrow, when you want to deploy your application, when you are packaging your application, that properties file also will be packaged. Okay, so if you see API gateway, inside this API gateway, there is one YML file is available. In this YML file, we are writing some configurations. So tomorrow, when we package this project, this YML file also will be part of the jar file. Application.properties file or application.yml file will be packaged along with our application. It will be part of our jar file. Suppose if I want to make any changes, to the properties file, some database properties I want to modify. If we want to make any changes to the properties, then we have to repackage our application and we have to redeploy our application. So if any changes required in the configuration properties, then we have to repeat the complete project build and deployment process, which is time consuming. So if you make a minor change in the properties file also, then you need to repeat the complete process. You need to take the latest code from the GitHub. You need to build that code by using Maven. You need to review that code by using Sonar. You need to perform security scans by using Privy, and you need to upload the artifact into JFrog, and you need to build a Docker image, and you need to deploy that application in the Kubernetes cluster. So this complete process we need to repeat. When we are going for project build and deployment. So if I make a minor change in the properties file, again we need to repeat the complete process. We need to redeploy the entire application. That is time consuming process, and it is not recommended. So that is the reason it is not recommended to keep our YML files within the application. So we are writing database properties, SMTP properties, Kafka properties, everything inside our application.properties file or application.yml file. If you keep like that, tomorrow when you want to make some changes to the properties file or when you want to modify some properties in the YML, then you need to recompile, you need to repackage, you need to redeploy the application. Whatever the microservice is available, you need to repeat the complete process for the microservice if there is a minor change in the properties file. If code is changed, then okay, we have to do everything. If code modified, we have to do everything. If you modify the property also, you have to do everything. That is not recommended. So why this problem is coming? We are keeping the properties file within the application. So when you package this project as a jar file, this properties file, YML file also will go in the jar file. If you make any changes in the YML, again you need to create the jar. Again you need to deploy your application, which is time consuming process. Okay, to avoid this problem, we need to separate our project source code and our project configuration properties. Okay, guys, do you understand what is the problem if you are keeping the properties file or YML file within the application? Are you guys able to understand what is the problem if we are keeping project source code and project properties file at same place? Can you tell me what is the problem if you are combining the properties file and source code? Come on, guys.
Sir, we need to redeploy the application again. It will take time.
The entire application. We need to redeploy the entire application. So it is not recommended to keep the properties file or YML file within our application. So to avoid this problem, we have to separate our project source code and our project config property files. Okay, so to externalize config properties from the application, we are going to use cloud config server. So what is cloud config server? By using this cloud config server, we can make our application loosely coupled. By using cloud config server, we can make our application loosely coupled from the properties file and YML file. So how we are going to implement a cloud config server? Whatever the properties are required for my application, those properties I am going to keep in the GitHub repository. Okay, so GitHub repository I'm going to take. Suppose there is one application available, which is, for example, flights application available. So for flights application, one YML file is required, flights YML. Similarly, trains application is available. We are going to take this as trains.yml. And hotels application is available. For that, we are going to take a separate YML. So like this, for every project, separate YML file will be available, which contains database properties, SMTP properties, Kafka properties, Redis properties, whatever you want. Those things we are going to maintain in the GitHub repository. And we are going to create one config server application. We are going to create one config server application. This is another microservice. This config server is responsible to load the YML files from the GitHub repository. So whatever the projects, whatever the microservices are available, for our microservices, configuration properties, the YML files are properties file. Earlier, they are part of our project. If you keep them inside our project, then our project will be tightly coupled with the properties. Tomorrow, if you make any changes to the properties file or YML file, we need to redeploy. We need to build and deploy entire application, which is not recommended. To overcome that problem, we are going to use config server. By using this config server, we can separate the project source code and the properties. So how we are going to maintain the property files in the real time? The property files we are going to keep in the GitHub repository. So whatever the microservice available, with your microservice name, you will create a properties file. So flights available, flights.yml. Flights API, flights microservice available. For that, I'm giving the file name as flights.yml. Trains API available, I'm giving the file name trains.yml. Hotels API available, I'm giving the name as hotels.yml. So now all these YML files will be loaded by our config server. All these YML files will be loaded by config server. And whatever the microservices are available, our microservices will act as a client for the config server. So for example, here flights service is available. Okay. And this flights service application is our microservice. That microservice will register with the config server. So our microservice will act as a config client now, config server client. Similarly, trains API is available, trains service available, one microservice. This microservice also will register with the config server. And similarly, hotels service is available. This is another application. This hotels service also going to register with the config server. It is also going to register with the config server. So like this, our microservices are going to register with the config server. Config server will get the YML files from the GitHub repository. Now, for this flights service, microservice, name we are going to configure, name is equal to flights. based on our microservice name, config server will identify from which YML file it has to get the properties. So in the GitHub repository, there are 3 YML files available. So in the application, there are 3 microservices available. For which microservice, which YML file is required, it depends on name of the microservice. So my microservice name, I'm configuring as a trains. Then it will identify that. So then config server will identify that for the trains microservice, trains.yml file data is required. So this name, whatever the microservice name you are writing, that name should match with the file name in the GitHub repository. Here, hotels service is available. What is the name of the hotels service? Okay, name is equal to hotels. So with this hotels name, is there any YML file available? Yes, hotels.yml file is available. So like this, config server is going to load the configuration properties from outside. Now tomorrow, when you make the changes to the YML file, which are available in the GitHub repository, then you no need to redeploy your microservice. So your microservices are loosely coupled from the configuration properties by using config server. So which microservices you are developing? For those microservices, we need to assign one name. With that name, we need to create one YML file, and that YML file we are going to keep in the GitHub repository. And we are going to create one config server project. So that config server is going to load the properties from the GitHub repository. And our microservices will load the properties from the config server based on the name of the service. If your microservice name is flights, it will take flights.yml. Our microservice will not take from the GitHub directly. Our microservice will take the properties from the config server. Config server will take the properties from the GitHub repository. So with this, can we say our microservices are loosely coupled from the configuration properties? In the every project in the real time, we are going to follow the same approach.
Sir, one doubt regarding multiple database connection. How we will do, like Flight is using a separate database and train service is using separate database.
Yeah. Multiple databases, that every microservice will communicate with its own database. That database properties you are going to write in your YML file.
So same way how we are using now with the flight name as flight and train name, same way database.
Yes, same database or multiple databases you can connect.
Okay.
Okay, perfect guys. Next one.
Sir, on the YML, we make the changes separately, sir, and those will be maintained separately on GitHub, separate from this microservice.
Yes, sir. Earlier, our YML files are available within the microservice, but from now onwards, YML files we should not keep within our project. YML files should be available outside of the project. If you keep the YML files outside of the project, what is the advantage?
Right, sir. We don't need to make the change again and again on the.
We no need to redeploy our application again and again. We don't need to redeploy our application again and again.
So these YMLs are separate microservice, sir, or is just standalone files, sir?
These are just files we keep in the GitHub repository.
Just GitHub, okay.
For every microservice, a file will be available. So currently, the files are available within our project, right? Application and YML available within our project. So if you keep the YML within the project, when you package, that YML also will go in the jar file. So if any changes we have done to the YML, again we need to create the new jar file. Again, we need to redeploy the application. This is a complete process we have to repeat when you make a minor change in the properties file also. So that means our application is tightly coupled with the properties file or YML file. That is not recommended. So that's why we want to make our application loosely coupled with the YML files so that we can make the changes in the YML files without redeploying the application again and again. So how can we make our application loosely coupled with the YML file? That's where config server concept comes into picture. So how the config server is going to work? First, we need to identify what all the microservices we are developing. For those microservices, we need to assign one name, unique name we need to assign for every microservice. With that microservice name, we will create a file in the GitHub repository. That GitHub repository information we will give to the config server project. Here, config server is one microservice. This we need to develop now. We need to develop one microservice which will act as a config server. That config server will read the files from it will load the files from the GitHub repository and it will give to our microservices. Which file should be given to which microservice? That's where config server will identify name of the microservice. If this microservice name is flights, then it will give flights YML file to this microservice in the runtime. This microservice name is trains. It will take trains YML file, will give to train service. This microservice name is hotels. It will take hotels YML file, will give to that microservice. So our microservices are going to act as a client for the config server. Our microservices will act as a client for the config server. Okay. Now let me start.
One question is that all these microservices and config server all are going to be hosted on the same server. They are in different servers.
It can be in the different. Every microservice will run in the different server. Config server will run in the one server.
So if config server is crashed or it is not available, then the entire application will not work, right?
Yes, sir. You need to take care of a high availability. If a config server is not available, your microservices will not work.
So that is the main disadvantage of this way, right?
Yes. Now here,
sir, I have small doubt, sir.
Let me complete the topic. Any questions you can ask at the end. Okay. Config server is used to externalize config properties from the application, and we can use this cloud config server to make our application loosely coupled. And how to use this cloud config server? Cloud config server is part of Spring Cloud library. Cloud config server is part of the Spring Cloud library. How we have used Eureka server, Feign client. Similarly, we are going to use cloud config server, which is part of Spring Cloud library. Okay. Now, when we are going for this config server application development, application properties files we will maintain in the GitHub repository, and the config server will load them and will give to our microservices based on our microservice name. So when we want to implement config server in our microservices, application config properties files we will maintain in the GitHub repository, and the config server will load them and will give to our application based on the application name. So as I told you, so here microservice name, app name. So if you are configuring app name, if you are configuring the app name as flights, then it is going to identify flights.yml. So based on your application name, it will identify which YML file is required. So application name, if you are configuring as flights, then it will take flights.yml. So if your application name you are configuring as hotels, if your application name is hotels, then in the GitHub repository, there should be one YML file with a name called hotels.yml. If your microservice name is trains, then in the GitHub repository, there should be one YML file with a name called trains. Trains.yml file will be available. Our microservices will get the configuration properties from the config server, and the config server will get the properties from the GitHub repository. So as you see in the diagram, our microservices are going to get the properties from the config server based on the name of the microservice, and the config server will get the property files or YML files from the GitHub repository. Now, if you implement this kind of approach in your application, then what is the benefit we are getting? What is the advantage we have in this approach? Guys, what is the advantage we have in this approach?
Deployment. Loosely coupled.
Application will be loosely coupled from the properties. Application will be loosely coupled from the properties. So what is the meaning of loosely coupled? Tomorrow, if we make any changes to our YML files, do I need to redeploy the entire application? Do I need to perform this process again if there is any change in the properties file? Guys, if there is any change in the properties file, do I need to redeploy this application or I no need to redeploy this application?
No need to redeploy.
Do I need to redeploy this application or I no need to redeploy this application?
No need to redeploy the application.
We no need to redeploy our application because earlier our properties are available within the project. Now we are separating the properties from the application, so we no need to redeploy our application. Okay, so we are trying to understand what is config server and why we need to go for config server in our application. So for every project, some properties configuration is required. Those can be database properties, those can be SMTP properties, those can be Kafka properties, or those can be application messages also. So as of now, whatever we are doing, the properties files, YML files, we kept inside the project only. If you keep inside the project, package, when we keep the properties file, YML file within the application, when we package our application, that jar file will contain the properties file also. If you want to make any changes, then we need to rebuild and redeploy the application. So that is a time-taking process. This much process will be available in order to build and deploy the application. So if you make a minor change also, you need to perform everything again and again. So which is a time-consuming process. So to avoid this problem, we are going to separate the properties from the application. For that, we are going to use config server concept. So cloud config server is part of Spring Cloud library. How that config server concept will work? If you see in the diagram, whatever the microservices are available, for every microservice, we will assign some name. And these microservices will register with the config server. Config server is another microservice. And the config server will load the properties files from the GitHub repository. So what we need to do now? First, we need to understand how to create the config server and how to register our microservices with the config server and how to keep our YML files in the GitHub repository. Okay, so first let's understand how to develop a config server project. So developing config server. So first, you need to create one Git repository for your microservices related configuration files. Create a Git repository and keep YML files required for the microservices. Create Git repository and keep YML files required for the microservices. So we should keep the file name as a application name. When you are creating the YML files in the Git repository, you need to keep your file name as application name. So if your application name is greet, then file name should be greet.yml. If your application name is welcome, then the file name should be welcome.yml. So like this, you need to create one Git repository and you need to keep your YML files in the Git repository. I'm having one Git repository. You can also use the same Git repository. So if you go to this Git repository, I kept two YML files in the Git repository. One file name is welcome.yml, another file name is greet.yml. So here welcome.yml file available, message welcome to Ashok IT is available. And there is a file greet.yml is available, message is available as a good morning. For other microservices also, suppose some report service is available, all my configuration I kept in this file. So like this, for every project, one YML file we are going to maintain. So currently here, welcome.yml, greet.yml is available. So in these YML files, one key value is available, message. In the welcome file, welcome to Ashok IT is available. And in the greet YML file, the message is available as good morning. So my GitHub repository is ready. So the first step that what you need to do, if you want to work with the config server applications, then you need to create a Git repository and you need to keep the microservices related configuration files in the GitHub. And you need to make sure whatever the file you are keeping, that file name should match with your microservice name. So the application name should match with the YML file name. So once it is done, then create the Spring Starter application with a config server dependency. You need to create one Spring Boot application, and for that application we need to specify cloud config server dependency. So let me create the application, file, new, Spring Starter project. So this project name I'm specifying as 07. I'm specifying the project name as 07 cloud config server. Specifying the application name as cloud config server. Now we need to select the dependencies here, guys. So what is the dependency? Config server. I'm selecting DevTools dependency and I'm selecting config server dependency. Cloud config server. Yes, config server is available. Config client is also available. So I'm using config server dependency. Click on next and click on finish. Cloud config server dependency I have selected, and once the project is created, now you need to write one annotation, enable config server. Enable config server annotation we need to specify at the boot class, start class. So first set up your GitHub repository with all the YML files required for your microservices. Then create a boot application. Create a boot application with the below dependency. So that is cloud config server. Cloud config server. And I have added DevTools also. If you want to restart the server, then I added DevTools dependency also. Config server dependency we have added. So once we created that project, then we need to add this annotation at our boot start class. Go to config server. You check the pom.xml file. Go to config server. You check the pom.xml file. So cloud config server dependency is added and DevTools available, guys. That's it. So Spring Boot 3.3.3 version, Java 17 version. And go to this start class and write one annotation, that is enable config server. Writing one annotation called enable config server annotation we are writing. So with this, our config server is ready. Now we need to tell to this config server, we need to tell to the config server from which repository it has to load the properties. Okay, go to the YML file of this config server. Properties file is available. I'm changing that properties file to YML file. Properties file is changed to YML file. So this is our config server application. So config server application port number, I'm configuring server.port. Server.port. I'm giving some port number for the config server, something like this, 9093. Some port number I'm giving for the config server, and this config server should load the property files from the GitHub repository. From which Git repository it has to load the properties. So I need to specify that. For that we will use spring.cloud.config.server.github. I want to load the properties from the GitHub repository. Okay, cloud config server.github.URI. What is the URI? What is your GitHub URI from where you want to load your properties? Cloud config server git URI. So this is the URL of my GitHub repository where my configuration properties are available. Git URI, clone unstart. Okay, clone unstart that you can specify. So whenever the application is started, then immediately it is going to clone that GitHub repository. It will take the properties from the GitHub repository. So management security enabled false that we are going to specify, that is optional. Just management dot security we'll add that later, we'll see that. So currently we are configuring application name and we are configuring our GitHub repository URL. So config server should load the properties from the which GitHub repository, that URL I specified, and I configured some port number for this config server application. Okay, Spring application name, cloud config server git URI we specified, and server port number also we have configured. Then what is the next step? Config server application is ready. Let us run the application, run our config server application, and let us see. Write these properties, configure below properties in the YML file. So what are the properties we are writing in the YML? A name is available for the config server and GitHub repository. From which GitHub repository? It should load our YML files. We are specifying that, and port number also we are configuring. Once it is done, then run our config server application. Once it is done, then let us run our config server application. Okay, let us see, is it going to work or not? Refresh, run as boot application. I'm running my cloud config server application. Yes, the application is started with embedded Tomcat container, and it is running on the port number 9093. So very good. Our config server is ready. Next, we need to develop our config client, our microservice we need to develop. So our microservice is going to register with the config server. Config server is connected with the GitHub repository. Now our microservice will be available. Our microservice will register with the config server in order to get the configuration properties. So how to develop our config client development? Okay, so that means we are going to develop one microservice. That microservice we are going to act as a config client. Okay, so create a boot application with the web starter, config client dependency, and a DevTools dependency we are going to specify. Then create a REST controller. Create a REST controller with the required methods. Then configure config server details in our YML file. Run the application and test it. So we are going to run the application and we are going to test it. That means I want to develop one microservice which is going to act as a client for the config server, and based on the name of microservice, it should get the message from the config server. So if you see in our GitHub repository, YML files are available. Welcome.yml, greet.yml files are available. So welcome.yml, if the microservice name is welcome, then it will load this message from the welcome.yml. If that microservice name is greet, it will load the greet message, which is good morning. Now let me develop our client application. File, new, Spring Starter project, 08, config client application I am developing, cloud config client. Click on next. Now, what are the dependencies? DevTools dependency, web starter I am using, and config client dependency I am adding now. It should get the properties from the config server. So I'm adding config client dependency, and if required, you can add actuator also, right? DevTools, actuator, config client, and web dependencies I'm adding. Click on next and finish. Now, what we are going to do in this application? The project is created. The project is created. Now we need to create the REST controller with the required methods. We need to create a REST controller with the required methods. So let me create one REST controller in this project. Now I'm going to create a REST controller. So .REST package is available. So I'm creating a REST controller, which is message REST controller, So how to represent this class as a REST controller? To represent this class as a REST controller, we are going to use one annotation called @REST controller. Annotation will be available. So we are using one annotation called @REST controller. Now, inside this REST controller, we can write the methods and we can read the properties. We can write the methods and we can read the properties by using this REST controller. Now, so what is the logic that we need to write in the REST controller? I will write one variable which is private string message. So from where we need to read this message? From the YML file. So if you see in the YML file, key message available. I want to read that key. For that, we will use a annotation called @value annotation $of message. $message. So this is used to read the property from the YML file. But that YML file is available in which location? Is it available in our project? Is it available in the GitHub repository, guys? The YML file is available in our project, or the YML file is available in the GitHub repository. Whatever the message we are reading, that message is available in the YML. That YML file is available in our project, or is it available in the GitHub repository? That YML file is available in the GitHub repository. That YML file is available in the GitHub repository. Are you guys able to follow me? Now, let me write one method here, public string get message. Okay, whatever the message is coming from that, I'm going to return that same message. Whatever the message is coming, I'm going to return the same message. So I'm not writing any fancy logic here. I'm just getting the message from the YML file and I want to return that message. Let me map this method to a GET request by using @get mapping and URL /. That's it. So this is our client application which is expecting the message from the YML file. That YML file is available in the Git repository. That Git repository will be taken care by config server. Our microservice will act as a client for the config server and it should get the properties from the config server. Are you guys able to follow me? What is the purpose of this value annotation? Which is used to read a property from the properties file. Are you clear? Which is used to read the property from the property file. It is used to read the property from the property file. It is used to read the property from the property file. Are you clear with my point? But where is the properties file available? Is it available in our system or is it available in our project or is it available in our project or is it available in GitHub repository? It is available in the GitHub repository. So that means our project should register with the config server. How to register our project with the config server? Okay, good. So to register our project with the config server, we will make some changes in the properties file. Let me convert this properties file to YML file. Application.properties file is converted to application.yml. So this is the name. We should give the name as welcome. Then it will read the welcome.yml. So I'm giving the application name as welcome so that it will read the welcome.yml. If I give the name as greet, then it will read the greet.yml data. If I give the name as welcome, it will read the welcome.yml data. So configure some port number for this one, server.port number. Default port also we can use, no problem. Server.port we are using. Server.port is equal to some 8081, or if you don't configure also no problem, default port will work. Now let me specify config server URL. where is the config server available? Spring.config.import. Spring.config.import. Config server URL we are going to specify optional config server http://localhost:9094. 9094. So where your config server is running, what is the URL of the config server you need to specify, and your application name you need to specify. So what is the meaning of that? So we are trying to give that, where our config server is available, its URL. Config server running on which port number, guys? So if you see, our config server port number is available as 9093. Sorry. So our config server port number is 9093. For the client application, we are telling the URL of the config server. That means our microservice is going to communicate with the config server. Based on the application name, config server will give the YML file to our microservice. So we are separating our application source code and our application properties. Earlier, properties are available within the application. Now the properties are separated from the application by using config server concept. So I created one microservice, and for this microservice, I have given the name as a welcome, and I have given the config server URL. So what is the meaning of this? My microservice will communicate with the config server, and config server will understand my microservice name is welcome. Then config server will go to the GitHub repository and it will identify, is there any file available for welcome microservice? Yes, welcome.yml is available. So it will load the welcome.yml file data into my microservice. In that welcome.yml file, there is a key available message. That message key value is welcome to Ashok IT. So I need to get welcome to Ashok IT into this variable that I am sending as a response. So if my microservice name is welcome, it will get welcome to Ashok IT message from the welcome.yml. And if my microservice name is greet, it should get the greet YML file data into our microservice. Now let me run my client application. So let us see. Our config client application is able to communicate with the config server, able to fetch the messages from the YML file, which is available in the Git repository or not. Let's try to understand. So if you observe, do I have any key called message in our YML file? In my client application, is there any message key available? No. Client application is having config server URL. Okay. And config server application is having GitHub repository URL. Inside that GitHub repository, my YML files available. Welcome.yml, greet.yml. Now I will run my client application and I will check, am I able to get the message from config server or not? So in my REST controller, I have taken one variable to understand from which YML file the data is coming. Key is message. In both YMLs, same key available, but values are different. Let me run my client application, run as boot application. Application failed to start. The spring.config.import property missing a config server entry. Add config spring.config.import config server property to your configuration. Spring cloud config enable is equal to false. Check enable. If configuration is not required, add spring config import optional config server instead. Spring.config.import optional config server. To disable this, check if configuration is not required, spring.config.import optional config server. Sorry, there is a spelling mistake in the YML file, guys. Server, config server. It was typo. Yeah, refresh your application, then run this application, run as boot application. I'm trying to run my client application. Config server is already running. Now I am running config client. Yes. Config client application is getting started. Yes. If you see the console, the config client application fetching the config server from 9093. I configured config server URL in the client application. So local environment name welcome it is taking. So default profile it is taking. The client application running on the port number 8080. Actuator is enabled beneath the base path. Actuator enabled. Now application is running with 8080 port number. Now let me show you the console of the config server. In the config server console, if you observe, adding property source YML via location, the config repository. Once my client application is started, config server is fetching the properties from the GitHub repository. Okay, client application started. So client application is having the URL of the config server application. Config server is having the URL of the GitHub repository. Now let me access our microservice. Microservice name is welcome. Localhost colon 8080. Just send the request. Am I able to get the message? Welcome to Ashok IT. But actually, where is this message configured, guys? This message is configured in the GitHub repository welcome.yml. The key is message, value is welcome to Ashok IT. Now, when I access my REST controller getting the message from where? It is getting from the config server. How the config server is giving only this file message? Why not greet message? Depends on the application name. Now, if I change my application name from welcome to greet, if I change my application name to greet, and if I restart my application, now you check it. So if I restart my application, now I am changing the name to greet. Now let me run this microservice. Based on the application name, it will understand from which YML file it has to get the data. From which YML file it has to get the data, that it depends on the name of the application. Earlier, my application name was welcome. So it loaded welcome file message. Welcome YML message it loaded. Config server loaded welcome YML message. Now I changed the application name to greet. Now send the request again. Now we are getting good morning. So with this, are you able to understand? Config server loading the data from the YML file based on name of the application. If the application name is welcome, I'm getting one message called welcome to Ashok IT. If the application name is greet, then I'm getting a different message, good morning. Why that difference is there? For the application name welcome YML file is available. For application greet YML file is available. So now my application loading the properties from the config server. So my microservice is acting as a config client. It is loading the properties from the config server. Config server loading the properties from the GitHub repository. So can we say our application is loosely coupled? Can we say our application is loosely coupled from the configuration properties? So currently in this YML, I just configured a message, key value. Okay, so database properties, SMTP properties, application messages, you can configure. You can see one of the YML auth service. So admin client URL, data source details, JPA details, actuator details, application message like this. Everything we will keep in the YML file. That YML file is available in the Git repository. If your microservice name is auth service, then it will load this YML data. If your microservice name is a cart service, it will load the cart service YML data. Here, cart messages, data source properties are available. Order service is available. So when microservice name is order service, then it will load the data from this YML. Payment service available, product service available, report service available, like this. Based on the name of the microservice, it is going to load the YML file data. So tomorrow, if I make any changes to this YML file, do I need to redeploy my microservice or not required? If I make any change to my YML file, do I need to redeploy my microservice or it's not required? It's not required. Why we no need to redeploy? Why we no need to redeploy? Because YML file is not in the project. YML file is available in the GitHub. How these YML files are loaded into our project, guys? Who is loading these YML files into our project? Programmer is loading or config server is loading? Programmer is loading these YML files into our project or config server is loading these YMLs into our project? Config server loading these YMLs into our project. Okay, so this is how you are going to configure the config server details in the YML file. So this is our REST controller that what I have created. So in this REST controller, I'm just getting a message key and that value is stored into a variable and that variable I'm returning as a response. How I developed my configure client application. I created one boot application with these dependencies, web starter, config client and dev tools. Then I created one REST controller with the required methods. Here I am getting a message variable. Then I am giving the URL of my config server in the client application. Then I am running the application and I am able to access my method. If my application name is welcome, it will load the data from the welcome YML. Welcome message will come. If I give the application name as greet, then it will give the greet message. Like this, in the real time, multiple microservices will be available. For every microservice, a separate YML file will be available. One thing that you need to remember, our whatever the name we are giving for the microservice, whatever the name, application name we are giving, that name should match with the file name. Then only config server will understand for which microservice, which YML file should be loaded. So if your application name is flights, the file name should be flights.yml. If your application name is trains, it should be trains.yml. If it is hotels, it should be hotels.yml. If it is order service.yml. If you see in my GitHub repository, auth service YML, cart service YML, and payment service YML, product service, report service. For e-commerce application, I created several YML files in the config server. So in the JRTP major project, we are going to develop e-commerce application. For that e-commerce application, several microservices available. For every microservice, a separate YML file I have created in the GitHub repository. So these YML files will be loaded by my config server. My actual microservices will load the properties from the config server. So my microservices are loosely coupled from the config properties. Any database property, SMTP properties, Kafka, Redis, those properties are in the GitHub repository. My microservices are loosely coupled. Tomorrow, if any changes required for the properties, I no need to redeploy my microservice. I no need to redeploy my microservice. Are you clear with my point? Now I am giving you one task. If I change a property in the GitHub repository, will it reflect automatically or it will not reflect automatically? So my GitHub repository is available. So welcome.yml, greet.yml is available. So here I'm giving a message, welcome to Ashok IT. Welcome to Ashok IT software training. Now I am updating the message in the GitHub repository. If I update this message in the GitHub repository, will it directly reflect in our application or it will not reflect in our application, guys? The file application name is welcome. So in the welcome to Ashok IT is available. Okay. Now, if I update this application, if I update this property, will it reflect in the client application or will not reflect? Will it reload the changes in the properties file? Is my application going to reload the changes in the properties file or it will not reload the changes in the properties file? It will reflect, it will not reflect. Directly it will not reflect. Okay, let us see this. First, welcome application we are loading. Welcome to software training. My client application started. Now I will go and change the property file. Welcome to Ashok IT software training institute. Welcome to Ashok IT software training institute. Okay, Hyderabad. Something like this. My application started, the message is coming like this. Software training is coming in the bracket. After my application started, I modified a message. I am giving the message Software Training Institute, Hyderabad. Update this file in the GitHub repository. After updating this file in the GitHub repository, let us send a request. Updated message is coming, old message only coming. Whatever the change I have done in the YML file, is that change reflecting in the client application or the change not reflecting in the client application? Then what we need to do to reflect? Is it loading the latest messages from the Git repository, or it is not loading the latest messages from the Git repository? Is it loading the latest messages from the Git repository? It is not loading latest messages from the Git repository. Then what we need to do in order to reload the changes from the Git repository in our microservice? There are two ways. You need to restart the application. You need to restart the application. Or what is the another approach? Two ways we can do. If I stop and start my application, then latest properties will be loaded, but which is not recommended. Which is not recommended. So if I stop and start the application, latest properties will be loaded. But in the real time, is it recommended to stop and start the applications? Is it recommended to stop and start the applications? No. Then what is the alternate? To reload the latest properties. Without restarting the application, it should reload the latest properties. It should reload the latest properties. Can you do some analysis on that? Can you do some analysis on that part? How to reload the properties? How to reload the properties dynamically? How to reload the properties dynamically? Come on, guys. How to reload the properties dynamically? I will give the clue. By using actuator, we can achieve that. By using actuator, we can achieve that. Without restarting the server also, we can reload our properties. Without restarting our application, we can reload our properties by using actuator. Yes or no? You understand what is the problem we are facing now? We are able to achieve loosely coupling. Our properties are separated from the project. Our properties are separated from the project. But what is the problem we are having now? What is the problem we are having? It is not reloading the properties. It is not reloading the properties. So how to reload the properties when there are some changes? When there are some changes, how can we reload those properties? When there are some changes available, how we can reload those properties? When the application started, whatever the properties are available, it is taking those properties. But after my application started, there are some changes to the GitHub repository. There are some changes in the GitHub repository. Those changes are not reflecting in my client application. Those changes are not reflecting in my client application. So what we need to do for that? Yeah. So the applications are not loading the changes. So what we need to do in order to reload the properties? You got any solution, or shall I tell the solution for that? You got any solution, or shall I tell the solution for that? Yeah, so the solution is very simple, guys. We need to do three things in order to reload. How to reload? How to reload properties dynamically? How to reload the properties dynamically? So when I change the property in the GitHub repository, it is not reflecting in the client application. So you need to stop the project, then only the property will be loaded. So how to reload the properties dynamically? Now let me show you how to reload the properties dynamically. First one, configure refresh scope annotation at REST controller class. And the next one, enable actuator endpoint, which is refresh. Third one, send post request to actuator endpoint refresh from the postman. So in order to reload the properties dynamically, how to reload properties dynamically using config server? So what you need to do is you need to make 3 changes now. If you make these 3 changes, then your properties will be reloaded dynamically. So first thing, configure refresh scope annotation at the REST controller. So this is our REST controller. Here, let us write one annotation called @refresh scope annotation. We are writing an annotation called refresh scope annotation. Then go to YML file. Inside this YML file, in the client YML file, you need to enable actuator refresh scope. How to enable that? Management dot endpoint dot endpoints dot web dot exposure dot include you need to include one endpoint which is called refresh. You need to enable one endpoint called refresh endpoint. Okay, that's it. So which application want to reload the properties? In that application REST controller, you configure one annotation called refresh scope annotation, and in that client application YML file, you configure this actuator refresh endpoint. That is the reason when I am creating the client application, I added actuators dependency also. Okay, so when I am creating the client application, I have added actuator dependency also, so that we can reload the properties dynamically without restarting, without redeploying the application. So what is the change I have done? I configured annotation called refresh scope annotation, and I configured refresh endpoint, actuator endpoint I have enabled. That is a post method endpoint, guys. Now let me run this application, refresh the project, run as boot application. I'm running my project. First, let me access the existing message. Then I will change the message and I will reload it. Yes, my client application is started. Clear this. Go to this application, access. The message is coming as welcome to Ashok IT, guys. The message is coming as welcome to Ashok IT. Go to this properties file, edit this. Welcome to Ashok IT available. So I'm writing software training institute. Very good. I'm updating this message in the Git repository. When I update this message in the Git repository, when I send the request, is it loading the latest message from the Git repository? It is not loading the latest message from the Git repository. Guys, is it loading latest message from the Git repository? Not loading the latest message. It is not loading the latest message. So then what we need to do? We need to refresh. How to do the refresh? Actuator refresh we enable. Localhost colon 8080 actuator refresh. Send it. I have sent the request in order to refresh. So configure client, okay, 200 response, okay, refreshed. Now send the request again. Now are you getting the latest message now? After refreshing, are we able to get the latest message? Did I restart my server? Am I restarting my server? Without restarting my server, am I able to access? Am I restarting my server? Without restarting also, I'm able to get the latest messages. Yes, can I show you once again? Yeah, so there is a spelling mistake in the message. Okay, let me correct it. Ashok IT Software Training Institute, Hyderabad. Yes, I corrected the spelling mistake and I added Hyderabad, commit it. I made the changes to the Git repository YML file. Now send the request. Still we are getting old message only because property files are not refreshed. How to refresh the property files? We already configured actuator refresh endpoint. Now go to your Postman. Localhost code. This is client application URL. Configure client URL. Actuator/refresh. Send a request. So this request is used to refresh the properties from the config server. Yes, we are able to do the refresh. Once the refresh is completed, send the request. Now, am I able to get the latest message now? So do I need to restart the servers? Do I need to redeploy the application if there are any changes in the properties file? Not required. So now tell me, keeping the properties file in the config server is recommended or keeping the properties file within the application is recommended? If I keep the properties file within the application, can we achieve this? If I keep my properties within the application, can we achieve this loosely coupling? No. So in the real time, in every project, this config server concept will be used so that our application will be loosely coupled from the properties. Now, practically we are able to see the application, our microservice connected to the config server. Config server is connected to the GitHub repository. Our microservice related YML files are available in the GitHub repository. So our microservice will connect with the config server URL. Config server will connect with the GitHub repository URL. Based on the name of the microservice, it will give the YML file from the config server. If any changes happen to the YML file, so you can use actuator refresh endpoint and we can reload the latest data from the YML file. So we are able to do that. So how we are able to reload those YML file data? Configure refresh scope annotation at the REST controller class level. Enable actuator endpoint refresh. How to reload config properties dynamically. So we need to make below 3 changes in the config client application. We need to make below 3 changes. To reload latest config props. Okay. Configure refresh scope annotation at the REST controller class. Then enable actuator endpoint called refresh. Then send post request to the actuator endpoint refresh from the Postman. Then after refresh, check your application giving latest data or not. Test your application. After refresh, test your application. So before refreshing, I was getting a different message. After refresh, I'm getting before refresh, old message was coming. After refresh, the latest message is coming. So if you are having admin server, so this actuator refresh endpoint you can access from the admin server also. You don't need to send it from the Postman. So if your application is registered with the admin server, then this refresh endpoint you can access from the admin server also.